Num 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 num. 1, 2, 3, 4, 5. Waiting for the YouTube. Num 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 num. Waiting for YouTube. For the YouTube. Num 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 num.
YouTube
Waiting for
seems to be fine.
YouTube. Notifications. Most corrupt prime minister. MAGA racist had no idea he is a disgusting hate fueled bigot. Um, dark side of Pern. This is interesting. 1 plus 1 equal to 2. Okay. Okay, let's watch it.
One plus one equals two. Or does it? Alright, enough with the Vsauce impressions, but seriously, let's take a closer look at the classic and seemingly basic equation. Is 1 plus 1 really equal to 2? Or is something missing from our logic? Let's look at a simple example. First off, meet Alice. Now, take a second. Count the number of people on your screen. You're probably thinking, easy, that's 1. And yes, you'd be absolutely right. Now, say hello to Bob. Take another count. 2 people on the screen, right? Simple math. 1 plus 1 equals 2. But wait a second. If Alice is 1, does that mean adding Bob makes exactly 2? Think about it. If 1 plus 1 is the same as 2 times 1, we would need 2 Alices to truly say we've got a pair. But instead, we have Alice and Bob, 2 different people. Is that really the same as 2 identical Alices? Or does the simple math miss something bigger? Maybe 1 plus 1 isn't as straightforward as we thought. Let's take a closer look and figure this out together. First off, let's take a journey back in time, as we are far from the only people to have wondered about this problem. We are heading to ancient Greece to meet one of the greatest philosophers of all time, Plato. Now, Plato had an interesting take on numbers. He saw them as an absolute, unchangeable truth, existing entirely independent from the physical world. According to him, everything in the universe fell into 2 categories, the material and the immaterial. The material world is everything we can see and touch, your dog, your cat, your own body. But numbers, they belong to the abstract, immaterial world. They exist beyond the physical, untouched by reality. Let's explore that with a simple example.
So this distinction is not so clear. I don't know. I mean, I don't know what he means. Like, this is not a person, this is just an image of a person. So I would say this is immaterial. This is not a cat, just, this is not a dog. Nothing here is real. This is all immaterial. It's no different than these numbers. How are these numbers different than these concepts? Now you could say, well, but what about an actual person? Yeah, I would always say that actual person is in your mind. That actual person is just what you perceive as an actual person. So it's always in your mind. So there's no difference between an actual person and some number. So everything is the same. These are all just the same. Whatever anything is. There's no distinction between 0, 6, and this image of a puppy and so on. But let's continue.
They exist beyond the physical, untouched by reality. Let's explore that with a simple example. Look at this blue sky. How many clouds do you see? 2, right? So 1 plus 1 equals 2. But suddenly, the wind starts blowing, making those 2 clouds slowly drift towards one another, finally merging into 1. Suddenly, 1 plus 1 doesn't equal 2 anymore. It equals 1, although maybe a bigger one. If someone were to start watching this video right now, they'd only see a single cloud. Yet we know there were 2 before. This is where Plato's thinking comes in. Numbers like 1, 2, or even 1 plus 1 don't depend on what happens in the material world. They exist as their own truth, separate from the physical things they might represent. So while in real life 1 plus 1 could become 1, in the abstract world of numbers, 1 plus 1 will always equal 2. It's a reminder that our understanding of math doesn't always match up perfectly with the way things play out in the real world.
So when you say 1 plus 1 in the world of math will always equal 2, that's just you saying that. That's you asserting that. I can say the opposite. I can say 1 plus 1 will never equal 2. Just like you asserted true, I can assert false. Why is your assertion better than my assertion?
1 plus 1 will always equal 2. It's a reminder that our understanding of math doesn't always match up perfectly with the way things play out in the real world.
What is the real world? What is that? Right? I would say it's always all in your mind, and there is no distinction between the mathematical world and the so-called real world.
However, Plato's own student, Aristotle, another renowned philosopher, disagreed with him on the nature of mathematics. While Plato saw numbers as abstract truths or objects existing beyond our world and maybe beyond our understanding, Aristotle had a very different view. He argued that numbers aren't some otherworldly concept floating out there in the realm of ideas. No, numbers are how we see them, and they help us in describing the world around us. Taking a look at our cloud.
No, I wouldn't say numbers are very
No,
real. What did he
numbers
say?
are how we see.
No, they're not very real. Everything is in between. Everything is in our mind. This universe exists only in my mind. So it's all in my mind. That's it. Well, I don't know what else to say.
See them, and they help us in describing the world around us.
In general, I can understand that 1 plus 1 is 2. In general, sometimes, like in the cloud example, 1 plus 1 is a bigger 1. Yeah. And I see a picture of Plato, I guess, and Aristotle, I guess. All right. So just like I believe 1 plus 1 is 2, I believe that I'm seeing this picture and this picture. That's it. It's just all in my mind. And how comfortable am I with any expression? I'm comfortable that this might be Plato. I'm comfortable that this might be Aristotle. I'm comfortable that in this story that we're being told, I have no reason to doubt that this is maybe what Plato looked like. 1 second. I have a visitor. Hello, visitor Amber. What's up? Hey.
I'm getting ready for my dog's appointment. She has like a groomer coming over.
Oh, nice. Very nice.
I've never had a groomer make a house call, so this is really cool.
Wow. What do you mean groomer? So like a haircut?
She's gonna do all of it. She has to cut her nails too.
And bathe her?
I guess she's gonna just wash her in the shower. Yeah, that's what they said. But like,
They don't come with their own van that has everything inside?
they might. I'm not sure what's going on. I've never had this service done before, so we'll see.
Because I mean, it makes more sense that they would
A
come with
van would make sense.
Yeah, I mean that would be the simplest. I mean, like to wash a puppy in the shower, that's like a nightmare.
I mean, I've seen like assisted devices for it, but like I'd rather not have to do it. That's why I
Yeah,
paid someone to do it in the first place.
definitely.
Because like I hate doing that. Like we've given her baths before, but like it's hard, and then he just picks her up in the shower.
Mm-hmm.
I have no interest in that.
Very good. So, I actually discovered an amazing server yesterday. I was like I discovered, I think, 2 servers yesterday. One of them
Awesome. What was it?
no, but one of them banned me almost within the hour, and the other one laughed at me for like an hour. But both were really great experiences. So one of them was an ether, no, not an ether, a flat earther server, but they banned me.
Yeah.
I think they were an ether server. I think they were also an ether server, and they banned me. I was apparently asking too many difficult questions.
That's annoying. They're always like that in those servers.
Yeah.
But then like the server itself will get taken down because I guarantee you in a few days there'll be some sort of like jab related like weird post and then it will get taken down because that happens every time I'm in one.
Hmm. It doesn't matter. I mean,
Yeah.
it was, an interesting experience. Anyway, and then I went to the other server, which is an anti-flat earther server. It's called the Globe Gangsters.
Oh, I remember that one.
Right. Oh, you
I
were
got
there?
banned from that. I got
Mhm.
banned from that server. Yeah. First of all, it got nuked for literally exactly what I was talking about. And then when it went back up, I got banned because someone talked about how much they hate vegans, and I was like, "Leave me the fuck alone."
Mhm.
And and then they were like, "Why don't you just eat a fucking baby?" And I was like, "Yeah, whatever." And then they banned me because apparently I was talking about eating babies, but it was like what the other person was doing. So I don't know. It's just
Mm,
random, stupid
mm,
bullshit.
mm. I see. Anyway, but no, on Globe Gangsters, there's like a bunch of actual physics experts that I really enjoyed talking to, and I showed them all my papers, and they made fun of the papers, but they also gave me like actual productive reviews. They did basically peer review, quick peer review, and they said exactly the issues. So it was productive, but it was really funny. I was cracking up like crazy. I couldn't breathe. It was so funny.
Nice.
Yeah, but I presented to them my ether theory, and they said, "Oh, then you have nothing new to say because basically you're agreeing with all of big physics except for you're renaming things to your ether. It's just a renaming. That's all you're saying is that you're renaming things, which is boring." But they also said that everything I'm saying is completely a complete contradiction to big physics. So they said both. They said both that I'm completely not revolutionary and that I'm completely revolutionary. And apparently they didn't even see the contradiction in the positions they took. But it's fine. It was a very productive for me. It was a very productive time. Both having fun and talking to smart people was good.
Nice.
Yeah.
Hopefully they let you back in or clear something up.
I mean,
I feel like it's always just like one person has like mod powers and then fucks the server up and then like someone finds out and they take it away.
look, the owner of the server was the guy that came in like 2 days ago, or yesterday. I don't remember. I think it was 2 days ago. His name is Lion Sea Lion. Anyway, he was on my server for like 2 hours, and we had a lot of conversations. And so that's the owner of the server. So I'm good friends with him, and he's about to do his PhD in mathematics, and he's like the rest of them. He's very smart, very knowledgeable. He liked my theory. He saw my theory. He saw the papers. He understood it right away, and he liked it. So Anyway, it was a very interesting day. Yesterday was like a 7 hour stream. When I finished, I was starving. I went to eat, and basically I was completely knocked out. I couldn't continue. I just laid on the couch and rested for a couple of hours and then went to sleep.
Sounds like a good day, honestly.
Yeah, it was a very good day. Like I was completely knocked out. It was, I mean, and the criticism they gave me was good. I mean, It was like a little bit of a punch to the stomach, to the gut. It was very difficult to hear the criticism. But after thinking about it and thinking, I came to the conclusion slowly, to the realization that I have something important to say, and it would be very beneficial for me, for the world, to hear my discovery. So that's it.
Good for you, dude.
Yeah. So I mean, I'm gonna continue writing my papers. I think they're all very, like, let's say if I could have read my papers a long time ago, it would have been better for me. Like, if I could have read my papers before I came up with these ideas, I would have said, "Oh, fantastic! This simplifies everything so much." My ether theory simplifies big physics. Like, big physics is very confusing, and my ether simplifies, agrees with, yet simplifies big physics. Anyway, so that was my day. What are you gonna do now until they come?
I don't know. I lit a candle and I'm just like sitting on the couch vaping. I smell like vanilla because I took a shower.
But a candle is very
I'm
dangerous.
just trying to relax.
Are you
No, it's
protected?
not.
I mean, candles is how many fires start. Just,
Well, duh, but people are stupid with them. It's not around anything. It's just like a big candle.
Okay, just be careful.
The wider the base, like the less dangerous it is.
Sure. But still, it's fire. I mean, like, if you leave it there, let's say something happens to you, like, it's gonna take it a couple of days to burn through, right? Yeah?
I could probably burn this through tonight. It's like the end of it.
Oh. What happens when it reaches the end?
I'll just like blow it out.
No, but let's say you're not there when it reaches the end.
Well, I'm not gonna leave it on when I'm not here. That's retarded.
But let's say something happens to you and you don't and you get knocked out or something. You black out and you wake up at like
It'll burn all the way to the end and then self-extinguish. Like it'll do that.
is the container made out of glass, or what is the
Yeah, it's like a thick glass. It's really thick. I'm probably gonna clean it out and save it because I might use it for her water.
Okay. Anyway, just be careful. Like, when I light candles, I'm really worried. I'm always worried.
I'm worried when I'm on like psychedelics. I don't like to have candles going, but if I'm just in the house, there's no reason not to. Because I always have a table I'm not using, and I have a lot of free space. Since this isn't my house, it's like an Airbnb, so I can just put it pretty much anywhere and it would be safe.
Mm-hmm.
So I just put it on my table and I scoot all the chairs in so my dog won't get on the table.
Mm-hmm. Very nice. Very nice. Anyway, I'm gonna continue doing my review. I'm reviewing somebody's video.
All right, dog. I'll talk to you later.
I'll talk to you later. Bye. All right, so we was somewhere here. Let's continue.
Taking a look at our clouds example again. According to Aristotle, at one moment there were two clouds, and in another there was only one. Simple as that. Numbers, to Aristotle, aren't objects in some mystical realm. They're more like adjectives, describing the world in a way that makes sense to us. Let me give you another simple example to illustrate this fact. Consider the human body, then take a look at this statement. Every human has two eyes. Now, according to Aristotle, this two isn't some abstract or mystical concept, but rather just an adjective, which helps us define real-world objects, such as in this case, eyes. So, in Aristotle's view, numbers are deeply connected to the material world. They don't exist on their own, but instead are part of how we understand the things around us. This view, held by Plato and
So people get confused by math. People think math is something different than anything else. So math is just a language. Like, it's just a language. It's a part of English. Well, it's a part of English, it's a part of Spanish, right? You could say you could talk in math in Spanish. You can talk in math or write math in English or any other language. So, but it's its own language, but it's just a language. You could say that 1 + 1 = 2 is not math, it's just English. Well, you could say it's both, but you could look at it as it's just it's just a descriptive statement in English. So to say, like some people say, oh, the universe is mathematical. Well, you could say that the universe is English or the universe is Spanish by the same logic. So I would say the universe is, it is what it is, and we can describe it using English. We can describe it using that language called math. We can describe it in a language called physics or chemistry. We can describe the universe in any language, in languages that evolved to describe the universe, right? So English evolved in order to describe the universe. And mathematics evolved in order to describe the universe. We evolved in order to describe the universe. That's our evolution. We evolved in order to describe the universe. We evolved in order to exist, to transfer our genes. Right? Whatever the words in order mean. I mean, what does it mean in order? I mean, the universe didn't produce us in order to do anything. We're just a matter of fact in this universe. There is no reason in this universe. This universe, as far as we know, has no reason. It's just basically random.
And his followers is referred to as Platonism, whereas the view held by Aristotle and his followers is referred to as human-centered. As
I don't even know the difference between their positions. So what's the difference between their positions? I didn't get that there's a difference.
it rejects the notion of infinity, embracing the finite way in which humans work.
We need a human-centered view. What do you mean we need? I don't understand. So I don't see the difference between them.
These contrasting views held by Plato and his own student Aristotle just highlight the deep nature of mathematics and all its branches.
So he said math is deep. No, nothing is deep. I don't know what the word deep means. And I don't know what the word math means. You could say English is deep. Is English deep? You could say English is deep. You could say whatever you want. But I don't know what you mean.
But what does all this mean for the big question? Does 1 + 1 = 2? Well, the answer is it depends.
That's like asking, is the sky blue? Well, it depends. Do you want it to be blue? I don't know. Do you want me to say that it's blue? I mean, is it blue? What is the sky? I don't even know what the sky is. Right? In my room right now, is this the sky? Is it not? Am I the sky? What is the sky? You can, however you define, and also what is blue, and so on. So I don't know. So at the end of the day, what do you want it to be? I'll say whatever you want me to say.
For an average person, the answer would be yes, absolutely. 1 + 1.
Right. So yeah, for the average person, as I say, in general, yeah, 1 + 1 is 2. In general, that is the ritual that we humans go through. We, in general, believe the sky is blue, and that 1 + 1 is 2.
Equals 2. And that's the way it should be, as this is the way in which
I don't know what it means. Should be.
our world works. How we count objects.
I don't know what you mean by our world works. You could say that human society works based on English in the United States and Spanish in South America, And mathematics, when you go to the store and you buy apples and you want to pay for them, or bottles,
and how we make sense of things.
it's about human society. That is what English is about, and that is what math is about. It's about communicating with other humans.
Around us. But math isn't always that simple. Consider the binary digits, for example, where you only have either 1 or 0. There, 1 plus 1 equals 0 and not 2. As for number 2,
Wait, what? 1 plus 1 equals 0? No, 1 plus 1 equals 10.
doesn't even exist in the binary system.
What do you mean 10? 10 is binary for 2 in decimal.
And it's not just binary. Any number system that excludes the number 2 will give us a different result. Taking a look back to our clouds
2 is not a number. 2 is more like a digit, but fine.
example, there also
1 second. Global relevance: Gaza aid director killed by Hamas. Wow. Too dangerous to live. Marcellus Williams case analysis. Mm-hmm. Mm-hmm. Okay.
1 plus 1 did not, in fact, equal 2, but it just gave us a bigger 1. So, where does that leave us? Well, in certain mathematical and philosophical systems, 1 plus 1 might not always equal 2. It can vary, like in binary, where 1 plus 1 equals 0, or in the case of our merging clouds. But for most practical purposes and for how we experience the world, 1 plus
Right, it depends. I mean, sometimes 1 plus 1 is not 2. Like, you could say two people, a boy and a girl, enter a bedroom and they come out with a baby, so that's 1 plus 1 equals 3. You could say that.
1 equals 2. It's the foundation of everyday math.
It depends on what, at the end of the day, it depends on it's basically a ritual between humans.
Still, if you're looking for the cold hard proof, it's been mathematically proven. And here,
No, it hasn't. Nothing has been mathematically proven. Nothing. Because of the incompleteness. Not the incompleteness theorem, but because of the incompleteness of any system. Every system is incomplete. Any system, meaning mathematics as a system, is incomplete. Meaning, what is it, right? A system must be founded on something. So it must have axioms. So if it must have axioms, meaning assumptions, then it's incomplete. Right? These assumptions are not true by definition. They're just assumed to be true. So every system must have a ground truth that is assumed, meaning it is a lie. So every system is built on a lie. So no system can ever be true. So nothing could ever be proved.
it is. Now, I won't dive into the full proof, mainly because it's too long. And already,
No, there is no full proof. Because I could say, like, I could just ask questions. Like, what are we assuming? Are we assuming we exist? Are we assuming this is this is written in English? I mean, I could just ask endless questions. And what is English? And who decide? And like, I could just ask endless questions and go into any rabbit hole. Is this the letter F? Or is it some other letter? How can I know it's the letter F? I could just ask endless questions about everything. And at the end, right, you have to start from some assumption. You're going to tell me, well, let's assume that this is an asterisk. Okay, so an assumption is the lie. This is the ground truth, but the ground truth is just an assumption. An assumption is something that we know we didn't prove. So if yet you hold it to be true, then that's the end of that. Then basically the conclusion of this discussion is based on an assumption. So you might as well assume the conclusion. That's it. So this is completely incorrect. Sorry.
The theorem leading up to it spans hundreds of pages. But here's the shortened version. The proof basically revolves around the set theory, and it goes like this. Let's say if you have two disjoint sets, let's say set A with an X.
Okay, so what is a set? Right? Whatever a set is, you're gonna, at the end of the day, right? A set is a word in English. So we're assuming English, right? We're assuming that this discussion is taking place in English. So again, you're assuming. So if we're assuming, then we no longer have truth. We have a ground truth that we're faking. We're faking the ground truth. We're building an edifice. We're building a construction on nothing. So this is not truth. This is an assumption. It's fake. It's false.
An element X and set B with an element Y. Then the union of these two sets contains exactly two elements, X and Y. In other words, this demonstrates that 1 plus 1 equals 2. It's a very simplified way of explaining how combining two separate things results in 2.
It's based on a bunch of definitions, which are just assumptions. So you might as well just have started from this. I mean, well, I don't see the difference between believing that 1 plus 1 is 2, or agreeing to the ritual that 1 plus 1 is 2, or the ritual that two sets, whatever, is true. I don't see the difference.
But the actual proof from the book that it comes from, Principia Mathematica, goes much deeper.
Principia Mathematica, as far as I know, they came to the conclusion in page 306 that they cannot prove 1 plus 1 is 2.
And the reason that it takes so long to establish this is that the book builds everything from the ground up, starting from the most basic principles and working its way to this conclusion.
No, you don't build everything from the ground up. You assume certain things. So you're assuming your ground truth, meaning you don't have an actual ground truth. So you don't have truth.
Conclusion. It's an incredibly detailed journey to arrive at what seems like a simple truth. Anyways, that was all she wrote, folks. I hope you enjoyed watching this video as much as I did making it. This is AD from Silverlight Studio signing off. Don't forget to like and subscribe. And as always, thanks for watching, keep exploring, and until next time.
So you're spreading disinformation, but very nice. Let me make a comment here. Very nice. Would you like to collaborate? DM me on Discord. You can find it in my about. Very nice. Very nice. Okay. Let's see. I did want to go through his courses, his playlist. This guy, Dr. Physics A, I find him to be the easiest to understand of everyone. So we should try and do a review of his course, because the other course that I started going through, I cannot understand it. Like this guy, this is just impossible. It's so incomplete that it's crazy. So where was I? This guy. So a simple derivation of the Schrodinger equation. I went through this in 7.5 minutes. It's so straightforward. There's like zero assumptions, and he actually explained it. Finally, after I heard it, I could finally understand Schrodinger's equation. It's so easy. It's so straightforward. Like everyone makes such a crazy nightmare out of it, especially Sean Carroll. Like the last thing you want to hear anyone explain Schrodinger's equation is Sean Carroll. So after hearing Sean Carroll explaining the wave equation, I thought I don't even know what I want to say. I just want to say that Sean Carroll doesn't understand the wave equation. But I'm not even going to bother. It's a waste. I don't want to there's no point. Anyway, so this is Schrodinger equation, a simple derivation. This is the wave function. I did want to take a look at, I mean, some people use the complex version of the wave equation to do normal physics. I did want to take a look at that. Let's see what it says here.
Hello. Today, we're going to look at wave functions, and in particular, to understand why I chose the wave function that I did in my video on the Schrodinger wave equation. It's also worth explaining why we need a wave function at all. The reason we need a wave function is basically to understand why an electron going around the nucleus doesn't simply spiral into the nucleus and annihilate the atom. That is really the foundation of quantum mechanics. The explanation is that you have to think of the electron not just as a particle, but also as a wave. And if you want to think of it as a wave, you need a wave function. That is why when I
I don't know. I mean, okay. So you're saying that the wave function was needed to stop the Bohr electron from collapsing? I mean, the electron from collapsing as a wave, it doesn't want to collapse? Why, as a wave, it would not want to collapse? What's going to stop it?
did the video on deriving the Schrodinger equation, I took as a basic wave this form, psi equals e to the I kx minus omega t. I should just explain what I is. I is the square root of -1. Now, there is no solution to the square root of -1. No two numbers multiplied together can ever make -1, because any identical numbers multiplied together always make a positive number. So the square root of -1 is what we call an imaginary term. It doesn't exist. But it's used in physics to solve a problem like this. Supposing you end up with a result that says that a squared equals minus b squared. There is no solution to that. But if you introduce I, you can say that a equals ib, because then a squared is I squared b squared, and I squared is -1. Now, for those of you who don't know, there is a basic mathematical form, which I'm not going to derive, but it's well established, that if you take psi equals e to the I alpha x, that is one and the same as cosine alpha x plus I sine alpha x. And that is clearly a wave term, because cosine waves oscillate, and so do sine waves. Cosine waves oscillate between +1 and -1. If you want them to oscillate between greater amplitudes, then you simply have to put an amplitude term a in front of the general term for the waves. Let's consider the real part of that wave, which is the cosine term, and we are using cosine of kx minus omega t. As I say, that is an oscillating wave. But what does it mean? Well, let's begin by simply looking at the cosine of kx. I'm defining k as 2 pi divided by lambda, where lambda is the wavelength of the wave. Here is the wave, and the wavelength is the distance between two successive peaks. So we can rewrite cosine of kx as cosine of 2 pi over lambda times x. What happens when x equals lambda? Then the term becomes cosine 2 pi, and that equals 1. And so for every x is 2 pi, that is 2 pi, 4 pi, 6 pi, and so on.
I'm not really following, but I don't know, where is he taking this discussion?
On.
What is special about this discussion? I'm trying to understand. I mean, the title of the video is the wave function, but what's the question that he's trying to answer?
The wave will have completed one complete wavelength and will look something like this. That is known as a standing wave. It doesn't go anywhere. If we now take the second part.
What? He keeps confusing standing waves. Standing waves are something different. It's when two waves in opposite directions meet. That's when you get a standing wave. This is not what's going on here at all. The wave function does not describe a standing wave.
And so, for every x is 2 pi, that is 2 pi, 4 pi, 6 pi, and so on, the wave will have completed one complete wavelength and will look something like this. That is known as a standing wave. It doesn't go anywhere.
What are you talking about? Standing? That's not the definition of a standing wave. I mean, this is just a wave without time. You didn't... But I don't get it. I mean, he has here omega t, so it should be moving. What is going on? What is he trying to say? Let's try this.
Let's consider the real part of that wave, which is the cosine term, and we are using cosine of kx minus omega t. As I said,
That's the cosine. Is this alpha x? So instead of alpha x, it's now kx minus omega t. So this equation didn't have t inside it. I don't know why he expressed it without the t, but fine. Now it's with the t.
Say that is an oscillating wave. But what does it mean? Well, let's begin by simply looking at the cosine of kx.
What do you mean it's an oscillating wave? I don't understand what he's saying. This is a wave. Let me just move
I'm
this
defining
out of the way. This is just, right? If you let t move forward, then your wave, depending on k defines the shape of the wave, and t defines the motion, and omega is the speed, basically, the velocity of the wave as it's moving. K is basically the shape. That's it. It's a moving wave moving to the right, as far as I know, right? So what is he saying?
K as 2 pi divided by lambda, where lambda is the wavelength of the wave. Here is the wave, and the wavelength is the distance between two successive peaks. So we can rewrite cosine of kx as cosine of 2 pi over lambda times x. What happens when x equals lambda? Then
Cosine kx. Okay, but this is just the shape. And k is 2 pi over lambda. So every time x equals lambda, or a multiple, or n lambda, you get a multiple, you get n times 2 pi. Basically, 2 pi is a full circle. So whatever, so you're going from basically peak to peak, because the cosine of 0 is 1. So every time x is a multiple of lambda, you've completed a cycle. So as you analyze the shape of the wave, every time x is a multiple of lambda, you must be at a peak. That's it. As the wave is not moving, as you're holding t constant in this discussion.
the term becomes cosine 2 pi, and that equals 1. And so for every x is 2 pi, that is
Right. So cosine 2 pi is 1, or cosine of n 2 pi, a multiple of 2 pi, is 1. So you're going to get the peak. Cosine doesn't go beyond 1. So you're getting a peak as you're moving along x, as you're analyzing the shape of the wave, holding time constant.
2 pi, 4 pi, 6 pi, and so on. The wave will have completed one complete wavelength and will look something like this. That is known as a standing wave. It doesn't go anywhere.
No, that's not a standing wave. That's not the definition of a standing wave. I don't want to use up my ChatGPT, so let's just ask Brave. What is the definition of a standing wave? Standing wave is a type of a wave that oscillates in a fixed location. Let's go to Wikipedia. This is a standing wave. You see the red one, the red is a standing wave. Animation of a standing wave, red, created by the superposition of a left traveling blue and a right traveling green. So the green is traveling to the right, and the blue is traveling to the left. And the superposition, meaning the addition, is a standing wave. This is a standing wave. What he's saying is not a standing wave. I don't understand why he keeps repeating this statement. Has anyone else noticed that it's a mistake? Oh, wait, I have, oh, there it is, standing wave. I've already said, I see I've said about incorrect from chat. I already hear ChatGPT, so I don't know what else to say. I guess I checked already. There's only 213 comments over 12 years. These are the best videos on YouTube. This guy, best physics YouTube videos. But what he's saying here is incorrect.
If we now take the second part, cosine kx minus omega t, this is what's known as a travelling wave, because the wave will actually move at velocity v to the right. I'll tell you what v is in a little while. Where do the peaks fall in this wave? Well, the wave will reach its maximum amplitude when kx minus omega t is 0. Because when k...
But notice this has nothing to do with I. He's just analyzing the real part of the wave equation. He's ignoring the imaginary part. So what's the purpose of the imaginary part?
x minus omega t is 0, cosine of 0 is 1, and that's the maximum amplitude. Unless, of course, you have this a amplitude term in front of the whole thing. So when kx minus omega t equals 0, that is the same as saying kx equals omega t, or x divided by t is omega divided by k. But what is x divided by t? X is this.
So anytime kx equals omega t,
Since t is
again you get a peak. Anytime kx equals omega t. So when kx equals omega t, all right, what happens?
time, and distance divided by time is velocity, v. And so this moving wave is traveling.
X to t, the ratio of x to t, which is the definition of velocity. Okay. I'm thinking, is this the definition of velocity? I mean, x is just whatever we plug in. X over t. The ratio? I don't know. The ratio. I'm trying to think. Is this really velocity? Anyway, but it's equal to x to t is omega to k. So omega to k is the velocity. Okay.
Traveling to the right with a velocity given by omega over k. But what is omega? Omega is the velocity in radians and is 2 pi times the frequency. What is k? K, as I've already said, is 2 pi over lambda.
So omega, I guess, is defined as 2 pi frequency or something. I don't know. Why is omega 2 pi frequency? So this is per second. It's just the definition. He should put like the 3 equal sign. So the definition of omega is 2 pi radians, meaning 360 degrees per, and f is the per second. So once per second, 2 per second. How many of these per second? So how many full rotations per second? That is what omega says.
So omega divided by k is 2 pi f divided by 2 pi
So
over lambda,
k, I'm trying to
which is
just,
simply f.
where's k? Okay, so k is 2 pi over lambda, but 1 over lambda is f. Isn't 1 over lambda f? No. 1 over omega. No. 1 over lambda? Isn't 1 over lambda the frequency? No. Frequency, no. Lambda times frequency is the velocity. So, well, we need the velocity. But k, so 2 pi radians is the 360 degrees. It's a full cycle. So it sounds like Israel tried or maybe succeeded to take out Mr. Hassan Nasrallah, the head of the Hezbollah. So that should be very interesting if Israel was able to exterminate this little maggot. Very interesting.
Lambda, which is the frequency.
But what's the definition of k? Well, we said that k, however is defined as 2 pi over lambda, it causes the equation. So as we travel along x, every n lambdas, every multiple of lambda, as x grows to a multiple of lambda, we're at a peak. That's the definition. That's the purpose of k. So we said omega over k is v. But what is omega and what is k? So omega is 2 pi f, and k is 2 pi over lambda, but f lambda, 2 pi crosses out, and f lambda, that's just the velocity of a moving wave. So f lambda, and we already know it's v, but now we proved that it's v. I would say now we can go back. Anyway, yeah, it's v either any way you look at it.
Times the wavelength. Frequency times wavelength is the velocity. Frequency is the number of waves that pass a particular point per second, and lambda is the wavelength of each distance from crest to crest. And so f times lambda is the number of waves which pass per second multiplied by the wavelength of those waves, and that gives you the velocity per second.
So f times lambda, I guess, means lambda is wave is peak to peak per second. So right, we're standing here, like how many peaks per second? Like 1 peak per second? Like the frequency per second. Frequency times lambda is the velocity. The frequency of a moving wave frequency just means we're standing here and how many waves, how many peaks are moving past us. How is he expressing this?
And lambda is the wavelength of each distance from crest to crest. And so f times lambda is the number of waves which pass per second, distance of waves that pass a particular point per second, and lambda is the wavelength of each distance from crest to crest. And so f times lambda, 2 pi over lambda, which is simply f lambda, which is the frequency times the wavelength. Frequency times wavelength is the velocity. Frequency is the number of waves that pass a particular point per second, and lambda is the wavelength of each distance from crest to crest. And so f times lambda is the number of waves which pass per second multiplied by the wavelength of those waves, and that gives you the velocity per second.
So you could imagine if you're always on top of this crest. Imagine that you're a wave surfer, that you're a surfer, and you're always keeping up with the peak. Just right, you're over here. You're just over the peak. And this is now a traveling wave. So what is your speed? I want to know your speed. So your speed is v. This is your velocity. And your velocity, if I know the peak to peak and I know the frequency, how many peaks go by a certain spot per second, right? So if I know the distance peak to peak and I know how many peaks go by per second by a specific point on X, then I know the velocity, and then I know your velocity as you're traveling on top of a wave.
We can also say more about k.
Which is the velocity of the wave.
K is 2 pi over lambda. But from my video on the reason for quantum mechanics, you will see that we derive the formula lambda equals h over p, where p is the momentum.
Right, so this is de Broglie.
So k is 2 pi.
Notice that, right, we're talking about an electron. An electron has a mass, but it's not a point mass. It's a wave that has a mass. An electron is not a point, it's not a particle. No matter what you hear people say, every time somebody says that an electron is a particle, you have to correct them and say it's not. It's a wave. And they would say, well, it has a mass. You would say, correct, because it's a wave that interacts with the Higgs field, giving the illusion of mass. Mass is just an illusion. Mass is something, it's just an interaction with the Higgs field. When a wave interacts with the Higgs mechanism, I shouldn't say the Higgs field, with the Higgs mechanism, it creates the illusion of inertia, of mass. by some magic that I'm not completely sure how it works, but basically it causes the wave, instead of the wave traveling at the speed of light, at the speed of waving through the ether, it bounces back and forth as it's moving along the ether. And this bouncing back and forth makes it appear as if the electron wave has slowed down below the speed of light. What light cannot do, light cannot slow down. Light cannot interact with the Higgs mechanism. But an electron always interacts with the Higgs mechanism. So it can always travel slower than the speed of light. We can actually stop an electron, and that is what, I don't remember who did it. Some guy, maybe J.J. Thomson was able to suspend a single electron. These people in those days, they were able to slow down electrons to basically zero. I don't remember, maybe even Rutherford, one of those guys. I mean, this is right around the time of the beginning of the 20th century. Everything happened all at once. Anyway, so de Broglie said that an electron has a momentum. Well, everybody agrees that it has, but it also, he added that it also has lambda. It has a wavelength. It has both. Both are true. Both. He connected the momentum, which make it sound like a particle. He connected it to a wavelength, which everybody's confused by. How can a particle have a momentum? Well, that's because P is not a part. Has nothing to do with a particle. I mean, not necessarily. P has to do with the momentum, which has to do with mass, and mass has to do with interaction with the Higgs mechanism, which a wave can do. A wave doesn't have a problem. Actually, only a wave can interact with the Higgs mechanism, apparently.
Divided by lambda, which means is divided by h over p.
So I guess now we're going to replace lambda, but we need to go back and remember why lambda equals h over p, but this is de Broglie, as far as I remember.
And that is simply p over h bar, where h bar is a new version of Planck's constant, h over 2 pi.
So k is 2 pi over lambda, but lambda is h over p, so h over p. So this is h over 2 pi, so this is h bar, the reduced Planck's constant.
And that means that p equals k h bar. H bar is a constant, so k is in essence a measure of momentum.
So p equals kh bar. So kh bar is a momentum. What did he say?
And that means that p equals k h bar. H bar is a constant, so k is in essence a measure of momentum.
I don't know why you would say that. I mean, h bar is a constant, but it's not, what do you call it? It's not dimensionless. It has a dimension. So I wouldn't say that k is momentum. Kh bar together is a linear momentum.
So in this formula for psi equals e to the I kx minus omega t, we can say that k is 2 pi over lambda, but it is also p over h bar. And it
Oh, this is good. So after discussing and explaining k, so he's saying, well, k is momentum. Has to do with linear momentum. So he's saying in this equation, k, right? This is everything we said. It's p over h bar.
we can say that k is 2 pi over lambda.
I think he's trying to get a feel for the meaning of this thing, even though there's an I here that makes this thing imaginary and unrelatable.
But it is also p over h bar, and it therefore gives us an indication of the wavelength of the wave and the momentum of the wave. Omega is 2
So
pi times
1 second, I need to move his hand away.
x minus omega t. we can say that k is 2 pi over lambda, but it is also p over h bar, and it therefore gives us
All right. So K has to do with lambda and with the momentum. So this thing has to do with the wavelength and the momentum. Both are inside K.
an indication of the wavelength of the wave and the momentum of the wave. Omega is 2 pi times the frequency, and thus gives us an idea of the frequency of the wave, and the velocity of the wave is omega divided by k, and that tells you how fast the wave is moving to the right.
So omega is about the speed. Yeah, but I would say this has, it's not interesting because this is the I, so this is imaginary. This has nothing to do with this universe. This is true for the real part of the equation, not for the full equation. I don't know why they use this with the I. What's the purpose of using the I? He's like, let's listen again. What was the purpose of this lecture?
Hello. Today, we're going to look at wave functions, and in particular, to understand why I chose the wave function that I did in my video on the Schrödinger wave equation. It's also worth explaining why we need a wave function at all. The reason we need a wave function is basically to understand why.
Yeah, but you don't need the imaginary version of the wave function. What's the purpose of using the full imaginary, the full complex, I should say, version of the wave equation? Why not use only the real notation? Why do you need the imaginary notation? What do you get from the imaginary notation?
An electron going around the nucleus doesn't simply spiral into the nucleus and annihilate the atom. That is really the foundation of
So in the conclusion of this video, you didn't talk about that. So I don't see how that's relevant.
quantum mechanics. The explanation is that you have to think of the electron not just as a particle, but also as a wave. And if you want
How is that relevant?
to think of it as a wave, you need a wave function. That is why when I did
Yeah, but you don't need that wave function that you selected. You could have used just the cosine or the sine wave function.
the video on deriving the Schrödinger equation, I took as a basic wave this form, psi equals e to the I kx minus omega t. I should just explain what I is. I is the square root of -1.
Everybody knows that. Why? What do you get from using I? Where is the benefit of using I, the I notation? Right? You're going to show that the expression e to the I whatever, it's actually cosine plus the I sine. Okay, so you just need the cosine version. So why do you need the complex version of this wave equation? And why are you explaining to us I? Like, we know I from 4th grade or something or whatever. Who cares?
Now there is no solution to the square root of -1. No two numbers multiplied together can ever make -1, because any identical numbers multiplied together always make a positive number. So the square root of -1 is what we call an imaginary term. It doesn't exist. But it's used in physics to solve a problem like this.
It's used in mathematics. There are problems in mathematics where I is useful, where I seems to be relevant to our universe. But I don't. But you haven't shown that it's relevant in this problem.
Supposing you end up with a result that says that a squared equals minus b squared. There is no solution to that. But if you introduce I, you can say that a equals ib, because then a squared is I squared b squared, and I squared is -1. Now, for those of you who don't know, there is a basic mathematical form, which I'm not going to derive, but it's well established, that if you take psi equals e to the I alpha x, that is one and the same as cosine alpha x plus I sine alpha x.
So it's very straightforward to derive it using just deriving. If you take the derivative, of both sides, whatever, you can show that this is true.
And that is clearly a wave
Or you can use the Taylor expansion or whatever.
term, because cosine waves oscillate, and so do sine waves. Cosine waves oscillate between +1 and -1.
Yeah, so you could have used the cosine because you don't care about, I mean, all you need is to describe the electron as a wave. So you don't need the imaginary part. So why did you bring it up?
If you want them to oscillate between greater amplitudes, then you simply have to put an amplitude term A in front of the general term for the waves. Let's consider the real part of that wave, which is the cosine term.
Yeah, and you never considered the imaginary part. So what's the purpose of the imaginary part?
And we are using cosine of kx minus omega t.
Yeah, and then you went through everything and you never bothered with the imaginary part. So why are you bringing it up?
As I say, that is an oscillating wave. But what does it mean? Well, let's begin by simply looking at the cosine of kx. I'm defining k as 2 pi divided by lambda, where lambda is the wavelength of the wave.
Okay. I don't know. I'm sorry. I just don't know the purpose. What is the purpose? This is not in my course, but it's very interesting. My video on atomic physics explained this in more detail, but in essence, we might expect a charged particle electron in orbit around. Anyway, I don't want to waste my time. Like, once a great teacher told me you should learn from teachers what they have to teach and not what they don't have to teach. So sometimes teachers don't know something, but they try to teach it, and they're just wasting their time and your time. So just ignore that, skip that lesson. But sometimes teachers want to teach what they know how to teach. That is what you should learn from them. So as he is explaining the wave equation, there's a lot of stuff that he is teaching that is great, but there's some stuff here that is nonsense. So just ignore the nonsense and consider the not nonsense. And so forth, and so forth, and so forth. All right. I'm just thinking, should I go through this entire series? I mean, these are great topics that I really want to go through. Let's give it a shot. Oh, this is an hour. Interesting. So this one is an hour. The double slit experiment and diffraction. I mean, I know everything there is to know about that. Solving Schrodinger. Oh, he's going to solve Schrodinger. That is great. So we should do solving Schrodinger. I don't think we need the double slit, the double and single slit experiment. Oh, but there is a single slit. This is very interesting because some people, they say, oh, when you block one of the slits, it stops behaving like a wave. That's not true. As a single, even in the single slit, it still behaves like a wave. It still gives, it demonstrates that it's a wave. So it's not like it stopped being a wave. You just blocked one of the pathways, one of the slits. Anyway, I'm just wondering, should we listen to this or not? I don't think so. This sounds really boring at this point. I don't have a question. I mean, I'm just wondering, what is a detector, an electron detector? So people think that in the double slit experiment, they actually had 2 slits for the electron. That's not true. They passed it through a crystal. The electron goes through a crystal, and they use the atoms to behave as the slits. So the electron wave is tiny. It is a wave, but it's tiny. You cannot create apparently 2 slits manually. Like with the light, we're able to actually create 2 slits and get a diffraction pattern. Not so with the electron. With the electron, you actually end up having to use a crystal. Anyway, yeah, let's skip that. Let's look at solving Schrodinger for hydrogen atom cheating. Oh, he's cheating. Why is he cheating? Let's listen to it anyway.
Hello, today we are going to do a cheat solution of the Schrodinger equation for a hydrogen atom. You'll recall that in my video on deriving the Schrodinger equation, we ended up with a time-independent Schrodinger equation of the following form: E psi equals minus h bar squared over 2m times d2 psi by dx squared plus v of psi. But what does that actually mean?
I'm going to have to take a break because I'm beginning to become starving. But let's just begin watching this.
This is a formula which is very similar in its context to classical mechanics that tells you something about
I can barely, like, let's try and fix the quality. No, it's maximum. Okay.
how a particle is and what its future is likely to be. In this particular case, the Schrodinger equation is telling us something about the energy.
Wait, what did he say? It's a particle?
But what does that actually mean? This is a formula which is very similar in its context to classical mechanics that tells you something about how a particle is and what its future is likely to be. In this particular
How a what? A particle?
context to classical mechanics that tells you something about how a particle is and what its future is likely.
What do you mean? This is a wave equation. It's true for a particle spring, like a mass spring system behaves like a pendulum. So you could say it also like a pendulum, and like a pendulum, you could imagine there. It's the way a pendulum behaves and a wave, an ocean wave behave. They're similar. Like all waves behave in a similar. There is similarity, and we can employ a single mathematical tool to explain or express physical aspects of a surface water wave, an ocean wave, a sound wave, and a pendulum motion that looks like a wave, and a spring, and a mass, and so on. There's other circuits and stuff. So there's many things that seem to behave in a similar way to that are all waves or all waving. But the reason why Schrödinger came up with the wave equation has to do with de Broglie saying, or even Bohr, I think it comes out of Bohr. I think everything started with everything started with de Broglie. So Bohr took de Broglie seriously, and Schrödinger took them both seriously. But everything started with de Broglie. So de Broglie said, everything started with Einstein. So Einstein said that light seems to behave like packets of energy, which is not a particle. A packet of energy, a wave, right? So light behaves like a wave, but also like a particle. It's a strange creature, but it's still a wave. There's nothing about the photon that is a particle, except for it's a strange wave. That doesn't make it a particle. The photon is still the ether waving. The photon is an energy wave through the ether, but it's a special wave that when you look, when you take a look at it from a distance, it resembles a particle. You could mistake it for a particle from the distance, but as you get closer to it, it's just a wave. It's just waving through the ether. It's just the ether particles, a wave going through the ether particles. Hold on, I have some visitor. Oh, Spaghetti, how are you?
Hello, I'm fine, thank you. And you?
Fantastic. So, do you want to talk about ether?
Not really.
Okay, do you want to talk about something?
I could take it or leave it.
Do you want to talk about Schrodinger's equation, Heisenberg's uncertainty?
Yeah, I could take it or leave it.
So, do you agree with Sean Carroll that he says that the universe has a wave equation or something like that?
Yeah, makes sense.
What do you mean it makes sense? I mean, the wave equation describes an electron waving around the nucleus of a hydrogen atom, why would you say that the wave equation is relevant to anything else?
Well, there are other kinds of waves also.
Okay, fine. So
Like ocean waves.
yes. So you could use the wave equation to describe waving phenomenon, but let me ask you, does it make sense to say that a baseball, that the Schrodinger's equation applies to a baseball? Would you say it's relevant?
Yeah,
Is the baseball waving?
I guess so.
What do you mean you guess so? I mean, if you
Yeah,
guess
I guess so.
no. If you guess so, then the answer is no. I mean, is the baseball right? Because the purpose of the wave equation is to use a mathematical tool we call the wave equation in order to describe the behavior, the physical behavior that we are noticing, right? We're noticing a natural phenomenon that we call a wave. And we have a mathematical tool, or we developed a mathematical tool that in general seems to model this physical phenomenon that we have noticed. So you take the mathematical model that seems to, closely predict and describe the physical phenomenon that we've noticed, like an ocean wave or the electron waving around the nucleus, and then it makes sense. But we never noticed that a baseball is waving. So why would you apply the wave equation to a baseball?
To see that it works and it makes the correct predictions and so on.
Like what prediction do you get from applying the wave equation to the baseball?
Basically the same prediction that you would get if you hadn't used it
So
and just used classical mechanics instead.
wait, you can make any prediction based on the wave equation and applying the wave equation to a baseball?
I guess so.
Okay, give me an example.
Yeah, if you throw the baseball, you can predict where it will be.
With the wave equation?
Guess so, yeah.
How?
Solve it.
What do you mean solve it? I don't know what
Find a solution.
I wouldn't. Okay, what, like the wave equation? Like I I wouldn't know where to begin. Can you point me to someone who applied the wave equation to a baseball and then got a prediction right?
Maybe.
Okay, then you can't. Then no one has ever applied the wave equation to a baseball to make a correct prediction. Then it doesn't apply. The model doesn't fit. It's a bad theory. Right? You
Why do
basically,
you say this?
excuse me?
Why do you say this?
I'm asserting, you're welcome to prove me wrong. I'm asserting no one has ever applied the wave equation to a baseball to make a prediction and got it right. That's my assertion.
Okay,
So,
yeah, your assertion is wrong.
so point me to a single person who's ever applied the wave equation to a baseball, made a prediction, got it right.
I don't feel like it.
Let's see one.
I don't feel like it.
Well, just tell me about it. I'll search Google, tell me about that prediction. I'll Google it simultaneously. Has anyone
Yeah, just search. Just do that. What
What?
you said.
what?
just to do what you said.
I wouldn't. I like. What prediction can you make? Okay. I'll do it. Google search. Okay. Wave equation, baseball prediction. Okay. The concept of applying wave equations to baseball prediction is intriguing, but I'm doing a Brave search, so it's basically an AI. Essential to clarify that traditional wave equations like the Schrödinger equation are not directly applicable to predicting baseball outcomes. However, the idea of using wave-like patterns to analyze the forecast baseball performance has been explored. Pythagorean winning percentage, I don't know. I don't see, in summary, the wave equation baseball prediction is not a direct application of traditional wave equations, but rather an inspiration from wave mechanics, leading to novel approaches in baseball analytics and forecasting. While wave equations themselves are not directly used in baseball prediction, the concepts and ideas inspired by wave mechanics have led to innovative approaches in analyzing forecasting baseball performance. The Pythagorean winning percentage formula and the physicist formula are examples. Let's see.
An AI summary.
That's an AI summary. Yeah, physicist.
Sounds like it's talking about predicting the outcome of baseball games rather than the physical properties of the ball itself.
Okay, physicist formula, a more recent development in formula proposed by a physicist which uses runs scored. Yeah, runs is a game. Pythagorean winning percentage. One approach. Okay, that's a winning. That's baseball, the game. I want. Anyway, it's obviously incorrect. It's an incorrect theory. To theorize that a baseball is a wave is obviously an incorrect theory. As incorrect can be, like the most incorrect. What?
Why?
Because no such data exists. I don't have any data to support this theory, so it's false.
Well, how would you distinguish between a wave with a very, very, very small wavelength and a delta?
Look, show me the data where you applied the wave equation, Schrödinger's equation, or any wave equation to a baseball, and you made a prediction, and you got the prediction right. Just show me the data. It's really very a baseball, any large object, any object that is not waving, like even I would even suggest a hydrogen atom.
Proof somewhere.
Excuse me. What?
There's a proof somewhere.
I need data.
I don't remember how it goes. No proof that quantum mechanics reduces to classical Hamiltonian mechanics in the limit as h bar goes to 0.
As what goes to 0?
H bar.
H bar is a constant of nature.
Yes, but if you don't treat it as a constant and let it go to 0, then in the limit you get back classical Hamiltonian mechanics.
I don't know. I'll ask you again. Show me the data. The data that you use the wave equation to predict any macro object's behavior, and you got it right. Just show me any data. Why? But why would you? Right?
The proof's not count.
Excuse me?
The proof's not count.
No, I need data. Show me the data that you, right? Sean Carroll says the universe has a wave function. Okay, that's as nonsense as nonsense can be. Schrödinger invented the wave equation because Einstein showed particle wave duality in light. De Broglie said it should apply to an electron. Bohr applied it to the hydrogen atom, and Schrödinger applied it again to the electron, basically, to the electron. But that's because we're talking about something that seems to be waving. The electron seems to be waving around, right? It seems to be waving in the double slit experiment. It seems to be waving because right, we know the orbitals, the orbits. I mean, so it seems to be waving. The wave theory of the electron has data to support it. So Schrödinger,
Okay.
what?
Okay.
Do you submit?
No, I'm just bored.
Okay. So you still think Sean Carroll is correct that the universe has a wave function?
Probably, unless one of the objective collapse theories turns out to be right.
I don't know what you just said. You said probably, unless. Well,
Yeah.
so in the beginning you said yes, and now you're saying probably. So are you beginning to submit?
No.
Yes, you are. In the beginning you didn't say probably. Now you're saying probably. You're changing your mind about his position.
Whatever.
Whatever. Again, you seem to be changing your mind. So you agree that Sean Carroll is saying nonsense.
Anyway, I'm bored.
You're bored that Sean Carroll keeps saying that the universe has a wave function.
Yeah, I'm bored. I'm going to see what's going on somewhere else. Bye.
Like, incredible. People who actually understand this stuff don't appreciate truth. So sad.
In this particular case, the Schrödinger equation is telling us something about the energy of the particle. In our case, we're going to be looking at the electron in a hydrogen atom. Now, to solve that equation, you would strictly have to insert the potential energy, which is the Coulomb force between the electron and the proton. And thus, the formula would become E psi equals minus h bar squared over 2m d2 psi by dx squared. Plus, of course, you now have to do this in 3 dimensions. So it's d2 psi by dy squared plus d2 psi by dz squared plus a potential term. And the Coulomb term would be ze squared over 4 pi epsilon naught r, where z, of course, is 1 for hydrogen because there's only one proton in a hydrogen. Z squared dy squared plus d2 psi by dz squared.
So this is the conclusion from one of the previous lectures that he gave that I did follow. I don't remember specifically, but let's assume this was the conclusion. So the total energy times phi is equal to negative h bar over h bar squared over 2m, the mass of the electron. He is drawing the electron as a particle around, but this is not what Schrödinger said. Schrödinger didn't say the electron is a particle. Schrödinger said the electron is a wave waving around its orbit. That's what we're looking at. We're trying to solve what this behavior, we're trying to solve for the actual wave equation. We want to know exactly how it's waving, what it looks like, this waving. So we need the mass of the electron. That's fine. And this is the potential energy. Okay. So he's copying everything 1 to 1. Nothing has changed.
Squared plus a potential term. And the Coulomb term would be ze squared over 4 pi epsilon naught r, where z, of course, is 1 for hydrogen because there's only one proton in a hydrogen atom. Epsilon naught is the permitted free space, and r is the polar coordinate distance between the proton and the electron. And therein lies part of the problem as to why it is so complicated to solve the Schrödinger equation, because we have this part of the Schrödinger equation in x, y, and z coordinates, but this part of the Schrödinger equation is in polar coordinates. You have to convert to all of one particular type. And generally, it's better to convert to polar coordinates. And then it becomes really rather complicated, and it's worthwhile asking a mathematician to sort it out. But we're going to do the solution by a slightly cheating method. We're not going to actually use the Schrodinger. It's worthwhile asking a mathematician. And generally, this part of the Schrodinger
But
equation is distance between the hydrogen atom
One
plus
second.
d2 psi by d.
This is V times phi. Psi, sorry, not phi, psi. This is V psi, V times psi. He completely neglected psi. He wrote Coulomb's law, but without psi.
dz squared plus a potential term. And the Coulomb term would be ze squared over 4 pi epsilon naught r, where z, of course, is 1.
Where's psi? So Ze squared, that's fine. Z is just the number of protons, and E is our electron. So it's ZE E. So that's the electric element. And I guess according to Coulomb, there's always a 4 pi r, and epsilon naught is the permeability to electric propagation. This is not a force. A force would be r squared. If you multiply by r, then you get the potential energy, but there has to be a psi here on top.
For hydrogen, because there's only one proton in a hydrogen atom. Epsilon naught
Let's skip forward.
in xy particular type. And generally, what we're going to do the solution to do is we're going to look at 3 formulae and use those. Formula number 1 says that total energy is kinetic energy plus potential energy. And for our electron, that will be half mv squared, that's the kinetic energy, minus ze squared over 4 pi epsilon naught r.
What did he say? How are we going to cheat?
To sort it out. But we're going to do the solution by a slightly...
So obviously we need to cheat because we need to either express Schrodinger in polar coordinates or express this distance in xy in Cartesian coordinates. And by the way, this is x, y, and z. Shouldn't he put parentheses on something? Like, I don't think he took too much. I don't think he's going to continue from this because he made many mistakes here.
cheating method. We're not going to actually use the Schrodinger equation, but we're going to end up with the same result.
Oh, he's not going to use Schrodinger's equation at all?
What we're going to do is we're going to look at 3 formulae and use those. Formula number 1 says that total energy is kinetic energy plus potential energy. And for our electron, that will be half mv squared.
Okay, so he's starting from first principles. Total energy is kinetic plus potential.
That's the kinetic energy.
Total energy is kinetic energy, 1/2 mv squared.
Minus ze squared over 4 pi epsilon naught r, which is the Coulomb potential.
Okay, potential energy is the Coulomb potential in radial. Okay.
It is the potential between 2 charges, the proton and the electron. Z, of course, is 1, but I'm going to keep it in because we should be able to derive a more general solution at the end of this exercise. The second equation I'm going to use is to look at the centripetal acceleration of the electron as it goes round. We're going to assume it goes in a circle as it goes around the nucleus. And the
It's a wave that goes around in a circle. It's a moving wave. It's not a standing wave. It's not 2 waves that are interacting and canceling each other out or whatever. It's a single wave that's running around.
centripetal acceleration is, or centripetal force is mv squared over r. The acceleration is v squared over r.
Okay, we need to come back and derive this, but for now we'll just assume it's correct. This is the acceleration of a rotating wave or a rotating object. It doesn't matter if it's a rotating wave or object or a rotating ring. There's no difference.
But what produces this centripetal force? It must be the Coulomb force, which is
Yes, that's correct.
ze squared divided by 4 pi epsilon naught r squared on this occasion. So what we're
This is the Coulomb force, r squared, yes.
essentially saying is that the Coulomb force is the force that provides the centripetal force that keeps the electron in orbit around the nucleus. The third equation that we're going to use is an equation that says that angular momentum is quantized. Why do I say that? Well, let us consider an electron going round a proton in the nucleus. What quantum mechanics says is you have to think of that electron not simply as a...
This is the, Bohr. So Bohr came up with quantizing the orbit. the orbital inertia.
Particle, but also as a wave. And it's a standing wave. It goes round in wave form. But here's the rub. It has to come back to the point at which it's
That's not a standing wave. It has to complete a full cycle so that to be continuous, otherwise it's discontinuous, and I wouldn't know how that physically is possible, right? Imagine, right? Imagine any type of wave. By the way, it's not what he's drawing is a wave. 1 second, someone is visiting. Let's see. Spaghetti, how are you?
I am fine. Thank you, and you.
Phenomenal. Um, do you know how to solve Schrodinger's equation for a hydrogen atom?
I've done it before.
Wow. Are you a PhD in physics?
No,
You have a master's
in
in physics?
no,
Do you have a bachelor's in physics?
no.
So how do you know, when did you solve Schrodinger's equation?
Ages ago,
No, but like on your own, like, or in school?
yeah, in school.
Do you want, like, what did you study?
Nanotechnology.
Nice. So what do you want to talk about?
Birds.
Birds. Anyway, I'm trying to what am I trying to do? I don't even know. Do you believe in particle wave duality?
I like birds. My favorite bird is penguin.
A penguin is a bird. I never even thought about that. It's not a mammal? Oh no, they lay eggs. You're right. So do you believe in the particle wave duality? Hello, Lily.
Yes, so.
What do you mean? Lily, what's up?
Nothing.
Oh,
Really.
oh, nice. We're talking about the particle wave duality. So, Spaghetti, so you believe an electron is a particle and a wave?
Yes, so.
Why would you say it's a particle? What evidence do you have that an electron is a particle?
Spins.
Because it spins?
Yeah.
Define spin.
It spins. It has angular momentum that is intrinsic.
Wait, if it's intrinsic, that doesn't sound like a particle. What do you mean intrinsic? If it's a particle, it should be able to get rid of the spin or change it. It should be mutable. Shouldn't, is it mutable? Like, can you imagine? Like, we know an electron is a wave, right? There's a lot of evidence that it's a wave. And spin, you're never able to explain to me spin. So to use spin as the evidence for anything is flimsy at best. Like everything else about the electron is very straightforward. Spin, no, I've never heard
Yes.
any. Excuse me?
Uh-huh.
So your only evidence for the electron being a particle is spin? No other evidence?
Okay, I guess it's not a particle and it doesn't spin. It has no spin. There's no such thing as spin.
Well, I don't know what spin is. I mean,
You are right. You are correct. You do not know what spin is.
yeah,
Therefore, spin does not exist.
I didn't say that. I wouldn't, before I would rush to use spin as evidence for anything, I would slow down. Especially when it,
You are right. It is not evidence for anything.
no, I mean, I would slow down. Especially,
Also, there's ether.
okay, that's like you're switching topics, but fine. You said you don't want to talk about the ether. Now you're bringing it up.
Yeah, the ether is real.
I mean, if you want to talk about the ether, we can talk about the ether. It's up to you. I mean,
What do you talk about normally when you're not talking about this?
what do you mean? Right now, I'm doing quantum physics. I'm trying to understand quantum physics. I'm trying to understand modern physics.
Okay, well, then read the textbook. Don't ask me.
Okay, I mean, I don't have a textbook. Is there a modern physics textbook?
There's a bunch of them, I assume.
Are they free online?
Yeah, some of them are.
Can you send me one? Can you give me, like, tell me one?
Some.
What?
Oh, I can find some.
Wow, that would be amazing if I could
Or you
go
can
through.
use LibGen to download them.
What? Oh, I can download?
Yeah, with LibGen.
What is LibGen?
It's a website where you download books from.
For like legally for free or illegally for free?
For free.
LibGen. All right. LibGen. Library Genesis.
Yeah. It's a Russian website, okay?
Okay. Great. So, do you have any questions about modern physics?
Yeah.
You want to ask me? Maybe I have an answer.
Uh,
Do you understand Bell's inequality?
uh-huh.
Can you explain it to me?
Probably.
What?
Yeah, I probably could.
Do you want to?
Not really.
Mm-hmm.
Anyway, I'll be right back.
Okay, bye. Anyway, let's look at LibGen. Is this where you go unofficial? This is endless. So where do you start? LibGen at Library Genesis. Or LibGen. You can choose from more than 2.4 million nonfiction books, 80 million science magazine articles, 2.2 million fiction books, 0.4 million. Okay. Library Genesis links as well, comments, or most books are in the public domain. But how do you enter? Is this where you enter? No. Oh. Oh, so you just go here. So we need 1984 is separate. 1984. That's a good book. Public domain. Is there a search? Here's a search. So let's look for quantum physics. Oops. Quantum physics. Sorry, but what am I missing? But nothing matched. Let's just look for quantum. Wait, I have a notification in the YouTube app. What happened? Any moral position that seeks to reduce suffering. Okay, so sorry, but nothing matched your search terms. Please try again with some different keywords. I don't know, 1984. Okay, so a single entry. So we need a specific name of a book, like Introduction to Quantum Physics. So she what's her name? She recommended let's Google search what is the most recommended textbook on quantum physics. Okay, based on provided search results, here is a concise answer. The most recommended textbook on quantum physics is Griffith's Quantum Mechanics. Okay, so let's take that. No? I don't get it. There's nothing. Is this the search? How to use browse LibGen book index to search and download. That is one of the how to search book title. You can search, but how do you search? I mean, nothing is working. Okay, search. This is like an old version. I've been looking for a book called Please help me. Please, I really need this book. Social science. I don't know what's going on. What am I missing? Alice, Dracula, Frankenstein, Great Expectations. Little Women. Oh, so these are specific books. So these are specific books. Oh, maybe this? No. Recent articles. Library, Genesis. I don't know. These are the pages. I don't know how to search here. I don't know what to do. This is useless. Maybe we can go to YouTube and ask them how to download from LibGen. How to download books from Library Genesis 3 years ago. Okay.
Hello everyone. To download a book from LibGen, first visit the active website of LibGen. Enter the title of the book you want to download and press enter or click on search.
I can barely see what is going on here.
It will take you to the page with the list of available books with the matching titles. Navigate and scroll to the page till you get the right book. For example, here I want to download 7th edition of the book. Click on any mirror links given in the square brackets. It will take you to the download page. Click on get button to start download the book to your mobile, PC or tablet. Happy learning.
No. No, that didn't work. Let's Google why isn't libgen working? Why am I getting no results in libgen? What happened to libgen? Answer, I'm not sure about gem, blah, blah, blah. Is it up? Reports it to be, okay. Some mirrors always show the same error. Well, is it working? I download, how can I know if it's working? Let's try this. Is libgen working? Based on search, it appears that libgen mirrors and proxies are experiencing issues and not all of them are working consistently. Some users have reported successful downloads using Tor browser. Okay, so it's not reliable. All right, forget about it. Let's go back to part 1. I was listening to D-Rock's lecture, really interesting. This looks really interesting. Calculus. I love calculus. Abstract algebra. Wow, amazing. Anyway, I did want to see that if I received an interesting Diddy's S3X slave speaks out. Whoa. What does the new government even stand for? Iranian proxies destroyed and decapitation strike? Wars here. Hezbollah wiped out. Donald Trump faces missile attack, grounding Trump Force 1, and J.D. Vance doxxed by woke journalist. Tizitel's upload. I don't know. Lex Friedman, ARM or I have a lot to say about what? Vegan linked. Is there anything interesting? That's the question. Because I got a message on my phone that was sort of interesting. There's nothing interesting. Of everything, there's nothing interesting. Let's click that again. It's over. This is interesting. Let's see what happened to.
It is finally over. Francesca Gino's $25 million lawsuit against Harvard and Data Colada has been dismissed by a federal judge in Massachusetts. She lost.
Wow, amazing.
In my opinion, this is a fantastic result for science and scientific integrity. Had the result gone the other way, it would have set a very bad precedent going forward. So I'm glad it worked out how it did, and I'll talk more about that at the end of today's video. But given that this video is likely my last ever video on Francesca Gino, I thought I would recap the entire saga in chronological order at a high level, in case you've missed any of the developments that have happened so far. So let's start from the beginning, and then we'll talk about what this means for science at the end. All right, let's go. Chapter 1, the PhD student. Around 2018, Zoe Ziani is a PhD student in Paris. She's doing her PhD on the psychology of networking, field in which one of the cornerstone papers happens to be written by Harvard professor Francesca Gino, along with a couple co-authors. This cornerstone paper from Francesca Gino claimed that networking makes people feel dirty. Zoe thought that this idea seemed pretty implausible, and when she looked at the data of this paper, she found that it didn't make sense. At first, she thought that perhaps the authors were just cherry-picking their data or p-hacking, but after a little bit of digging, she actually became more suspicious of the data and came to the conclusion that this was not just p-hacking, but this was actual fabricated data, aka data fraud. But when Zoe brings these findings to her supervisors, which of course is the correct thing to do, her supervisors, rather than approach this with curiosity and concern, instead try to shut her down. Essentially, what Zoe experienced was her supervisors trying to bully her into not pursuing this line of inquiry any further, which in my opinion is absolutely shameful. If you're an academic watching this and maybe you supervise some younger students, please do not do this if this happens to you. If a student approaches you with concerns about a paper, even if it's a paper about somebody very famous, approach it with curiosity and an open mind. You'll only be doing science a favor and fostering a good atmosphere for science. However, Zoe, being a legend, refuses to be bullied into silence and instead decides to enlist the help of another fellow researcher to look more into Gino's data. The two of them together look into Gino's work and end up identifying 3 more datasets which they think contain fabricated data. So if you're keeping track, that's now 4 different datasets from 4 different studies, all of which they think contain fabricated or fake data. So since Zoe and her anonymous friend were not getting any luck with their own university, they instead decide to bring these allegations to Data Colada. Chapter 2, Data Colada.
Yeah, I mean, it's good to be able to catch actual frauds. It's much more difficult to catch not so clear frauds. It's like when actual scientists come up with bad science. What do you do against that? Like, fine. It's fine. I mean, it's obviously laudable that we got, we're taking down actual frauds. That's fantastic. But we still have to deal with the not so clear cases that people, I mean, what I believe is bad science. People promoting bad science. How do you deal with that? Like, you listen to Professor Sean Carroll, and he's espousing his nonsense that the universe has a wave equation, a wave function. What the heck are you talking about? Like, that's like, I would call it fraud. But he probably believes it. I mean, he would probably die at the stake defending this nonsense. So how do you stop that?
Data Collider are a blog run by these three researchers, Yuri Simonson, Leif Nelson, and Joe Simmons. On this blog, they investigate and write about research misconduct and other issues of scientific integrity. When approached by Zoe, they have the correct response as any good academic.
So this channel is a very important channel. He just crossed the 100K subs on YouTube. Amazing.
Should have, which is concern and curiosity, but also a healthy dose of skepticism. So when Zoe approaches them with these allegations, Data Collider worked with her and her anonymous friend to validate all of these findings. And according to Zoe, they were incredibly rigorous, triple checking every single claim that Zoe made, so that the only plausible explanation for how this could have happened was data fraud and not something else more innocuous or innocent. But after what seems like many months of checking, they come to the same conclusion as Zoe and her anonymous friend. This is data fraud. When they looked into Francesca Gino's datasets, they found that the p-values were too low, the data was out of sequence. They even went as far as to look into Excel's calc chain files to find evidence of physical manipulation of the different cells within an Excel spreadsheet, which very much looked like somebody tampering with the dataset. And in the case of the networking paper that kicked this all off for Zoe Ziani, they actually found that the data was inconsistent with itself. The numerical data and the word data that Gino collected wasn't consistent with itself. I won't get into the details now, but essentially the data didn't make any sense. So all of this combined pointed to a very clear conclusion that Francesca Gino is very likely to have engaged in data fraud in all of these different papers. So,
but Francesca Gino is hot. I mean, she's really hot. She's thin and nice face, but she got caught. Unfortunate for her.
In 2021, Data Collider approached Harvard Business School, Francesca Gino's employer, with their findings. Chapter 3, Harvard Business School. When the dean of Harvard Business School, a guy called Dean Data, hears about these accusations from Data Collider, he, to his credit, approaches it with the right attitude, which is concern and skepticism. After all, fraud on this scale and of this magnitude is quite rare, and also Francesca Gino is one of his superstar professors. So he asked Data Collider to not post their blog posts on their findings about Francesca Gino, but instead first wait for Harvard Business School to run their own internal investigation to validate the findings made by Data Collider and Zoe and her anonymous friend. And massive kudos to Data Collider, they agree. Now that's a really tough thing to actually do. Imagine you're sitting on the scientific fraud case of the decade, and you're asked to delay talking about it by an unknown amount of time, and will end up being many, many more months. That's actually a very difficult thing to do, and I think it speaks volumes to the integrity of Data Collider that the reason why they do what they do is not for fame or fortune, but is instead just for the good and betterment of science. So what follows is Harvard's internal investigation, which is very thorough. It includes taking Gino.
I don't think so. Everything should be transparent. This is incorrect. I mean, this is a discovery. Why should they wait? I don't get it. I mean, basically, you want to go through peer review. You want me to wait publishing until you peer review my discovery. Why should I wait? The public has a right to know. Why should we wait? I don't think this speaks to anything. This is inappropriate. Harvard Business School should never have asked for this.
Gino's laptop away from her by surprise, looking through her files, looking through her emails, her datasets, validating all of the tests that were done by Data Collider and Zoe and her friend, and also conducting many interviews with Francesca Gino and all the co-authors involved. All of this is an extremely lengthy process. Apparently, it took 11 months to complete. And at the end of this 11-month investigation, the result was a 1,300-page report, which concluded that, indeed, Francesca Gino is guilty. Now, I should say that at this point in time, this report is a little bit of an enigma. No one has seen it except for Harvard people, not even Data Collider. But nevertheless, the dean of Harvard Business School, Dean Data, when he receives this report, says, I have to accept the conclusion of the report, and decides to fire Francesca Gino, or technically put her on administrative leave without pay. Then, following this, Data Collider published their 4 blog posts, each one relating to a different study originally found by Zoe. And so hopefully you can see that by the time the Data released their 4 blog posts, these allegations have gone through multiple layers of checks by multiple groups of people across literally years of validation. And the conclusion to all of this testing and validation is that Gino is guilty. And that brings us to the fallout. Chapter 4, the fallout. These 4 blog posts by Data Collider go insanely viral. My own video covering the first 3 of these blog posts gets nearly 2 million views, which would be insane today, but at the time I only had 10,000 subscribers, and so it was absolutely bonkers for a small channel like me to get that kind of viewership on a video. But I am far from the most important person or most well-known outlet for talking about this case. Basically, every other major news organization was also talking about this, from the New York Times, the New York Post, NPR, The Guardian, the list goes on and on. Everyone seemed to be captivated with this case of Francesca Gino, and the result, of course, of all of this publicity was that Gino's reputation was ruined. And well, Gino wasn't going to take this lying down, and so here came the lawsuit. Chapter 5, the lawsuit. After such widespread coverage of these findings, Francesca Gino decides to hire a top lawyer, a guy called Andrew Miltenberg, and decides to sue Harvard University, Dean Data, and the guys at Data Collider for defamation. Rather famously, this lawsuit was asking for $25 million in damages, which is an eye-watering amount of money and something very scary to have over your head. So my heart goes out to the guys at Data Collider who had to deal with the stress of being sued. A lot of people in the scientific community felt it was very unfair for Francesca Gino to go after Data Collider in this case, and so a GoFundMe is started.
Wow, she came after Data Collider. Unbelievable.
to raise money for Data Collider to help them in this lawsuit, which is no doubt going to be extremely expensive. This GoFundMe raises a lot of money, way surpasses the goal in a short amount of time, and so the support from the public for Data Collider was very clear. Harvard and Data Collider filed a motion to dismiss this lawsuit, but the hearing of their case was not to be for many more months. During these many months, Gino tries to defend herself on one of the papers via a website she sets up called Gino versus Harvard. On this website, she provides some half-convincing arguments that I covered in a previous video, but I think the overall general sentiment amongst the public was still very much in favor of Data Collider. But then in March of 2024, another major development happened, which was the release of the report. Chapter 6, the report. So in March 2024, there was a motion to unseal the Harvard Internal Investigative Report. This was supported by major organizations, including the New Yorker magazine, and when the report was unsealed, aka made public, everyone could read exactly what Harvard's internal investigation did, what the evidence was, and what Gino's defenses were.
How? Harvard is a private institution. How can you force them to publicize anything?
During the entire process. And well, when you look at Gino's defenses in the report, they don't seem very strong. One of the most shocking revelations from the release of this report, which I covered in a previous video, was that Gino actually had accused one of her former co-authors of maliciously manipulating her dataset in order to get back at her in some way. This person was redacted from the release report, but I'm 99% confident that the person she was referring to was Nina Mazar. But when you consider the timelines and the motives of this entire saga, it just seemed really implausible that that is actually what happened. Like, I highly doubt that Nina Mazar had anything to do with this kind of data manipulation. And that's what Harvard's internal committee also said. They agreed that it is highly implausible that Nina Mazar was the one who actually did this data manipulation. But there were actually other things that were revealed in the report that I never even covered on this channel. For example, here's me reading the coverage from the New Yorker magazine. They write, in perhaps the most comically inept example of alleged misconduct, the apparently falsified data in a file had been deliberately highlighted in grey. In one case, the description of a study had been revised over several successive drafts and in plain sight of the co-authors, seemingly to compensate for fatal flaws that had been pointed out in the original design. Gino's defense against this allegation is that the research team hadn't kept careful track of which version of the paper they were working on. In other words, that an entire group of elite business school academics was, when it came to basic project management, functionally incompetent. So the public release of this report basically sealed the deal on Gino's credibility. Everyone could see that the report was extremely thorough, I mean 1,300 pages long, and everyone could also see that Gino's defenses to the allegations just seemed really implausible and unlikely. But just when you thought things couldn't get any worse for Gino, they did. Chapter 7, plagiarism. A month after the report was made public, a postdoc from Montreal called Erin Ackland just randomly decided to look into Francesca Gino's work out of curiosity. And she literally had to look at one chapter from one book that Gino wrote and immediately found evidence of plagiarism. A little bit of digging later, and Erin Ackland had found multiple examples of plagiarism in basically every book that Gino has ever written. Science Magazine then published an expose revealing these details, and this basically just removed any last shred of credibility that Francesca Gino had. I mean, she was already scraping the barrel at this point, but this really took the barrel away. Because at this point, the only thing that Francesca Gino really had going for her in terms of credibility was that the opinions of people who worked with her were mixed as to how plausible it was that she would engage in this kind of unethical behavior. There was a large group of her co-authors and people that she worked with that said that they found it highly unlikely that Francesca Gino would be the kind of person to engage in unethical behavior. But with these multiple accounts of plagiarism across many different years, across many different books, it just shows that Francesca Gino is sort of not afraid to engage in unethical behavior, and this is clear evidence of that. Which then brings us to today, Chapter 8, the dismissal. So just over a week ago before filming this video, Harvard and Data Collider's motion to dismiss Francesca Gino's $25 million lawsuit was successful. It was done by a federal judge in Massachusetts, guy called Judge Myung Jun, which is a great result in my opinion. Like I said up front, Joe Simmons wrote a very nice tweet about it. Joe Simmons is one of the guys at Data Collider, and he wrote, Gino's case against us has been dismissed. Scientists cannot effectively sue other scientists for exposing fraud/errors in their work. Those who work to correct the scientific record can sleep better tonight. Those who don't want to correct it, well, I don't care how they.
Wow, unbelievable. Scientists cannot effectively sue other scientists for exposing fraud errors in their work. Unbelievable.
sleep. So great.
I mean, important. But in the long run, it's it's a losing battle.
Outcome in the end. The reason why this is such an important outcome is because if this case had gone the other way around, it would have set a very bad precedent in the industry. It would have set the precedent that if somebody wants to correct the scientific record and raise concerns of academic fraud, that they could then be sued into the ground by the people that they were accusing, which of course would only discourage this kind of very positive behavior that we see for people like Zoe Ziani and Data Collider and others. However, the good news is that because the case didn't go that way, and instead this case was dismissed relatively early in the process, it shows that these kinds of lawsuits from the accused are likely to not be taken very seriously. However, in many ways, this is still only a partial victory because in a lot of ways, the lawsuit in itself was the punishment. Being sued for $25 million is of course very stressful, and the uncertainty of it is very stressful. And so the case getting dismissed is of course great for Data Collider, but it's really the best outcome of what was just a terrible situation.
Unbelievable. So no one else in the world is ever going to dare expose fraud. It's just too expensive.
Science. So hopefully this is my last ever video on Francesca Gino. This case has obviously had a massive impact on my field of behavioral science, but I just want to thank you guys for all the support that you've shown the channel on me covering this very story. I know it's captured a lot of your.
It's behavioral science that suffers the most from these frauds. It's like the science that studies these frauds suffers the most from these frauds. What are the chances? It's not physics that suffers from these frauds.
Imaginations, and I'm glad it's resonated with such a large audience. I really appreciate it. So on this video, by just giving you a little bit of food for thought, there's this phenomenon in behavioral science. It's called the Streisand effect. It was named after Barbara Streisand when, in 2003, she and her attorney tried to get this rather obscure photo of her house removed from the internet. It was a photo that was taken to document coastal erosion, but she didn't want it on the internet, and so they tried to get it removed. But the irony is that in her efforts to try to get this photo removed from the internet, instead this garnered a lot more attention to that photo, and the opposite result occurred. So the Streisand effect is when people try to bury something from being public and instead draw more attention to it and make things worse for themselves. So if you're an academic who's accused of academic fraud, maybe don't sue the people accusing you for $25 million because you're only going to make things worse for yourself, like Francesca Gino did. Instead, admit your mistakes, take the L, and move on. Thank you guys so much for watching. Thank you for all the engagement, and I will see.
She should have just moved on and gotten a job somewhere else. Just recused herself. I mean, just quit her job in Harvard and whatever. Just get a job somewhere else. No one cares. She's still going to get a job. somewhere else, probably.
See you in the next video. I appreciate it. Thank you. Bye.
Fascinating. Oh. Mhm. Okay, let's get back to quantum mechanics. Anyway, so this is not a standing wave. This is just a normal wave. The electron is waving, but it's not going up and down as it's waving, or maybe it is. It could be moving. We don't know, right? So when Schrödinger came up with the wave equation, he really wanted to know, okay, what can it look like? So let's impose all the constraints on something that can wave, and let's see what we get. And let's solve it, see what we get. And he got, and whatever he got, it seems to be doing a good job. Okay, 1 second. What are these notifications? Very nice. So 2 from Cape. Oh.
Good afternoon, viewers. We are here at the countdown clock for the Crew 9 mission, where there's finally going to be an opportunity to bring these 2 astronauts stranded on the ISS back home. Of course, they won't actually be coming home until February, but at least they'll have the comfort of knowing that there's a spacecraft available for them back to the ISS, assuming everything goes well. In spite of the storm, everything seems to be going smoothly out here at the Cape. The rocket has been moved out to the launch facility. Everything looks go for tomorrow. Of course, unpredictable weather may make some changes and all of that. I'll keep you guys up to date, and I should be coming to you live in less than 24 hours. So until then, I urge all of you to stay angry about space.
This guy's an idiot. I mean, he's one of the best reporters when it comes to space and SpaceX. He used to be really good, but as time continues, he's not as good. So he we need to have competition for SpaceX, and we cannot rely only on SpaceX. SpaceX has a monopoly to do this and that, and Boeing is going to also do it. This is so good. Oh, Boeing, yeah, we cannot have a monopoly. And then Boeing ends up being a complete flop. And there was never a reason for Boeing in the first place. And he supported it and he pushed it so much. So for that reason, I consider him, and for other reasons, I consider him an idiot. But he's still, relative to everybody else, he's one of the best, if not the best. Yeah, let's close that and get back to... Okay, so let's continue.
It started. And so
angular momentum is quantized. Very interesting. So this is what Bohr said. Bohr came up with this notion that angular momentum is quantized. I think basically what he said is that if it's waving, right? De Broglie said it's a wave. The electron is a wave. Basically, trust me, the electron is a wave. That's what De Broglie said or postulated, without any evidence. And Einstein said, yeah, he's onto something. There was no evidence. This was the complete postulate, just no evidence. And Schrödinger and Bohr took De Broglie seriously. And De Broglie is the first time, basically, there was evidence that the electron is a wave. Because Bohr came up with a model that was based on De Broglie, and Bohr was able to explain, had immense explanatory powers. Bohr's model was great. So now comes Schrödinger. So Schrödinger is already, he knows it's a wave, but what exactly does it look like? So So he gets invited to speak by a guy named De Boer. A weird name that is similar to everybody's name. De Boer, the bar, the barn. Anyway, at the end of the lecture, this professor asks him, "So what does it look like?" Very nice lecture. You explained De Broglie and Bohr and everybody very nice, but so what is it? What is the wave? It's so the electron is a wave. Nice. Okay. What does it look like? So Schrodinger went home, came back with the wave equation to describe the wave of the electron. That's very nice. So, but Bohr already said that the electron orbit must be n times lambda long. The length, this length must be, well, the first orbit or orbital is lambda long. So what is lambda? Lambda is the wavelength of the electron as de Broglie predicted from however he predicted it. So from de Broglie, we know the wavelength of the electron, that it's a wave. So Bohr said, well, if it's a wave, it cannot wave around the nucleus unless it's at least lambda long. That's the first orbit. The second orbit or orbital is twice lambda. And the third is 3 times lambda and 4 times lambda. And that's basically the angular, right? So, and that's the quantization of the orbit. And therefore, since there is a velocity and a linear momentum, and therefore an angular momentum, so you quantize the orbit, you're quantizing the momentum. Anyway, I don't remember exactly. I mean, when right, because you increase the energy as it goes up, you're increasing the energy of the system. Anyway, let's see what he says.
If we consider that the total length of the orbit is length L, and that we start off at point X, then you can say that the wave function, when we start, is e to the I k x. There is no omega t term here because there is not a traveling wave. We only need the ikx term. We can find out.
That's incorrect. Yes, there is a traveling wave. We're just suspending it. We're taking a snapshot, let's say at t equals 0. We're not letting t move in time. That's all. I mean, the wave equation is perfectly capable of making a prediction of the motion of this wave in time. See video on the wave function. Okay.
More about.
This is so fascinating. I find this whole thing just so incredibly fascinating.
Why we use this wave formulation in my video on the wave.
No, you never explained why you use this wave formulation. You did not. You pretended to have done that, but you did not do it.
Function. So psi is e to the I.
Did you hear the way he said function?
Not a traveling wave. We only need the ikx term. You can find out more about why we use this wave formulation in my video on the wave function.
You heard that function? He didn't pronounce it completely. That's because his brain was occupied. This happens when you lie. When you have to think about what you're saying, you mess up what you're saying. So when somebody says something and he mispronounces it, then that's evidence that he knows he's lying. So he knows that he doesn't, he knows that he doesn't know why we use the I. There seems to be no reason to use I. And he never explained it, and he's pretending that he did explain it. Teachers do this often. They lie. It's fine. That's the way it is. That's the way it is. Anyway, so he's using the time independent wave function. That's fine.
So psi is e to the I kx when the electron is at point x. But once the wave has gone all the way around and come back to point x, it has gone a distance x plus L. And so psi equals e to the I k x plus L. But those two wave functions must be the same. So e to the I k x must equal e to the I k x plus L. And that can be written e to the I k x times e to the I k L. The e to the I k x cancels, and you end up with e to the I k L equals 1. How can that happen? Well, it can happen if k.
So e to the ikx equals e to the ikx times e to the ikl. Well, you can divide both sides by e to the ikx. So e to the ikl equals 1. Okay, how could that be? Well, take the natural log of both sides, and then ikl equals natural log of 1, which is 0, if I remember correctly. So IKL equals 0. So so L equals 0? I don't know.
K or L are equal to 0. But that's a rather trivial solution. But it can also equal 1.
Wait,
The e
what?
to the ikx cancels, and you end up with e to the ikl equals 1. How can that happen? Well, it can happen if k or L are equal to 0. But that's a rather
K equals L equals 0, but that's a trivial solution. E to the 0 equals 1. Anything to the zeroth power is 1.
trivial solution. But it can also equal 1 if KL equals 2 pi. Why is that the case?
Oh, because of the expansion that e to the IKL is equal to cosine KL plus or minus I sine KL.
Because if KL equals 2 pi, then e to the IKL equals e to the I 2 pi, which equals cosine 2 pi plus I sine 2 pi. Sine 2 pi
Oh, it's plus, okay.
is 0, so that.
So KL, I mean, you don't have to guess that KL equals 2 pi. You can just expand it. Cosine of 2 pi is cosine of 0 is 1, and this is 0. So this is 1. So e to the I 2 pi is 1. Which is incredible. You might say, oh, look, e to the I something equals 1. How could that be? Yeah, because there is an imaginary part that we're ignoring.
That term goes, and cosine 2 pi equals 1. So
Wait, yeah, that's because that's 0. Oh, yeah, that's amazing. So it's even if you don't ignore the imaginary part, it's 0. So that's perfect.
KL must equal 2 pi or any multiple, whole number integral multiple of 2 pi. I'm going
And
to call it 2 pi m, where m is an integer of value 0, 1, 2, 3, up to any number you like, but it must be an integer number. What is L? L is the distance around the circumference of the circle. And that is
which is, I mean, the Bohr said L is n lambda.
2 pi r, where r is the radius of the circle, the distance between the electron and the proton. So 2 pi r times
I don't know why he's not saying that L is n lambda, as Bohr proved.
k is 2 pi m. And that means
So L is 2 pi r. And what is this?
that r times k equals m.
I can't read it. What is that? Pi r k? Let me see.
And that is simply 2 pi r, where r is the radius of the circle, the distance between the electron and the proton. So 2 pi r times k is 2 pi m. And that means
2 pi r k? Well, there must be a 2 on the left that we're missing. So 2 pi r k, he's multiplying by k. Well, what is k? K is 2 pi over lambda.
that r times k equals m. But in a previous video, I have shown that k is equal to p over h bar.
1 second. So this is 2 pi r. 2 pi r k. K is 2 pi over lambda. So here's 2 pi n. is k what 2 pi. So rk is n. I don't know what is he saying here. I don't understand. I'm completely baffled. There's 2 pi r here. There's 2 pi r here. I mean, there used to be an L. The L is gone now. What is he trying to say? I don't get it. 2 pi r is the length of the circumference. 2 pi r times k. Isn't k 2 pi in itself over lambda? What's going on? Why is this 2 pi n? K is 2 pi n? Where is this from? Let's see what he says. Let's
Radius
hear
of the
it.
circle, and that is simply 2 pi r, where r is the radius of the circle, the distance between the electron and the proton. So 2 pi r times k is 2 pi m, and that means that r times k equals m.
I don't get it. I don't know what he's saying here. 2 pi rk is 2 pi n? K isn't k. What am I missing? Let's go back. Did he say anything about k?
1. So KL must equal 2 pi or any multiple, whole number integral multiple of 2 pi.
I'm going to call it.
Oh, here KL equals 2 pi and 2 pi. This was just the conclusion we arrived at. So K equals n2 pi over L. So that's K. Okay, we need to remember KL equals n2 pi. I need to write that down somewhere. Oh my god, how can I do that? Anyway, can we remember this? KL equals n2 pi. I'm gonna write that maybe in the comment section. So 731 KL equals n2 pi. "68 comments. Has anyone, as I think I set out, this is a very simplistic way I derive." Okay, no one else needed this note. It's fine. Okay, so we wrote a note to ourselves. KL equals n2 pi.
M is an integer of value 0, 1, 2, 3, up to any number you like, but it must be an integer number. What is L? L is the distance round the circumference of the circle, and that is simply 2 pi r, where r is the radius of the circle, the distance between the electron and the proton. So 2 pi r times k is 2 pi m, and that means that r times k equals m. But in a previous.
So 2 pi rk is 2 pi n. We multiply by k. 2 pi r k is 2 pi n. What is k? K is 2 pi n over L. K is 2 pi n over L. So 2 pi n over L. L is 2 pi r. So it's 2 pi n over 2 pi r. I don't know. What is he doing here? This is so confusing. This is at 8 minutes. Has anyone mentioned this issue at 8 minutes? What happened here? I'm looking through all the comments. Um, no one is asking? No? Let's try and listen to this again. I don't know what's going on here.
I'm going to call it 2 pi m, where m is an integer of value 0, 1, 2, 3, up to any number you like, but it must be an integer number. What is L? L is the distance around the circumference of the circle, and that is simply 2 pi r, where r is the radius of the circle, the distance between the electron and the proton. So 2 pi r times k is 2 pi
Okay, so this is KL.
m, and that means that r times k equals m.
Okay. So before he said that KL, right? KL equals 2 n2 pi or 2 pi n. Okay. So that's L. So he's taking L and he's substituting for L 2 pi r, right? You're saying that L is 2 pi r. Well, LK is 2 pi n. That's from before. LK is 2 pi n, but L is 2 pi r. Substituting 2 pi r for L is 2 pi rk. Now we know 2 pi rk is 2 pi n. Oh, so 2 pi drops out, so rk equals n. Sorry. 2 pi drops out, 2 pi from both sides, n. So rk equals n.
But in a previous video, I have shown that k is equal to p over h bar, and therefore r times p
Okay, fine. P over h bar from de Broglie.
over h bar equals n. R is the radius.
So k is p over h bar. So r, p over h bar, is n, is an integral value.
And that is a constant. H bar is a constant. And what this means is that the momentum p
What's
is quantized
constant? N is a what?
over h bar. And therefore r times p over h bar equals n. R is the radius, and that is a constant. H bar is a constant. And what this means is that the momentum p is quantized. Rp equals mh bar. P is mv, so mv r.
So assuming r is a constant, then momentum is an integral value. I don't get it. What is he trying to say? For the same radius, you can increase the momentum? With holding the same radius, you can increase the momentum with the same radius? How?
Is quantized. Rp equals mh bar. P is mv, so mv r is, and that p over h bar. And therefore r times p over h bar equals n. R is the radius, and that is a constant.
R is constant. You're going to hold R constant and claim that P can grow in jumps? So you can increase P and hold R constant?
H bar is a constant. And what this means is that the momentum p is quantized.
This is not angular momentum. RP is the angular momentum. RP is L, angular momentum. That's quantized. But you're not holding R constant and increasing P. That wouldn't make any sense. You mean the electron can rotate? You can change the velocity, because you're not going to change the mass. So you can change the velocity of the electron and hold it in the same orbit? That's not possible. You're violating the equation. You're violating Coulomb's law.
RP equals mh bar. P is mv, so mvr equals mh bar. And mvr is angular momentum. And therefore, angular momentum comes in quantized units.
So he just said nonsense. He doesn't understand.
Is equal to p over h bar. And therefore, r times p over h bar equals m. R is the radius, and that is a constant.
No. R is not a constant. RP is angular momentum. You don't need to go any further. RP is angular momentum, or R cross P is angular, but it's 90 degrees. So RP is angular momentum, and it is a multiple of n. It grows in quantums. It's right. It's basically RP equals NH. Or L, the angular momentum, is equal to NH, meaning the angular momentum is a multiple of H. But you can't say that you're holding R a constant. That's nonsense. That shows a complete lack of understanding. 1 second. R, he said R is a constant?
H bar is therefore r times p over h bar equals m. R is the radius, and that is a constant.
R is the radius, and that is a constant. Oh my god. R is the radius, and that is a constant. Sounds like a joke. If R is a constant, then P cannot change, because M certainly cannot change. Then if V changes, then we are no longer balancing Coulomb's law. I don't know. I don't know what he meant. I don't know if he was thinking.
H bar is a constant. And what this means is that angular momentum, P, is quantized. RP.
He said momentum. It's like angular? Did you just say angular? Yes or no? I mean, I don't know what he's saying. He's mumbling.
H bar is a constant. And what this means is that angular momentum, P.
Angular momentum? Look, ang. It says here ang. Constant H bar is a constant, and what this means is that ang, that's momentum, and then he said that. Okay, so he took back the ang. Okay,
is quantized.
so what's quantized?
H bar is a constant. And what this means is that angular momentum, P, is quantized.
Okay, momentum P is quantized? No. No, it's not. RP is quantized. P is not quantized, is it? If RP is quantized, does that mean P is quantized? I mean, I guess it does. No, it doesn't. It's only RP is quantized only because, I mean, there is another constraint that L must be n pi n times 2 pi. But from here, you don't see it. You don't see the quantization of P. R and P could be any value. That's why he said R is a constant. Oh my God, he does not understand what's going on. There's no way that he was understanding this as he was saying this. It's complete nonsense. Complete and utter nonsense. Oh my God, and I need oh my God. I've gotten to a point that I can easily see through these teachers, including Sean Carroll, who is like the #1 teacher in this space. So why can't I see? Oh, wait a minute. Did somebody make a comment in my video? No, there's no comment in my video. So, but I did get a comment in my app, in the YouTube app. So I don't know what's going on. Interesting. Anyway, I'm very happy that I'm finally at a point that I can easily converse with physicists and scientists, especially physicists, people who seem to understand physics, and I'm able to, what I would describe as, run circles around them with really minimal knowledge, just because my fundamentals are sound. That's my feeling right now. I feel very confident. Like in the beginning, when I started researching quantum mechanics, I honestly had no idea what's going on. And it looked insurmountable. It looked really something impossible. I just had no idea how I could ever grasp this stuff. It made no sense. But I think at the point that I realized that particles don't exist, that it's only waves, which is actually at the beginning, right? Because I came from the realization of the ether. The ether doesn't allow, my intuition of the ether did not allow for particles. Once I assumed there are no particles, so my intuition drove me, and I don't remember exactly when I started really understanding quantum mechanics, but now I'm at a point that I really understand it. I mean, I don't really understand it, but I'm able to listen to people explain it and find their errors very quickly. Especially this guy. Like, I appreciate this guy more than anyone else. The rest of them are maybe more difficult to debug because they're not as clear. This guy's purely clear. He's purely mathematical, so it's very easy to find his mistakes. Anyway, R times P is quantized. That does not mean that P is quantized. P is quantized for a different reason, not for this reason. So this is 834. 834. So he said, Let's listen to it again.
H bar is a constant. And what this means is that angular momentum, P, is quantized. Rp equals M.
He just said P is quantized. P is quantized. P, this equation says that Rp is an integer or integral. It does not say that P is integral. This is why he said that R is a constant, which is nonsense. Why would R be a constant? R is not a constant. The radius is a constant? Of course not. I mean, it goes through orbits. R can change when an electron switches orbits. Anyway, good stuff.
M H bar.
How much time have we been here? Almost 3 hours. Yeah, I'm gonna quit soon, take a break.
Heat is MV. So MVR equals MH bar. And MVR is M.
So it's really amazing. So I've done research into fields previously. Like I've taken a field that I knew nothing about and I took a plunge into it and became an expert in my own eyes, which are the only important eyes as far as I'm concerned. So I became an expert in multiple fields. But when it came to quantum mechanics, it's like with any other field. Like in the beginning, I was hopeless. I knew I trusted myself that I should be able to accomplish it, but it felt like this is going to be a miracle if I'm going to make actual progress. But like with everything else, like you don't let up, you don't give up, you keep pushing forward until you get it, and that's it. Just don't give up, just keep pushing. Yep.
Angular momentum. Therefore,
Angular momentum is already here. This says that Rp equals NH bar. Rp is already angular momentum, which is NH bar. So NH bar, like, what is... Oh, he said it here. Okay, Rp equals NH bar. And Rp, he changes its name to MVR. That's so ridiculous. Like, you're going back. You started from MVR. Like, didn't you? Didn't this discussion start from MVR? Oh, there was no MVR here? Okay, fine, whatever. Anyway, RP is yeah, but you should use little l, for angular momentum. Anyway, so angular momentum is quantized. That's just Bohr. That comes out of Bohr. Okay.
It comes in quantized units of whole values of H bar. And that is the third term that we need for this cheat solution of the Schrodinger equation. So now let's proceed. We can write that m squared, v squared, r squared equals n squared, H bar squared, which is n.
So he's squaring both sides for some reason. N squared, v squared, r squared equals n squared, h bar squared. Okay.
N squared, h squared over 4i
He doesn't need MVR. I mean, he could have L, but fine.
squared, since h bar is h over 2 pi. These
So h bar is h over 2 pi, so it's h squared over 4 pi squared.
squared, which is the velocity squared, is n squared h squared divided by
So, sorry, this is the velocity squared. So he's going to take m squared r squared, bring them over to the right side, okay?
4 pi squared m squared r squared.
Continues on video part 2. So, yeah. This is n squared h squared over 4 pi squared m squared r squared. Good. Okay. I'm gonna stop here. I have to go take a break, eat, and then I'll come back. Good stuff. Really good stuff. You know what? Before we take a break, let's see if there's anything interesting. Oh, there's very few people, and there's 2 VCs going on. Oh, but these people are not talking. That's weird. No one is speaking here. Let's go here.
The number of people dying from cancer skyrocketed. And when I say the cancer, I'm not talking about people had cancer, then they caught COVID, and then they died. I'm talking about people with treatable cancer not receiving the treatment.
Well, is that related to lockdown? Is that related to the fact that with a lot of people with COVID and the health systems were overwhelmed and people with all sorts of diseases were dying?
No, unfortunately, when you look into it, it appears that what happened is these people, they just were not showing up as much.
Yeah, it was like a backlog of people who would go to the doctor to check themselves, and people had cancer and didn't know.
They did not show up, and it seems that it was not because it wasn't because the medical staff were overloaded. Remember, these doctors who deal with the cancer patients, they are specialized. As specialists, sure, they could be used for treating COVID patients in a pinch, but the specialists will always be taken up by their special cases. So these people, they were available. Nothing, but the patients would not show up. Many children would not go to school.
Hello?
There's no getting around it to simulate it. That doesn't make it reality. And that's where QE fooled us. I don't even know if he fooled himself too, but I know that that's his DV, his wave function, his IV, his knowledge of which path. And I know that his DV is wave function collapse. And I know that wave function is mathematics.
Wave function is not mathematics. Wave function is a model of a wave.
Oh my God. What do you mean? What do you think a function is, dude?
I mean, right. It's a model. It's a model that expresses reality. What would we?
It's a mathematical model. I agree. So diffraction would be the reality of it. So now if he were to say that diffraction collapses with knowledge of which path, there's a reason he won't say that, because the diffraction doesn't collapse. It's ridiculous, dude. And he admitted that, go back, watch my videos where he boldly admitted that the double slit is not an experiment.
Wait, the double slit is not an experiment?
According to QE,
Erwin, it is.
No, according to Quantum Eraser, when I called him out on it, I called him out because I was trying to talk about Michelson-Morley. I could use the same thing for Michelson-Morley. I could say the fucking knowledge of which path the light went down, you know, or with Airy's failure. I could say diffraction. No, for my natural phenomenon, I could use diffraction, and I can line it up the same as double slit.
Wait.
And then that's when he said that
Wait, one at a
the
time.
double slit's not an experiment.
Wait a minute.
I got it. Trust me.
Wait, one at a time. So Michelson and Morley, they got a null result. What, you're saying they did not conduct an experiment?
Well, he's saying that it's not an experiment. When I'm telling him that it's just as much as an experiment as the double slit. If you're going to use diffraction as the natural phenomenon, well, that's what we're observing is the diffraction.
Sure. Yeah, these are all good
But anyway,
experiments.
I'll post a video of him saying it.
Anyway, okay, people can say whatever they want. At the end of the day, you need to be convinced. So
Yeah, I took it as read that light was a particle there for a while. So I think Darwin did too, even though he knew better internally. I think he finally conceded. And
I didn't.
Well, you should have. I mean, you shouldn't have. Good if you did. No, you. I mean, my bad. I respect you, man. I meant to say you shouldn't have. Always stick to your guns if you know you're right, or if you know you might be right.
I wouldn't say light is a particle. I would say light is a wave. Why would you say light is a? What evidence do you have that light is a particle?
It's not a wave.
The double slit.
The double slit says light is a wave.
It collapses the wave function into a single point.
It collapses, but it doesn't collapse with diffraction. Nothing in reality collapses diffraction. It's a known phenomenon. There's no way to collapse it except for to stop it from interacting with something.
Yeah, but all these, y'all talking about waves, particles. According to the science part of it, it says that light exhibits properties of both particle and wave, but it's neither. That's what science says about it.
Because it interacts with solid. It interacts with like with solar panels, the photoelectric effect. When you're talking about solar panels, because they're saying that it physically reacts with the electrons. Okay, so look, it physically brings heat and energy. Okay, so for that they count it, and they call it a particle because in that fashion it does act like a particle. If you're saying that the electron is a particle. But but that doesn't mean it's actually a particle. That's just the way they model it.
What evidence do you have that light is a particle? What's the evidence that light is?
Well, he would say the photoelectric effect, and I would say that's a good model.
No, hold on.
But it's not reality.
Wait, I don't know what it means. He would say, who wants to claim that light is a particle? Let them speak. Okay, so that settles that.
I only spoke up because nobody else did. I don't think nobody here would make that specific claim.
Okay.
But there's a big part of this community that would. I don't think any of them are here. If there are, speak up.
Well, I need to debate someone who believes something in order to debate them. I cannot debate. There's no point in that. So as far as I know, there are no particles in this universe. Everything is waving through the ether. If someone wants to convince me that there are particles in this universe, I'm open-minded to hear the evidence. As far as I know,
well, define particle. That's a bold claim. Define particle.
Wait, do you mean matter isn't a particle?
So what I mean is, as far as I know, there's the only type of particle that exists in our universe is the ether particle. The ether fluid fills this universe, and everything we call elementary particles, those are just waves or wave types in this in the ether. That's how I view it. So if you have evidence, go ahead.
Can you describe the property of the ether particle? What are the properties? What does it weigh? What's the density? What color is it? Any of that?
Well, we know a lot about it because we know how, from Maxwell, we know, for example, that the maximum waving through the ether is what we call the speed of light. So that's one thing we know about the ether.
Okay, so if like just take a simple particle of water, what we would call a particle of water, what would you say the properties of water is, if not having mass, not weighing anything? What are the properties that make you say it's not a particle?
I mean, so what? I mean, I mean, you need to present evidence that something is a particle. As far as I'm concerned, everything is a wave. I mean, right? I can bring you tons of evidence that an electron is a wave, that light is a wave. So if you want to convince me that light is a particle, that an electron is a particle, then submit your evidence and we'll discuss it.
No, I didn't. It didn't say light was a particle, but you're denying matter as being particles, and I think you'll have trouble doing that.
Look, what we call an electron, it behaves on the macro level. It behaves like a particle. Like we see a stream, a beam of electrons. So, or I touch the doorknob and I see a spark. That seems to be, well, that looks like particles. That's fine. But when you actually submit the electron to the double slit experiment, it behaves like a wave. So all the data, like on the macro level, it seems to be one thing, but when I actually stress test it, it's not that, it's a wave. So yeah, it looks like a particle to us that we're so big. But when you actually test it, you let the electron go through a crystal, it behaves like a wave. It interferes with itself, which is a wave. So it's a wave. It's a strange wave. It has a mass. It interacts with the Higgs. It doesn't disperse. It keeps its integrity. That's all fine, but it's waving through something. So I say, okay, it's waving through the ether. It's okay. You don't have to accept that. We can discuss the ether, but it's a wave. All the evidence is that there are only waves. There's no particle wave duality. There's only waves. That's what I'm saying. There's no data. There's no evidence of particles. All the evidence of actual stress test experiments is everything is a wave. When you actually test the particle, it's a wave. So it's a wave. Like I might seem like a strong guy, but when you actually stress test me, I'm weak. So I'm weak. I might seem strong, that's fine, but I'm actually in a stress test. That's what counts, right? When you test something, that's when you discover what it is. Okay, I might seem strong from who knows what, but when you stress test me in a laboratory condition, you discover the truth, right? And you run the experiment to discover the truth. And all the stories are nice. I can tell you that I defeated 10 bears this morning. That's nice. Let's put me in a cage now with a bear and let's see if I survive. If I do, then fine. But
this is what we just went full circle, because like you guys are both in disagreement regarding the double slit experiment. We're trying to acquire knowledge, we're trying to acquire truth, but yet we can't come to a reasonable conclusion regarding this experiment.
What's the question? Ask me any question about the double slit experiment.
Not an experiment.
I've seen a PhD say that if you can give some kind of logical, coherent explanation as to why it happens, you'll get a Nobel Prize.
What happens? What's the question? Ask me any question.
The math fails. Wave function collapses. The math failed. That's what happens.
What do you mean the math fails?
It's it's not about math. It's about why the light does something different when we know the path.
Wait, what? I didn't even hear that last word you said. What's the question? Ask me any question about any double slit experiment. I'll gladly answer. What's the question?
Okay, why does the light do something different when we know which slit it went through?
I can barely understand what you're saying. Maybe speak louder and clearer.
My bad. Why does the light do something different when we know which slit it went?
Oh,
We have no.
okay. So when you block one of the slits, it behaves just like it behaves as if you shone the light through one slit. It still behaves like a wave. You're still getting a wave result. It doesn't behave like particles. In any case, it never behaves like a particle. But if you block one of the pathways, you no longer get interference. When they say that we put a detector in one of the slits, they mean they blocked that slit. So of course, if you block
Right,
that,
they interacted with it.
I mean, it sounds like you're not explaining the double slit experiment correctly. They have two slits.
Mhm.
You shoot light through it. You get a particle pattern on the board behind it, and then if you measure which slit it went through, it's now a wave pattern because we know
You don't
which,
get a
which
particle
slit it went
pattern,
through.
Jeremy. In reality,
you do get a
don't get
particle pattern. Okay.
You
mean if the light's small enough, like if you make a laser like coherent light, you can squeeze it through. But the point is, we can't interact with light without getting a diffraction pattern. Nothing can. It's that simple. Nothing can interact with light without diffracting it. So anything they use to try and measure it and act like they're not doing nothing, no, you've just fucking diffracted it.
Well, this is the de Broglie wavelength thing Kosho was talking about last night. De Broglie wavelength, about how the smaller amount of mass it is, the higher de Broglie wavelength it has, and then it can start doing weird stuff.
What do you mean weird stuff? There's nothing weird in anything. So ask
There's
me.
definitely something weird with the double slit. I just
There is
explained
something
it.
weird.
I'm still asking.
Know the path, when we know the path, the light does something different. Why does that happen?
Wait. What do you mean when you know? You blocked, in order to know, when you say you know, you blocked one of the slits. That's all you did.
All right, that's the problem here, is you're not even describing the doubles. The double slit is when you shine some photons or electrons through two slits.
Yes.
You get a particle.
So you're calling it a particle to
you get
begin
a
with.
particle pattern on it. Hold on a second. You guys, is my mic low? This guy said
It's
my
fine.
mic was low. Do I sound okay?
It's okay.
You're
Just
good.
Yeah.
speak slow and
So-
mhm.
So you're not describing the double slit. You're describing something else. The double slit is when you have two slits. You shoot some particles through. It has you get a particle pattern on the backboard where the photons or electrons or whatever hit. Then if you measure to see which slit they go through, now you get a wave pattern.
What's the question?
The thing where you block a slit, like that ain't even in my repertoire when it comes to the double slit. I don't know what you're talking about. Some other experiment maybe.
Can't measure it without interacting with it. There's no dot. It's a probability.
I'm honestly, maybe you want to ask the question again, but please stop referencing me all the time, pretending I'm not understanding. I'm describing a different experiment. I mean, at this point in history, we're all talking about the same double slit experiment. I don't know if there's multiple. As far as I know, there's only one type of double slit experiment. We've all seen many videos about it on YouTube. So what's your question? I completely thoroughly let me just be clear. I completely and thoroughly understand the double slit experiment. So you're welcome
Well, then
to
how
ask.
come we're explaining it different? You're saying I don't understand it then? Because in my version of the double slit, there's two slits.
I'm just letting
they
you.
shoot photons
I'm
through.
just hold on. I'm just letting you know. As far as I'm concerned, I completely and thoroughly understand the double slit experiment.
I heard that part. And
So
that,
you're
we're gonna
welcome.
flush it out
No,
right
no, no.
now because
Hold on. You're just welcome to ask me any question and have you come to the same realization as I am. That's all I
we're
can
not
offer
even
you.
talking about the same thing. That's what I'm saying. We can't even go into it because I'm talking about the double slit where you have two slits. You shoot electrons or photons through the slits.
So let's say,
get a
is it?
particle
Hold
pattern.
on. Is it
Hold on. I'm explaining the double slit, bro.
Which
Just
one?
hold on.
Which one? Electrons or photons? You're that's
Either one.
You
Pick
think
one.
no.
Photons.
you think you're
Shoot
physically shooting something
photons
through there,
through a
Jeremy?
double slit. Hold on
Okay,
a second.
so
You
photons.
shoot
Okay,
There's a difference between photons and electrons.
fine,
The
fine.
experiment doesn't behave
It's
for both
fine. It's
last
fine.
time I checked.
Okay. He wants the photons. Let's go with the photons. So you're firing, I'm assuming, a laser beam, right? A red laser beam. How are you firing photons, right? I'm assuming it's a red laser
I
beam,
gotta
right?
go. I gotta go.
Okay,
dude.
it's good.
The thing you were describing is not the double slit. That's all I'm saying.
Here's the thing: if a small enough piece of light, we'll just say a piece, so we're not going to call it a wave or a particle. Like if you want to assume it's particles, you can make whatever prediction conclusions you want, but you've already assumed it's a photon's a particle. But if we just say a piece of light, a small coherent piece of light we've shot through, if it doesn't interact with an edge, you'll always get a spot, no matter how big it is. No matter how big the laser is, no matter how coherent the light is, if it can fit through the slit, it will never give you a diffraction pattern unless you fuck with it, and then you will. It won't collapse if it fits through there. It won't collapse. So so that's fallacious when they act like you were getting a diffraction pattern, but now you're not. No, if it fit through, you never got a diffraction pattern. If it interacts with anything, surfaces mainly, then you will. Period. You never won't.
So the question is, have you ever conducted an experiment, a double slit experiment, and not received a diffraction pattern?
Depends on it. No, but I never made the slits real big. I mean, if you make the slits big and the laser dot fits through there, it won't diffract.
Okay.
But the point of all this,
you have to.
I'm not disagreeing with you, just so you know.
No. Either way, you have to have evidence. Like all the evidence I'm aware of is that in any double slit experiment we ever conducted, we always received diffraction patterns. So if you claim that you can reproduce a double slit experiment and not get diffraction patterns, it's very nice. You need to present your evidence. Until then, it's meaningless.
Here's the weird part of it. If you want to say something's weird, I'd say there is something weird. If you fire enough little dots that fit through the slit, then it will still form the diffraction pattern. That's because it always makes a diffraction pattern to me. To me, that's my explanation. To me, coherent light is not the same as other light. To me, you have to be real specific. And to me, they're begging the question when they're calling electrons and photons particle at the beginning of said experiment, quote unquote experiment. Because
I'm losing you. What's your position? I'm not sure. What is your position?
The position is that light's not a particle as in the way we think of particles as in physical, like as in matter.
I don't understand. I don't understand.
I don't think light's matter. I don't think light is matter that can be described as a particle.
Didn't he just finish saying that light has mass?
Light doesn't have mass.
Does that mean that
light has?
I don't even think air.
Light doesn't have mass. Light has. It has momentum, not mass. Has momentum.
I heard you say it, but you said that.
I said
think
that?
light has energy. I think light has energy, which can move like a solar sail. Like if you fired at a sail that's sitting on water, like an aluminum sail, like a big enough light, or it could heat stuff up. So I think it can interact with matter.
No.
But as far as actual momentum, dude, we wouldn't have eyeballs. If light had momentum, bro, I don't think we'd have eyes.
Wait,
Just
light
saying.
light has momentum. We see from Maxwell that light has momentum. So what's the question? Maxwell,
you're saying it could transfer. That's by assuming.
Maxwell said
I'm
that.
not denying, bro. I'm not denying that light has momentum.
Mm-hmm.
But how do you have momentum,
bro?
Hold on, Brian. I'm asking him a question because I don't know. How do you have momentum without mass?
I mean, for Maxwell, you
Yeah,
see.
that's the definition of momentum as mass over velocity. You can't have
Bro, I
momentum
know,
without mass.
but I'm asking him, dude. I want him to answer, but I appreciate
Well,
you, Brian.
you
But
see.
after he answers, you can answer.
Look, you see from Maxwell that a light wave moves the electron basically up and down, and then the magnetic aspect, the magnetic wave, interacts with the up and down and pushes it backwards and pushes it backwards, basically. So you're pushing the electron. So light with no mass is able to push back the electron, just the way it interacts. The question is, you're asking, how can it push? Action equals reaction. So how could the electron with the mass suddenly start moving? That's a good question. So there's no there seems to be no you would say, oh, there's no conservation of momentum. There is. So conservation of momentum there is, because we never said light does not have momentum. But you're saying F equals ma, and suddenly you're getting ma. So, but okay, we have F. So I'm not so
right. Force equals mass times acceleration. Light has a constant acceleration. Light has momentum. Therefore, light must have mass.
No.
Listen, I honestly don't know. Hold on. Do you think that electromagnetic waves have mass?
No, they don't.
Why not?
There's no evidence that they do, as far as I know. I mean, Maxwell doesn't have M. There's no M anywhere in Maxwell. I mean, there's no, as far as we know, there's no M. There's P. There's MV. But momentum seems to be different than mass. Light seems to have momentum, but does not seem to have mass. I know it's like counterintuitive, but everything works out.
It's impossible. If momentum is mass over velocity, then you got to have mass to have momentum, because it's defined as mass. So you can't split the two. This is where scientists went, bro. They have to they have to keep the Earth in motion. So it's gradually just befucked the fucking definitions and
No. I'm open-minded.
This is observed fact, Brian. I'm sorry that you just light is not mass. It has momentum but no mass. I posted an article.
So what is momentum then, please? What is momentum?
Hold on.
No, okay, fine. Look, light is able to move the electron that has mv, as you said, but light in itself, the mechanism by which it does it, it's the interaction of an electric field and a magnetic field, and it carries momentum without having mass.
Yeah, but listen, if a sugar daddy is defined as caramel and sugar, then you can't have a sugar daddy. You can't have a sugar daddy. You can't have.
Look, I'm explaining. Okay. Let's go through the mechanics, through the Maxwell's mechanics. Just go with me with the Maxwell mechanics. We'll figure it out. I mean, hold on. So look, you have an electromagnetic wave. It's both electric and magnetic. The electro
There's a background, bro. There's a fucking background. There's a freaking medium in Maxwell's equations, bro.
Yes,
an assumed medium.
Yes,
so the light doesn't. The light doesn't need mass. Light doesn't need mass.
Light
Maxwell doesn't have an assumed medium. Stop it.
No. I believe Maxwell.
You see, that's where it comes in.
Yeah.
They can't have a medium.
Hold on.
They can't have a medium or stops, bro.
I have a medium. You talk. I believe in the ether, so I'm with you. Okay, so you have an ether wave that is the electromagnetic ether wave. That's fine. There's no problem with that. And it waves. The electro part goes up and down and moves the electron up. The electron then, as it's moving up, is interacting with the magnetic, which is moving, let's say, to the right. And you're pushing back the electron.
All right.
So the electron.
Can I get in?
Yeah, go ahead.
Dude, I'm trying to figure it out just as much as you are, or anybody else here. I'm picking at your brain because I'm trying to find the answers to these questions that I've had, right? So E equals MC squared is what?
equals
Energy
MC
equals
squared equals MC squared
mass.
is an incomplete part of the formula. I've just posted the complete formula.
Oh, you did. Well, I can't look at the screen. I'm driving. But
Energy
so
equals mass
energy.
times the speed of light.
Hold on, bro. Energy equals mass times constant acceleration, right? So energy.
That's half the equation.
What is electromagnet? Hold on. What is electromagnetism? What is energy? What is force? Can electromagnetism apply force
Yes.
or impart force? Yes, right? So
Yeah, with a
logically
medium.
speaking, right? Logically speaking, it would mean that electromagnetism has mass, but it doesn't. According to the Globers, it doesn't, right? Now, when we talk about ether, right? There's evidence to support that the ether has substantiality.
Yes.
Bro.
How can something how can something have substantiality? That means it has a substance, but yet have no mass.
No.
How can electromagnetism have
the-
a substance but have no mass? Go ahead.
No. The ether has mass. My ether has mass. So there's no issue with that. But
Right.
the
They try to
wave,
particleize.
but
sorry.
yeah, but the wave, the electromagnetic wave. Look, what is mass? I mean, it's a problem to say that the ether has mass, because what is mass? So we know today what mass is. Mass is just the
Density over volume.
No. Let's go deeper. So what gives the electron mass? Why do we say, right? The electron is a wave. Why? How can a wave have mass? So the
Because the medium in reality.
Well, so
because
I'll
it's
tell you-
just a disturbed part of the medium. It's not, to me, it's nothing on its own.
Hold on.
It's just a disturbance in the medium.
But okay, but the electron has mass, right? But the electron is just a wave. How can a wave have mass, right? That's
Hold
the
on, bro.
first question.
Well, this is the thing I'm trying, because I just asked you 4 minutes ago whether light has mass or not. And you're like, no, light doesn't have mass. Now you're telling me electrons have mass, or are
Electrons
you
aren't light.
Electron is
all
not
right,
Electrons
fine.
aren't light.
What about photons?
Yeah,
Photons don't have mass, but they do have momentum because
No, photons don't have mass. Photons have momentum. Photons are described by Maxwell. Those are
You can't have one without the other. Momentum is mass.
no, it's not. Sorry, not always.
It's in motion. It's
Why do you-
mass in motion.
Most of the time, yes, but not in this case.
Most of the time, that's how it's defined.
That's a definition, not the definition.
Tell me the definition of momentum that doesn't have mass in motion, please. Don't just reify it either and say light.
Well, how do you measure momentum? What are the units?
This all backs up, bro. Y'all, this all comes
Pressure.
back down to keeping the Earth in motion, dude. If you trace the roots, I spent like 2 years studying this, and if you trace the roots, this all goes back down to keeping the Earth in motion.
Okay,
Period.
listen,
There's no getting around it.
maybe
Whether
you're
it's
right.
or wrong.
Maybe
this is
you're
where it
right.
stemmed from.
Maybe you're right. Maybe you're right. But for now, you have to convince us. You know, we're right now talking about the details of the ether and an electron and a photon. Let's let go of the planet. The planet is not interesting right now, and let's
It's the whole point, though, man. It is very interesting. Just check it out real quick. This is the last thing I'll say.
Maybe.
Last thing I'll say is that, listen, is that they act like they abolished all they did at best is abolish the stationary ether, a stationary ether at best with Michelson Morley. But because they define it as abolishing and disproving an ether period, then that they had to update all the physics. That's when physics changed. That's the revolution, and that's when shit went ridiculous.
Your incredulity is noted. Relativity is a difficult concept to understand. It doesn't mean it's false just because you don't understand it. The universe is under no obligation. The universe is under no obligation to make sense to you. I'm sorry.
Yes, it is.
You don't understand.
Doesn't Einstein believe in ether?
Hold on, bro.
Yeah,
Jesus
Einstein did believe in ether, and the universe is under absolute obligation to make sense. So
No, it's not, sir.
Okay, that's the show. That's the show. Come on, bro. You gonna actually contribute to the conversation, or are you just gonna talk shit?
Let's continue.
What do you mean?
If
He's just
universe,
he's
if
talking
the
shit.
universe didn't
Wait.
have to make sense logically, then
The-
Occam's razor wouldn't be a thing.
The universe has to make sense. If somebody thinks the universe doesn't have to make sense, you can go join any cult at any time.
So there's no obligation to make sense to any one
Then,
individual.
then why don't you join the nearest cult? Anyway, let's continue.
Well, I could join the flat Earth cult, I guess.
Yeah, you can join
Not
any
even
cult. You can join
doing
all the
anything.
cults
You're
together.
just writing.
If you're
Derailing,
Okay,
derailing.
yeah, we're derailing. Let's continue. So, Brian, what is your claim about Michelson Morley? What's the problem?
Okay, because in Maxwell's with Maxwell's laws, okay, you have you don't need mass because you have a medium, okay, an assumed medium, and that's okay. So now, when you abolish that medium, now you've got to rewrite the physics.
I'm not
But I'll say
abolishing.
this.
I'm not abolishing.
No,
I
I'm telling
believe
you what the mainstream science has
I
done.
don't care.
bud.
I don't care about the mainstream. Talk to me. So I believe in the ether. Everything is fine. Are you unhappy with Maxwell with Michelson?
No. I'm not, see, me and you have a different. I'm just saying. I'm just pointing out when they abolished the medium, you can't have momentum without mass.
me.
Okay, if you're going to believe in
Brian.
let me finish.
But
bro.
I
You're
don't-
interrupting.
but
Listen, you
I-
ask me questions.
No.
I hear me, bro. Why are you doing that?
No, because I believe in the ether. There's
Yeah,
no
hey guys, let's not have any interruptions. Let's try to let everyone like slow down a little bit, let everyone say their full point, and maybe when there's a 3 seconds of silence, it's obvious they're done, and then someone else can jump in.
I'll try and be swift too. As I'll say that it's only in the globe model where you need these new definitions. You need new definitions of mass. You need new definitions of momentum. Okay, momentum is defined as mass in motion. Okay, or mass over velocity. Okay, so that means you can't have momentum without mass. Now, if you want to redefine, not you, but if they want to redefine something, they had to redefine things. They had to re-explain things because they got rid of Maxwell's medium. That's what mainstream did, not you, but mainstream science, and that's the whole point I'm making. Sorry, good.
Okay, got it. Listen, so I believe in the ether, so you can ask me any question you want. So as far as I'm concerned, apparently, you don't need mass and velocity in order to have momentum. Light seems to have momentum. It just seems to have momentum. That's how it works out.
Right, but if something has negative or zero mass, then P would equal negative or zero. And how would you have negative momentum?
It's just that
Negative or zero momentum and still have momentum is my question.
And you can't say that light has momentum over velocity. I mean, mass over velocity, and then say that it doesn't have mass because you've just effectively said that light has mass over velocity. By saying momentum, you're saying light has mass over velocity, unless you redefine momentum. Which, if you do, I'm open to hear it.
I just want to hold on. I want to pick at his brain, bro, because he believes in the ether. So you think that the ether has substantiality? Yes or no?
I'll tell you the problem. So, what is mass? Right? When you say substantiality and stuff, right? This is what we're used to. We exist one level above the elementary particles. The elementary particles are nothing but waves in the ether. So we're so removed from the ether. Mass in itself is just the Higgs mechanism of the ether. So
then everything has mass. I'm good with that.
But the ether particles themselves, I don't know if they have mass. I just don't know. I don't know anything about them.
Well, you're saying that the ether has mass, and now you're making it into particles. You're going down a split road. If you're saying the ether is a substance, okay, like a overarching joining substance, and then you're trying to break it down, bro, you're just doing what they did, but one step further.
No. For me, the ether is fine. It's there. I need it. Just like Maxwell, just like I need it for everything, including gravity. I use everything. Ether for me is the foundation of the universe. The question
is it particles? You just said it's particles. Is it particles?
It's a fluid. I don't know a fluid of what. My intuition is a fluid of particles that have interactions. The problem is that mass is created by the Higgs mechanism of the ether. So how
Bro, you're just
can
kicking the can down the road, bro. That's all you're doing. You're kicking the can down the road. It's the same discussion with the light being a particle or not. And now you're just kicking the can down the road. That's not a discussion, bro. It's not even a fair question.
That's basically what I'm trying to get at, dude. Is that he's saying that light is not a particle, right?
There are no particles. Light is a wave.
So what makes up a field?
There's only ether.
What is a field? Can you define a field?
Well, the ether is a fluid that you are waving through this fluid right now. This fluid is running through you, and that is gravity. And when light shines, it vibrates. It's a wave in this ether. Everything is some sort of wave or motion in the ether. There's nothing of any substance except for the ether. But what is the ether? I know very little about it. All we know...
All right, cool.
Yeah.
That's cool. That's fine. So, but you say it's a fluid. Wouldn't the fluid have substance? And if it has substance, wouldn't that mean that it has matter?
The problem...
Even if the matter... Even if the matter is not
I'll tell you the problem.
We can't observe it. We can't perceive it. We can't measure it. Like,
no.
It's not tangible. The ether, that's why it's ethereal. What if it's just beyond our senses, but it does have material substance?
No. There's like the Michelson and Morley should have been able to see it. Unfortunately, their instrumentation wasn't sensitive enough. But I'm writing a paper on the next Michelson and Morley. It needs to be, we need a 10-kilometer interferometer, not a 10-meter interferometer. So they were 1,000 times unsensitive. What was the question?
Can I just get a quick word in?
Yeah.
2 seconds.
Sure.
Air, when it's at a certain temperature, is magnetic. Can that say that air is magnetic in general, just weaker? So if air itself, as it gets colder, as it gets higher, is getting more magnetic, are we not just seeing magnetic aberration, and that is the ether?
No, the ether is that which light waves through. It's that which is flowing through you right now and is pulling you towards the earth. That is what we call gravity. The ether is the field in which vibrations create the electron. And
Yes, your environment. Your environment is
it's not.
Yeah, but when you're the Michelson Morley was looking up into space. He wasn't looking at each other going, "Oh yeah, I see something different." So if we're looking up and we're seeing magnetic aberration because we can prove that air or
What do you
oxygen,
mean?
sorry, oxygen.
What do you mean magnetic aberrations?
Wait. He's describing gravity as a force, bro. We know for a fact, whether you're flat earther, whether you're globe earther, if you're upward current type, you know that for a fact, gravity can't be a force. It's easy to prove that it's not a force. But here's the whole point: is, dude, hydrogen is not a field of particles. Even hydrogen and oxygen is not particles the way you're thinking in your mind. It ain't a field of particles. It's flexible, it's stretchable, it's compressible. It's not, if you have a certain amount of hydrogen, you have a certain amount of particles that are in a field together. It can't be. It can't be.
But if a hydrogen is a bond, then it's going to bond everything else, like the carbohydrates. So you get hydrocarbons sort of thing. So the hydrogen could be a glue, just like oxygen is. When oxygen is a certain sort of temperature or whatever, it becomes sticky, apparently. So
yeah.
We were talking about Michelson Morley, not gravity. So Michelson Morley is an observation, a perspective of what you're seeing, but you could be seeing magnetic aberration because of the oxygen. And when you get to O3, O4, O5, O6 and all that, you know you're looking through all this stuff, aren't you? Ozone layer is O3, so we're looking through a magnetic field.
Why are you bringing up like ozone layers and the atmosphere and air. Like we're discussing very like the foundations of physics.
It's all part of the aether medium at the end of the day. It's all part of the aether. I think it's kind of a valid thing to discuss.
Anyway, does anyone have any questions for me? Because I figured everything out.
No, I'm good.
I had a question for you.
I talk to you, brother.
I had a question for you, Mr. Slave.
Mm-hmm.
Can you talk to me a little bit about the momentum issue with electromagnetic fields and magnetic fields?
I'm thinking about it, but Maxwell described exactly how light or electromagnetic waves have momentum, how they can impart momentum onto an electron or a proton. So they should be able to do it.
I have a question too before you go. I got an important question before you go. Tell me when it's my turn.
Rod, can you
But
I just wanted to ask.
I don't have.
So,
I haven't
if they
thought about
define-
it. Go ahead.
I think I have I don't know, a concept behind it. So if they define the velocity as the mass towards the acceleration, they'd have to first know the mass of the magnetic field and the mass of the electromagnetic.
I lost you there. You said velocity. No, there's no acceleration. What acceleration are you talking about? Nothing.
I'm sorry. When you were talking about the momentum.
Yeah. So, an electromagnetic wave, the way it interacts with, let's say, an electron, is that it moves, the electric field moves the electron. Now the electron is moving. But it's moving up and down. So you could say, oh, it's not really moving linearly. It's just bobbing up and down. It's not going anywhere.
It's something on its own, then, basically. You're saying it's something on its own.
I'm not saying it's on its own. I'm saying an electromagnetic... As an electromagnetic wave goes through an electron, the electric field, the electric sinusoidal field causes the electron to bob up and down, let's say. But as it moves up and down...
So you're saying an electron is something on its own that bobs up and down?
I mean, an electron is something on its own that bobs up and down, yeah.
Well, fair enough. Here's my question, though. Do you think gravity is a pulling force or something that creates a pulling force?
Well, we know that gravity is that which pulls the apple towards the earth and the moon towards the earth. So it pulls.
That's not an answer.
What do you mean?
So you say, yes, it is a pulling force?
I mean, it's just a definition. Gravity is, if you...
Can't be.
What do you mean?
It can't be a pulling force, and I'll give you a second to ponder that if you'd like. But I just want to make this clear. Are you saying that it is a pulling force?
Gravity, the way people talk about gravity, it's that which causes the apple to fall and accelerate towards the ground. It seems to be...
I have a question, bro.
Go ahead.
I don't know why you're wiggling and swerving. Is it a pulling force? I don't care about an apple, period.
What do you mean you don't? It's what you define gravity. However, tell me your definition.
Is it a pulling force, bro?
What's your define? Go ahead and define gravity. I'm listening. I tried multiple times. You're refusing to accept my definition. Then you define gravity. Go ahead. I'm listening.
I don't have a definition for it. I'm trying to ask you because you're making claims about gravity, and I'm just asking you simply, is it a pulling force or not? It's not a blurry question.
I gave you the
force?
answer. I gave you the answer multiple times. You don't like it. I don't know what to do.
Yes or no? You won't say yes or no.
I said yes.
I'll even let you muddy the water.
Yes.
Okay, yes. Okay, so gravity is, yes, a pulling force. Okay.
Seems to be.
Can you think of any way we could easily disprove that?
No.
Anybody here? Can they think of a way to easily disprove? Why do you think they started saying that it's not a force? What do you think it is in reality?
Why do you care?
Consistency of the tides.
Why do you care about them? Talk to me. You want to debate me? Talk to me.
Stop calling it a force. There's an obvious glaring reason and I'm trying to expand some minds in here. If I got the opportunity, I mean, there's an easy and obvious reason
Is
that
it
it
the
can't possibly
inconsistency
be
of
a
the tide?
force.
Yeah, go ahead.
Well,
Trying to
What
see
is,
if anybody knows the answer.
so what's the answer?
if you're listening to what Mr. Slavin said about Aether being a field and gravity just being a misrepresentation of the Aether, I think that solves the issue.
No, I didn't say that. No. So the way gravity works, first of all, gravity seems to pull the apple towards the earth. But it does it with no strings attached. How does that work? So the way it works is that the ether is a fluid that fills the universe. And it happens to flow into the earth right now at 11 kilometers a second. And it drags everything in its path. And that's how the apple gets dragged into the earth. And by the same token, we are now dragged into the earth. That's why we're not floating into the air.
Okay. If we've got a magnetic field that's pulling oxygen, like a real strong magnet that's pulling oxygen, say, through toward it. Okay.
I don't know.
And it's encased, so maybe it's repelling the argon, something diamagnetic. Okay. So now,
I lost
if you
already.
then use
I'm
that same,
lost.
listen, okay, I'm saying
I'm
if
lost.
you have a magnet in a little bubble, say you got a little spherical case and you've got a magnet in the middle of it, and it's pulling oxygen toward it and so repelling
I don't know.
argon in that little bubble. Do you get it?
No,
you get my hypothetical so far?
No,
Okay.
I have no idea.
Okay, you got a little plastic round ball. Okay.
Hold
in
on.
the middle of it, you've
We
got a
were-
magnet. You
hold
understand so far?
Hold on. Look, we were discussing light and how light.
You said if anybody has questions, bro. Now you're just like you willingly not understanding my little scenario to easily disprove
I
that it
haven't-
can't be a full force.
I haven't heard a question answered directly yet.
So let me make my point. If you've got a little plastic ball with a strong ass magnet in the middle of it, and it's attracting oxygen, repelling argon or whatever, any other gas that's diamagnetic. Okay, now if you put a something in the middle of that and it accelerates say you put a little tiny container of water and argon in it or anything, if it attracts that down to its surface in the center, you're going to get freaking separation. You're going to get displacement. You're going to get basically a miniature density tower. If something accelerates in reality, then we get displacement, period. There's no getting around it. And so that's how they immediately knew that gravity can't be a force, because when we're watching something accelerate due to it, there's no displacement. Okay. And this is where the globe model just fractures, in my opinion. We can continue the argument, but hopefully I made my point. It can't be a force.
I wasn't listening. I'm sorry. So, I mean, as far as I'm concerned, obviously an apple seems to be pulled by the earth. And the question is, why does the apple accelerate towards the ground? So my answer is that obviously there is ether, and the ether fills the universe. And
Only
the
two
ether,
ways we can replicate that. We can replicate that with an acceleration, or we can replicate that with a force. That's the only two ways we can do it. If you've got a third way that we can replicate attraction at an accelerated rate, please feel free to tell me. But to me, it's got to be a force, like electromagnetism or magnetism, something, or an acceleration. That's the only two options. If you've got a
Wait.
third, I'm all ears.
what do you mean? I don't understand what you're saying.
To get motion, to get attraction, physical attraction. Okay,
To get
two things separated by space.
Okay.
Any space.
Mhm.
Okay, then you've got to have either a pre-existing acceleration.
What do you mean pre-existing?
Or some kind of force, or a force of attraction.
Hold on. What do you mean pre-existing acceleration? How do you get the apple to accelerate towards the earth?
Two ways: either accelerate the Earth, or give it a force.
Okay, but we know
So it's
the
either going
earth.
to be a force or an acceleration, and a pre-existing force,
Hold on.
or standing on its own force.
Wait 1 second. So you're saying that the Earth right now, we're accelerating upwards, and that's why we think
No,
that.
that's relativity. I'm not making that claim.
Okay, I'll
I'm
ask
telling you
Okay,
that the
hold on.
only two ways to
Okay, you said that.
get
You said that many
attractions from
times.
a force
You said
are
that.
a pre-existing force.
You keep saying that, and I don't understand. So let me ask a question to understand you. Okay, so you're trying to explain to me why the apple seems to accelerate towards the ground, right? That's the question?
No, you were trying to explain to me
Yes or no?
that the apple accelerates to the ground, and I'm trying to tell you that there's only two ways that can happen: from a force that is there, or a pre-existing force, like
What
acceleration itself,
question?
something that's already a
Wait,
force.
wait.
If mass and times acceleration
Hold on.
is a force, then,
Hold on.
then there's either already a force that
Hold
does
on.
it, or there's a force required to do it.
Hold on, I'm not following. What is the question you're trying to answer? I don't understand.
I made a point, but you didn't hear me.
What's the question? What is the question you're trying to answer? I have no idea what you're talking about.
It's science.
What?
I'm making a declaration that
Then
I'm making a declaration. I've already asked a question and you chose not to hear it. Okay, now I'm
Then can
telling,
you
I'm
repeat?
pointing out where you're wrong.
Can you repeat the question?
Yeah, I asked. Okay, is gravity a force? Is gravity a pulling force? You said yes. I explained to you how it's so easy. Over 100 years ago, they easily proved, anybody could know, that it can't possibly be a force because the acceleration measured, there's no displacement. It can't be a force.
Look, well, I don't know what you're saying. Like
Now, electromagnetism is a force.
Hold on.
Dielectric, there's a dielectric force.
Wait, let me get a word out. 1 second. So I'm holding an apple, right? The apple seems to be applying a force on my hand, right? I need force.
What are the two ways to do that?
Wait, but do you agree that I need to apply a force to hold the apple from falling? Yes or no?
Absolutely. And now I'm asking you, what are the
Wait,
two ways?
Wait, hold on.
to recreate that?
No. Hold on. You said, if I understood correctly, gravity is not a force, but you agree that I need to apply a force to hold the apple from what gravity is trying to do to it.
No, I'm telling you the two ways. I'm asking you, do you know the two ways we can get gravity to press down? Listen, dude, listen. I know you are, but listen, there's two ways to get the apple to press it. Listen, dude.
I'm lost about your position. Well, I don't understand.
And you're not listening, okay?
What do you mean? I'm asking you a question.
You want to hear me?
I'm asking you a question. I'm not getting an answer.
I'm answering it. I'm answering it. There's
No, you're
two
not.
ways.
No, you're not.
It's
a yes or no. I'm asking you a yes or no question.
No, it wasn't. It wasn't a yes or no question.
I'm holding.
It wasn't a yes or no question. You asked how. And I'm telling you, there's two ways to
I'll
recreate
repeat-
the apple
no,
pressing against the
no,
hand.
no, let
That's
me
A,
repeat-
to accelerate the
no,
hand.
let me repeat my
or that's
question.
B,
I have-
for a force
hold on.
to be pulling it to my hand.
I have a yes,
That's
no.
the answer. You didn't ask a yes
I
or no
have.
question.
Then I'll.
Unless I missed it.
I'll clarify.
He may not have been listening, Brian.
Let me clarify.
Anyway, listen, Mr. Slave, you've got to wait for Brian to finish, if possible, please.
Sure.
Even if you disagree,
Okay,
even if you
okay.
disagree with him, just wait for him to finish.
Okay, just for the record, I don't disagree. I just don't understand. I mean, here, Brian, I'll ask you my yes/no question again, as far as I'm concerned. So you, Brian, said gravity is not a force. Now, as far as I understand, gravity is a force. So here, I'll ask you my question as a yes/no. So I'm holding the apple in my hand. I seem to need to apply a force in order to oppose the force of gravity. Yes or no? Is this correct or incorrect?
That's not what. Ask the question again, and without all the assumptions, please. Let's be fair about this.
Sure.
Re-ask the question.
With all due respect, I'm just going to repeat my question because I don't think I made any assumption. So here's.
Spare me all the assumptions. Just ask a clear-cut question because
I'm not
assumptions. I might have different assumptions.
I'm not making any assumptions. I'll repeat my question.
Very good. Very good. Thank you.
I'll repeat my question. If you feel I'm loading it with an assumption, feel free to stop me as soon as you feel that I'm that I'm positing some assumption. So here is again my yes/no question. So you said that gravity is not a force.
That's not a question, dude. It's not a question. You're telling me what I said. Please ask the.
Yeah, the question. I'll repeat my question again. Don't interrupt. So you said gravity is not a force. I think gravity is a force. And my evidence is that when I hold an apple, I seem to need to apply a force to oppose the force of gravity. Am I correct or incorrect?
Yeah.
Buoyancy is pushing that apple to the
I
ground,
agree.
bro.
I do agree.
So gravity is a force? You agree gravity is a force?
And would you agree? Now my turn. Would you agree
Wait,
that
yes or
there's
no?
two ways
What do
to
you mean
replicate this force?
Wait, no. Wait, do you agree gravity is a force?
No, I agree that to get the apple to press against a hand, what you're calling gravity, I agree. There's got to be a force. So would you? Now my question to you.
No.
Is that there's two ways we can replicate this pressure.
No.
Would you agree with that?
No, hold on. But I said part of my question is the force of gravity. I called gravity a force. And I asked you, am I correct? So I called gravity a force. So gravity is a force?
That wasn't your question. Okay, I would
Wait,
say
is
that gravity is most
gravity-
definitely a force.
is gravity
yes,
a
most
force?
definitely. But that's
Gravity-
not
Hey guys, can we please work on the clipping? This is like really unlistenable.
So is gravity a
Man,
force?
he keeps asking me questions and interrupting, man. I don't know why he keeps doing that, but I'm just muting if I'm about done with this. But I want to say that, yes, it's got to be a force. To have acceleration, to see acceleration, it has to be a force. Now, my question to you, if you want to answer it or not, that's fine. But please listen to it, is, okay, are there two ways to replicate this pressure we're calling gravity, the apple pressing against the hand? Are there more than two ways we can replicate that? Because to me, the two ways would be with a pre-existing force, a mass already accelerating, or something that causes mass to accelerate. But my point is mainstream science is they're saying it's not gravity's not a force because it can't be a force. Okay, I'm saying that there's got to be a force present. There's got to be. I'm disagreeing with mainstream science.
So I agree with you. Gravity is a force. People that say that gravity is not a force are incorrect. And for me, gravity is just the flow of ether. The flow of ether is what we perceive as gravity. The ether flows through the apple towards the ground. That is what drags the apple to the ground. And that is the force of gravity.
Do you agree that force is mass times acceleration? So when I say it's a force, I'm being very specific.
No.
So if I say that force is, so you don't agree that a force is mass times acceleration?
I mean,
please define force.
The way force is defined as change of momentum. That's the original definition of force.
Can you have a force without an accelerating mass? That's my question.
No. I would even say force can change momentum, not necessarily, right? If I apply a force to a wall that's not moving, there's no change in momentum. So a force does not necessarily change momentum. It can. If a force is used to change momentum, then force equals change in momentum, but it doesn't have to change momentum. You can apply a force and an anti-force, and that's fine too.
Does a mass accelerating, will a mass accelerating, or let me ask it like this. Is there a way to demonstrate a mass accelerating without displacement? In other words, the heavier things go into the bottom.
Is this a one-on-one right now?
Yeah, you can join in, dude. I'm pretty much, I've almost stopped signing myself, man, because I'm trying to discover these things, man. I'm trying to ponder some of these things.
I'm about to leave too because, Brian, with all due respect, I mean, I'm looking for anyone who wants to know anything, because I've done a deep dive in the last 2 months into big physics.
Fair enough.
My conclusion is big physics is correct except for the ether.
Whoa! That's where I got one last thing then. By you saying gravity's a force, you do know you're disagreeing with observation, with any observation you can make, and you're disagreeing against mainstream science. So for you to say you go against big physics, no, you don't. You are definitely going against big physics, because they 100% say that gravity's not a force.
Yeah, they're wrong.
Yo, Brian, you see how he, Brian. See how he let you finish, dude? Why don't you let him finish? You clipped him, dude.
Go back and listen, dude.
I know you're eager.
Anyway,
but you gotta let people finish.
I gotta go. So if anybody wants to ask me something like about why, like, I feel big physics is correct about everything except for minor things like the ether. I mean, it's not minor.
I just want you to ponder something when you go, right? Take this with you. How do you got something accelerating with no displacement? That's what I want to know. If you look in the chat, look. Have a look at the chat, have a look at this. You always have displacement between matter. But when we drop something, put it into free fall, there's no displacement. So my question is, how the hell have you got acceleration with no displacement? How is your ether providing this force? You know, but he's saying it's an ether thing. I want him to explain that, because that makes no sense whatsoever.
So I don't understand your question. So the way the ether, ether creates what we call gravity. So the ether right now, for example, is flowing into the center of the Earth at 11 kilometers a second. It's going through me right now and is dragging me along with it. And that is what I feel is gravity. What's your question?
But different states of matter, if you apply a force, we get displacement, correct?
No.
Oh, excuse me?
No.
No displacement. Why not?
You don't, when you apply a force, you don't necessarily have displacement. If you have an imbalance,
can you show me that?
Yeah, if I'm pushing my desk forward, but it's not moving, I'm still applying a force, but there's no displacement.
You're joking. This guy's a joker.
No, he's got a valid point, dude.
Has he really?
Yeah.
I want him to show me how we can have this displacement right here, because every time we do this,
the air bubble in the bottle. Dude,
yeah, because every time it's testable, repeatable. That happens every time. Okay, so except in free fall. So I want you to explain to me how this applied force works, because it makes no sense.
I don't understand. So again, I'm pushing against my desk and it's not moving. Nothing is moving. But there is
what's the different states of matter? How is the different states of matter in this desk? I'm talking about solids and liquids, solids and gases. You understand?
No.
Maybe watch the demonstration. How's that? I just posted for you. Do you want me to tag your name with the thing?
Go ahead, but if anyone has any further questions, I'm going to leave soon. If somebody wants to understand, like everything big physics says is correct, except for there is ether. So
except for the relativity, right? You disagree with relativity, but hey, I enjoyed the conversation, man. Sorry, I was getting a little passionate, interrupt. I did enjoy it, Mr. Slave.
Thank you. No, relativity is correct. Relativity is correct.
That's an awesome video, Andy.
So you agree gravity's not a force, then?
When you say relativity, you mean special and general. So special relativity is correct.
No, both.
Yeah, they're both correct. Both for different reasons. Special
and general.
I thought you were saying that gravity was a force. I apologize.
Gravity is a force. To claim that gravity is not a force is incorrect.
You don't agree.
I do. No, I disagree over the interpretation of general relativity. So the equations of general relativity seem to be correct, but the interpretation is incorrect. The
fundamental backbone is that it's not a force. Sorry.
Let me finish. So GR is correct, but Einstein is incorrect in interpreting GR. So GR is a mathematical equation that suggests the ether. You can see the ether in Newton. You can see the ether in Galileo. You can see the ether in GR. You can see the ether in Maxwell. You can see the ether in SR and special relativity. But if you don't want to see it, you don't see it. It's fine. But
there can't be an ether.
Hold on, let me
Mathematically,
let me
there
just
can't be
finish.
mathematically. It's eliminated.
Let me just finish. So I can prove the ether from all of big physics.
You have to rewrite the equations, bud.
No, the
because
equations
there
are
mathematically can't be an ether. You know, there is no ether. There's no ether mathematically or interpreting description wise. Okay, so what gravity describes is the attraction of bodies in space. Whatever you want to say, it's an attraction. And the question is, the difference between Newtonian and Einsteinian is fundamental, and it is. Because mathematically, you can derive one from the other if you want to say that, but physically, one of them is a force, one of them is an actual force, and one of them is not. Okay, that's the fundamental backbone of relativity, is the fact that gravity is not a force, and that's like I said. So if you want to say that you agree with big physics, you have to change your spiel.
No, so I'll repeat. So you can. So Einstein said he doesn't understand relativity. He said that many times. So you can basically ignore his interpretation of GR. GR does not say that gravity is not a force. Any further
There's
questions?
no medium in the math. In the mathematics, there's no medium. In fact,
incorrect.
There's absolutely there is definitely a lack of medium in the mathematics.
That's incorrect. So
Oh
GR assumes a flexible space-time, and SR basically concludes that the speed of light is a constant, or SR predicts based on the assumption that the speed of light is a constant, makes predictions. The predictions is true. Therefore, the assumption that the speed of light is a constant is true. But let me finish. But if you say the speed of light is a constant, that basically is proof of ether, because ether, if there is a fluid, then the speed of light should be a constant. I actually have papers explaining all these things. If anybody wants links to the papers, let me give you.
Yeah, absolutely. I absolutely do. And I DM'd you a message saying I enjoyed the conversation and everything. If you check your DMs, but I'll end it with this. I'll say that I should have specified and said there's no physical medium. Yeah, if you want to use time as a medium, that's I don't agree with it, but I can't say that it ain't a medium. But I'll say there's no physical medium, because like if you want to add changes to the speed of light in gradients or in different gases or something, then yeah, you can expand on the equations and everything. But there's a fundamental lack of medium from the base principles of relativity, and gravity is most certainly not a force in big physics. Most certainly, no mainstream physician worth his weight in salt would say that gravity is a force. Yeah, in mainstream physics, gravity is not a force. So I appreciate that you're going against mainstream physics, and yeah, please DM me them papers. I would love to read them and have a discussion at another date.
Were you guys talking about space time? Were you guys talking about space time, Coriolis?
No, we didn't. No, we didn't.
Or lens theory.
No, we didn't talk about Coriolis' effect. But now I understand what you're saying. Yeah, big physics says that gravity is not a force. That's incorrect. Gravity is a force. They misinterpret GR. So now I understand what you were saying. Yeah.
Wow, you think GR and GR gravity is a force, bro? You got it.
GR
twisted up in the game.
GR gravity is a force. Whoever says GR gravity is not a force is incorrect.
It's not a force in GR. That's totally correct what I just said. I mean, I could get you all kinds of citations and shit saying it's not. I don't know.
No, I don't need
Who you would
citations.
believe.
It's just no, it's not a belief. It's just interpretation. So for me, GR is basically the ether. For me, SR is the ether. For me, quantum field theory is the ether. The ether is the unified field that unifies all of physics. Everything is explained through the ether. Black holes are explained through the ether. Dark energy is explained through the ether. Gravity is explained. Time dilation is explained through the ether.
I have
It's not
literally
mathematically. I'm with
tons,
you.
I have literally tons of citations saying that it's not a force.
But citations are not an argument. You need to argue from first principles.
Well,
Ernie,
I totally
think
get what
he
you're
just
saying, bro. Yeah, I
Sorry.
totally get what you're saying. But unfortunately, these other interpretations that you're calling them, really, they're just theories or hypotheses that are not Lorentz invariant, which means they can be transformed away, which means they're reference frame dependent, right? The kind of physics you're thinking about, right? So it kind of means that it's not real if you can transform.
I didn't get that. What?
Well, Jace is
so you have to be
gravity a force in
familiar
GR,
with it.
Jace? Is gravity a force in GR?
Hang on, just give me a second.
Bro, I think
What, you Googling it?
he's aware of the mainstream narrative that gravity isn't a force, and that in relativity gravity isn't a force, but he's against that.
Correct.
So he's
No,
against
I'm
the
not
mainstream
necessarily
narrative that gravity's
against
not a
it.
force.
Not just that. GR is the ether.
I'm not necessarily against it. I just think it's more complicated than that. There is something technically called the Einstein force, which is when general relativity goes into the weak field limit. Basically, Newton's law. You get back to Newton's model and Newton's law with a correction factor, and that's called the Einstein force. Now, would I argue that that's a real force? Absolutely not, but it is something that does happen with general relativity. So
it's not a force, but you can think of it as a force.
General relativity says it's not a force, and it happens because of the curvature of space-time bending. Like, if you're talking about it is a force, you're not talking about GR.
Well,
I mean, we can
thing is,
pretend that, but there's literally something called the Einstein force in general relativity, which is just a modification of Newton's force law. But no one is saying, right, that is a real force, right? It's just a quirk of how physics works. You still have the mechanism that GR proposes of bending space-time and changing paths and all that is the mechanism. I was just trying to highlight that just the blanket statement that it's not a force in GR, there's more to it than that.
I just wanted to say real quick.
Yeah,
I just
go
want to
ahead,
say is that Flatman, dude? Yeah, my bad,
Yeah, what's up,
Flatman.
bro?
What's up, man?
Hey,
No,
what's
I
up,
just
bro?
want to say, like, it's like the Coriolis effect, right? Like, yeah, according to them, the Coriolis effect is a pseudo force. It's a fictitious force. It's not a real force, and gravity is also not a real force. But that's based off certain interpretations, right? And according to this guy, I don't know this new guy, I don't know his name. He doesn't subscribe to that notion, right? In his understanding, it is a force, and I actually agree that it is a force.
Yes.
And the way that you interpret gravity, depending on your framework, like they're calling it the bending and warping of space-time, right? He explains gravity through a different framework. It's not the bending and warping of space-time. It has to do with the ether flow and pressure mediation, where the waves, right? There's like these ley lines, these waves, these flux lines that are pressing down on the objects, and that pressing down, that pressure is a real force.
Well, so it doesn't really matter. I mean, at the end of the day, when you hold an apple, you have to apply a force. So you have to apply a force to hold the apple. That means gravity is a force. I mean that you don't need to say anything else. I don't care what theory of gravity you have. Whatever your theory of gravity, you have to agree gravity is a force. If you don't think gravity is a force, then you're redefining words, which is fine. But we're agreeing on the data. Whatever you want to call it, call it. I don't care. But the cause of why the apple wants to move towards the earth, you can have many interpretations. You can say space-time is curved, you can say time is curved, you can say ether is flowing. That's the cause. At the end of the day, whatever causes it causes the apple to be forced towards the ground, and I have to apply an equal but opposite force upwards to hold the apple from falling towards the ground. So gravity is a force. To say that gravity is not a force is just not to understand, literally not to understand English. So that's a waste of time.
But all of this is invariant, man. So that
do you mean?
means it's just a way of interpreting physics.
Okay.
Right, there's a billion to the billion to the billion powers of potential ways to interpret physics. You have to actually show that your way has a connection to reality.
Jay, he just said that you're going against. You're saying that gravity is mass times acceleration, is a accelerating mass. So you're saying that you're going against language itself, bro. You are literally going against language. You're super projecting. You're saying that
No,
gravity
I'm
is
just
a
pointing
mass.
something out
It's an
behind.
accelerated mass because you're saying gravity is a force. So you're saying gravity is a mass accelerating. So is that what you're saying? You're saying that you're
No,
redefining
Brian,
what gravity is.
no.
Not you, him.
Me.
I was just trying to give him an idea of what Lorentz invariance is, right? Because that's important when you're talking about gravity.
Why is Lorentz invariance relevant to gravity? Lorentz invariance...
Because interactions that are not Lorentz invariant can be transformed away, which means they don't exist in all reference frames, which means they aren't real. And that's an interpretation that you're putting forth, is one that can just be transformed away, right?
Hold
You
on.
have to stick with the actual physics that can't be transformed away.
Okay, 1 second. So Lorentz invariance has basically it's wave mechanics, because
No,
yes,
it's not.
yes,
No, it's not, man. That's not what Lorentz invariance is.
yes, it is. It's basically from wave.
All right, I'll just go get the Wikipedia thing then and cite that you're wrong.
No, citations are logical fallacies. You need to argue from first principles.
You
But
trolling
when
me,
you're
bro?
arguing about something, like if you're arguing about GR, in GR, it's not a force. This thing Jace is saying with the Lorentz thing, in the Lorentz thing, it's very specific things are happening.
Still, you have to argue from first principles.
I mean, I hear what he's saying. I hear what he's
Yes,
saying, that if you bring
what
a,
I'm
if you bring a,
saying is that first principles lead you to the fact that reality, the interactions that are actually real in reality, are Lorentz invariant, right? That's what I've done the first principles thing, bro, and that's what it leads me to.
Okay, okay, can you derive Lorentz invariance?
What do you mean derive Lorentz invariance? It's a term for a process, right? If you do a transform and nothing changes about the physics you're observing, then that event is Lorentz invariant, right? It's not it describes processes.
Isn't Lorentz invariance the equations of the transformations of time dilation and length contraction?
Yes, to do the transform, the way you do the transform mathematically is you apply the Lorentz transforms, and then you go from one reference frame to another. You can go to any amount of reference frames that you want, and if the physics remains exactly the same, meaning you can't tell any difference, then that event, the interactions occurring in that event, are Lorentz invariant. If you can change reference frames and velocities and accelerations and momentums and all these values change when you change to a different reference frame, then it's not Lorentz invariant.
Mm-hmm.
Is invariance the
What were you gonna
laws
say,
of
Gio?
physics? Is that the same laws of physics are the same for different observers? Is that the Lorentz invariance thing?
Sorry, Gio. I know I did bulldoze you a bit. I did just want to get that
Fucking
out.
steamroll
If
him,
you're
dude.
still
You do
here,
that to
go ahead.
everyone. Oh, you're so
No, no, no.
You do that to everyone, though.
I did do it to him there, though, because I did just
You do
want
it
to
all
get that out.
All right. Yeah, I had to check my audio to see if my mic was working. I didn't know if you guys could hear me or not. But all right, yeah, if that's what happened, it's all right. Sometimes it has to happen a little bit, but ideally, it's not ideal. But yeah, I mean, everyone may do that sometimes if you're right in the middle of a point. It's fine. We came in at the same time. What I was just gonna say is just on the comment where he was saying, like, I was just saying, when somebody says they have a citation, what is that really doing other than saying, well, this guy said it? You know what I'm saying? It's just like in a direct discussion where you're trying to get to the truth. Like, I'm not saying citations are not useful, but the way that he was saying, like, you have to actually make your own argument. You can't just use someone else's thing for your argument.
I think the point of citations, right, it goes back to the whole inductive reasoning thing, right? So if I have an experience with something and then I can find a bunch of other people who also have that same experience, it goes towards the inductive reasoning conclusion that anyone else who performs this experiment or whatever phenomena for themselves will also observe that result. So that makes what you're saying stronger.
I agree. No, I'm not saying that it can't help bolster the point. I'm just saying, like, when it's used as like a sole, like, hey, here's a citation, I'm right. You know what I mean? When it's that, which probably is a fallacy. Does anyone know offhand what that is? If you just try to claim that the citation is your entire proof?
Yeah, I do. I have it. I'll get it for you. I had it already.
What's the name of it? Because I'd like to know that too. Yeah, because that doesn't
Yeah, give me a minute.
determine just.
It's probably like appeal to authority.
I didn't read that book you sent me.
It would be an appeal to authority in a way, yeah. If you're just saying because this authority said it. Because if you're using the citation as an authority, which usually it is, you're being used that way. So yeah, it would fit that.
Okay,
I
so
just wonder if there was a fallacy that's specifically with a citation though. Like the way you said that, like utilizing the citation as the proof or validation of your entire point, rather than just using it as supporting evidence or something that's supporting of the or that might glean additional information.
I feel like you want me to step in, but I'm gonna chill out. I'm sure somebody's got this.
I mean, a logical fallacy is only relevant if your counter party is rejecting whatever claim you're making. So if you're bringing up a source and I'm not rejecting the source, then everything is fine. But if I'm rejecting the source, then you need to argue without the source. Let's say I claim the source is incorrect. Maybe that is my whole contention. So what's the point of bringing the source? Anyway, getting back to Lorentz invariance and gravity, I don't see how Lorentz invariance is relevant to gravity, because Lorentz invariance is about time that. Are you referring to time dilation due to GR? Like gravity time dilation? I'm trying to.
No. We're not talking about time dilation or anything. We're just talking about the interactions that occur, the physical interactions that occur. They are classified as either Lorentz invariant or not Lorentz invariant. And that is based off of doing the Lorentz transforms on the physics that is happening, that you're observing, or that's in question.
So you're saying that gravity is not a force because of the argument of Lorentz invariance?
Yes.
So you're saying
the Newton's law, the Einstein force law, all of those laws are not Lorentz invariant. They're only applicable to very specific situations. They are not applicable to all situations, and thus they are not Lorentz invariant, and they're not really real.
By them saying gravity is not a force means that gravity is not a mass accelerating. So what they're saying is that there's already an accelerating mass causing causing that acceleration. Unless you're just going against the fact that force is mass times acceleration. You can't have both. You can't have
but force is
being
not
mass times acceleration
no,
and a force
force
not being mass times acceleration.
But force is not mass times acceleration. Force is force, mass is mass, acceleration. These are different things, and force can cause a mass to accelerate, but it doesn't have to. I can apply a force.
So what's your definition of force? So you're defining force as energy then.
Force
So
could be
energy can cause a force, but so you're just mixing shit up.
What do you mean? I can apply a force and nothing will move. Right?
You can't apply a mass times acceleration without a mass.
I don't know how to apply. I don't know how to apply mass.
You got to include all the forces that you're not accounting for the resistance to motion, like the friction of the feet on the floor. All that's involved in that.
Here,
Can you have a
I'm
force
pushing.
Let me
without
respond to
matter,
Geo's
period?
thing real quick. Go ahead, Brian.
No, you can't have been. I'd rather listen to you.
Just to Geo's thing, like if it's a citation, yeah, if you're debating on how like the real world works, then yeah, the citation thing, that's a thing, and I'd still like to hear that fallacy. But when you're talking about like an idea or a model or some kind of conceptual thing, like general relativity, like the citation for how that works, you know what I'm saying? Like if you're like, yo, in the globe model, the air rotates with the earth. Like that's just how it is in that. You know what I'm saying?
I think it has
I feel
to
like
do.
it's not. If it's reality, it's one thing.
But what is reality? Look, at the end of the day, whatever you cite, I can always question, and then you need to support your cite or your source. At the end of the day,
What I was saying is that. Sorry.
You can go on.
Well, what I was saying is that if you're going to describe a force as something that moves mass, then you have to have a field, period. You have to have a medium. And so the way they define mass is mass times acceleration. So you can't have a force without acceleration and without mass. You need them both. But like I said, you can describe it as energy. You're just saying energy basically. But then you're just saying that, you know what I said previous. You're basically saying that if it's something that causes mass to accelerate, then you're invoking a medium. And general relativity doesn't have a medium. It absolutely goes out of its way to disclude the medium.
Brian, I hardly ever am able to.
Let me give an example.
Go ahead.
Let me give an example. If I make up the Jeremy unicorn effect, and it's describing how unicorns have wings, and then I say, well, in the Jeremy unicorn effect, unicorns have wings. Like the citation for my effect is like, just some conceptual idea. Like that's just how it is in that idea. You know what I'm saying? It's not like in reality unicorns have wings. It's just in the Jeremy unicorn effect, unicorns have wings. You know what I'm saying?
Right. And that's reification, right? When an abstraction is treated as if it were concrete, real, or a physical entity, when an idea is treated as if it had a real existence.
Anyway,
the idea of like what is reality and we can't appeal to real that's just fallacious in and of itself. You have to appeal to real.
Well, Jeremy, that's a little bit different. It's a little bit different because in that case, the thing you're actually trying to prove is the actual citation, or sorry, he was hot micing. The thing that you're actually trying to prove is like 100% based upon some other source. So yeah, if you're like you said, if you come up with some theory and then you just state something, then someone else is just trying to say what you say. Well, then yeah, that basically in that case, like the citation would be the proof. Like
that's what I'm talking about with my thing. At least I don't know with J Ace's thing, but with my thing, that's what GR would. You'd be like, I got a citation showing GR gravity is not a force. That's a wrap. You know what I'm saying? It's not like in reality, is it a force? It's not a force. It don't matter. Just in this one specific idea of how it may work, it's not a force.
Yeah, but the way that he had said it that I commented on was like, you can't use a citation for your argument. You have to make your own argumentation. So yeah, if you were making your own argument, then that's where just appealing to an authority is different. If it was an argument that you're making about reality or about the nature of something, like in that case, like a citation could be a good addition or a good bolstering or give more evidence or lead more credence to it. But yeah, whereas if you're actually trying just to claim something that someone else has claimed, then yeah, I guess their citation of what they claimed, I guess, would be what it is.
Yeah,
Yeah, and if
GR
you-
unicorn
Okay, Jeremy.
theory, as far as I'm concerned. Go ahead. Did you
Yeah,
Did you
so
find
if
the
you-
citation fallacy?
Well, that would just be appeal to authority, right? You're saying that like my argument is this citation, right? This thing happened. But if you say that like you know if you make that argument, you say like this is a citation that this thing is true, and if you don't have a citation that says otherwise, then I'm right. That would be an argument from ignorance, right? So the lack of evidence to the contrary proves my thing right. So it would be a mixture of those two. But it is just fallacious reasoning. It's not logical. It's not it's not a logical.
It's funny because I didn't realize. I thought I'd be able to avoid it if I treated them like they were going to hit.
Who's hot mic guy? I think, guys.
Oh, I thought he was chiming in. Yeah, the argument from ignorance is the assumption of a conclusion or fact based primarily on lack of evidence to the contrary. So like when you get to like citation wars, if I have 10 citations that prove my point and you have one that proves your point, all of a sudden it's 10-1 and like it becomes a fallacious thing. But yeah, I don't think citations are necessary. I think you both look at the source itself. Like the citation is not the argument. The citation is the material between you two that you both interpret, and then you argue about the material.
Anyway, if we can
Yeah, but if my unicorn thing clearly states unicorns have wings, and then we're arguing about my unicorn thing, like I don't know. I just feel like the citation should end it right there because.
Yeah, that'd be
Talking about-
reification though, because that's something that
No, but no
hasn't
one's-
been proven to exist.
But no one's arguing if it's real or not. We're just saying in this conceptual idea, this happened. No, like nobody's saying it's even real. You know what I'm saying?
Oh, so it's like assuming it's real, then this.
Just in that idea, it's just in my unicorn idea, they have wings.
Okay, can we get back to gravity, if you don't mind? I'm not following this discussion about the unicorns.
Oh, you're good, dude. Go ahead. Yeah, that was a side thing. It's fine. Go
Yeah,
ahead.
so
sorry.
I'm just trying to understand why people feel that gravity is not a force, right? This is the question, because I feel gravity is a force. If you now you're saying that gravity is a force, is Lorentz variant, which makes it not real. So, can somebody explain this to me?
Yes.
Mm-hmm.
Yes, because the force, right? If you were to do an experiment and measure the force of gravity that you're calling using whatever equation, whether you want to use Newton's law, your own equation that you make up, or Einstein's law, Einstein's force law, right? You can take your measurements and get the value of the force quantitatively, and then plug all of that information that you gathered, all the data you collected during that test you did, plug it into the Lorentz transforms and see if you get the same answer for the value of the forces. If you do, then the interactions that occurred there are Lorentz invariant, right? If you don't, and you won't for most cases, there's only the weak force limit where you won't get the same answers, right? That means it's Lorentz invariant, and those forces aren't real. The Newton's law forces and the Einstein force law forces.
Okay, I'm confused enough. So let me ask you this. So I just put the apple. I'm holding the apple. I feel a force. What am I getting wrong?
I personally, if you
You're
talk
getting
about
the
physics,
mechanism.
yes, if you're talking about physics, I'd personally talk about physical things, seeing as it's physics. Like interactions between different states of matter, for instance.
Well,
Yeah,
I'm
that's what I was talking
I'm holding an apple, and I'm applying a force. Right? I'm applying a force. I can feel the force. So how can you say that it's not a force? What am I missing?
Why do you know you're
Well,
feeling the
think
force
about
and not the weight? Oh, sorry, James.
the Coriolis situations, right? The ball in one reference frame feels a force, but in another, it doesn't feel a force. It just goes in a straight line, right? So, is the force real? No, it's not a real force. If it can be transformed away, meaning the situation occurs differently in a different reference frame, then it's not Lorentz invariant, or it's Lorentz variant.
Let's ignore Coriolis' effect. So I'm just talking about the apple. I'm holding an apple in my hand. I feel that I have to apply a force so that the apple doesn't fall. That force is the force of gravity. Mhm.
But there's reference frames that you can transform to in that situation where there's no force at all being applied on you, that your hand, the apple, nothing.
Tell me
right?
about
Because
it.
that's not a Lorentz invariant situation.
Let's do it. Right now, I'm experiencing a
you gotta
force.
go.
Mhm.
You have to go deeper into the what the mainstream says about all this stuff.
Mhm. Go ahead. I'm listening. I'm applying a force. How can you say that the gravity is not a force? I'm opposing the force
Because
of.
it's a
Go ahead.
it's because the situation you're describing is within the weak field, what's called the weak field limit, right, of general relativity, right? The when that occurs, that means they aren't real forces. We don't call them forces, right? There's interactions that occur in these situations, but we stay away from forces in the modern day.
I don't understand.
Do you see why?
Can I jump?
No.
So
No, I don't.
does that prove? Is that like? Are you trying to prove
I don't know.
your
I
your
guess I
theory that it's not a
can't
force? Or you just
explain it
well,
any more simply.
you
You
guys know.
just have to look into what Lorentz invariance is and like what GR says about what forces are, and different experiments that have been done that actually show what happens when you move in these different frames and do these transforms. You got to just look at it, I guess.
Okay. So you like I'm in the middle of Lenny Susskind's course on GR, like lecture 4, I think, or 3, and I'm getting lost in the math. But I'll have to continue it.
Is this like a one-on-one, like private lesson or something? he's doing?
All right, go ahead. Queue up.
Oh, you hear me, J-Ace. Wow.
Yo.
Jay, so are you a physicist?
No, I'm a biochemist, molecular biology type of stuff I do. But we do a lot of stuff with crystallography, diffractometry, nuclear magnetic resonant spectroscopy, etc. And all these things we have to do these kind of Lorentz transforms and all this complex physics behind it. So that's how I'm familiar with it.
Do you have
I hear you about the transform though. If you have like I can put it in terms that can relate to like the Coriolis effect. Like in one frame, there is not a force. In another frame, there appears to be a force.
Mm-hmm. I understand. But I just don't understand how you could say, I'm trying to think why you would say that gravity is not a force in general.
Because of the mechanism of general relativity, right? This idea that gravity is a force can only be applied to a very limited amount of cases. It can't be applied to them all. For the rest, you have to consider how mass couples with space-time and how that changes the path of objects when they're traveling nearby each other or around each other, right? That's why.
Like I don't know when
Yeah,
it comes
they're
to this
trying to
whole
say it's like
space-time
infinite
thing, but when it
suction.
comes to I don't know when it comes to this space-time thing, but when it comes to the Coriolis one, The real frame is the one where there is no force. That's the real frame in Coriolis. So I don't know. Maybe different with the space-time thing. I don't know.
You broke up when you said the punchline. That's why I couldn't hear
No,
that
you
word.
didn't. It was your connection. We heard him.
No way.
Yeah.
I hear everyone perfectly well, and I couldn't hear what he said.
Well, I'm just saying he didn't break up.
Yeah.
Well, could you repeat what you said about the Coriolis? Is it Coriolis or Coriolysis?
When it comes to the
Coriolis.
Coriolis, the frame with no. When it comes to Coriolis, frame with no force is the real. That's the real frame, the one with no force.
Hmm. But if you're holding,
like I said, it may be different with the space-time one. I don't know.
But if you're holding an apple as it's experiencing Coriolis effect, you would have to apply a force to the apple, let's say, to keep it right. Well, let's say, I'm trying to think. Yeah, let's say you're looking at Earth. Let's say you're a giant looking at Earth, and the apple is moving in a quote straight line unquote. But everyone on Earth sees a Coriolis effect. They see a deformation in the trajectory, right? So, but let's say you want to keep it going in a straight line so that everyone on Earth sees it going in a straight line. So you would have to apply force to the apple in order to keep it in a straight line.
Bro, what the fuck are you talking about?
No, that's absolutely not how it works at all.
I'm saying
not with the Coriolis. I don't want to take this Coriolis, but I mean,
the Coriolis is you fire a bullet north, and it travels right. It doesn't travel in a straight line, or you have to fire at an angle.
The bullet travels in a straight line, so to speak.
Sure.
However, it appears the curve. That's why you got to shoot where the target's going to be, because you don't have to put a force on the bullet.
I know, but the people on
there's
Earth.
No force left.
Yes, but the guy firing the bullet sees the bullet veering off target. So let's say I was.
Yep.
Right.
That's where they think there's a force.
Exactly. So let's say I was able to manipulate the bullet with a remote control, and I was able to apply a magnetic force, or even using fins, I would be able to veer the bullet back on a straight trajectory, right? So the fins would feel a force, obviously. The fins on the bullet.
Yeah, if you wanted to keep it straight, then yes, you would have to apply force.
You want to tell me only I'm hearing Jeremy roboting?
That was fine to me, man.
No way.
No, he roboted that time.
Yeah, Jeremy, you're breaking up. Your
Yeah,
connection
he's
is
robot.
Yeah, Jeremy, your audio. I mean, your connection is it's shoddy. Like, I couldn't.
That
tell
time
what-
it was, but the first time that you said he broke up, he didn't. So that
okay.
time, yeah, he did.
Okay. Anyway, Jeremy, could you please fix your connection and repeat, or choose one of the above? Anyway, so going back to gravity, so everybody says gravity is not a force. You're saying because of the Lorentz transformations. That's very interesting. I mean, the way I interpret...
Well, it's more the mechanism. I was trying to relay it to you in terms of the Lorentz transforms in Lorentz invariance. But really, why physicists say that it's not a force is because of the mechanism of general relativity and how this idea of it being a force only gives you the correct predictions for very limited circumstances.
Could you show me where my interpretation or my model of gravity is the ether? I don't need the curvature of space-time. So
that model is trying to take care of one aspect of the issue of the whole force thing. It's trying to take care of the issue of the instantaneous action at a distance.
Yes.
Right. And locality. Right. Physics posits that the interactions that occur between matter happen locally, right? They don't happen instantly over huge distances, right? And so that's what the idea of a force, there's nothing there to account for that instantaneous action at a distance. The ether was one way to attempt to account for that. And that's why I was saying it. But it's a way that is Lorentz transformable, which in general relativity means it's not real. It doesn't make the correct predictions for all cases.
Wait, my ether works well with special relativity. Actually, my ether predicts special relativity, and it gives me gravity. It allows for the apple to accelerate towards the ground. So what in my ether...
Sure. You could have a new ether theory that is Lorentz invariant, right? And that does account for all these things. I'm saying all of the ones that have been put out in the physics community up to today have all not been Lorentz. They all fall under that, trying to account for the instantaneous action at a distance, but not being Lorentz invariant and thus not real.
So you're saying my ether, there's no reason my ether could be Lorentz invariant and give us gravity and give us everything, no problem.
Yeah. If you were, if you showed that, then you'd have a legitimate scientific theory.
Oh, well, do you want to stress test my theoretical ether, my ether theory?
Yeah. I mean, if you want to, talk about it with us all, anyone is free to jump in.
Okay. So basically, the way I see it is that, for me, ether is a fluid that causes time dilation. It gives rise to Maxwell, obviously. It flows towards the earth and pulls things towards the earth, so it gives us gravity. And what we call elementary particles are waves in this ether, in this fluid, just like quantum field theory says. So I think what I have is a unified field theory. It's a theory of everything that unites everything.
Can I ask a question before Jay Ace jumps in?
Yeah.
How did you figure out that time dilation is a real thing?
I mean, time dilation is, time dilation comes out of if you're assuming that we are in a fluid, then everything is a wave. Then, do you know the channel Dialect on YouTube?
So I have to watch a video for you to answer?
What?
I do.
So Dialect, they came up with a sound clock, meaning a clock based on sound. So if you watch that episode, they prove time dilation based on sound. So that.
But sound doesn't travel instantly, right?
Correct.
So we're talking about time dilation?
Right,
I'm
but
just saying because you're accounting for time dilation in this
yes,
theory you're making up, and
yes,
time dilation is based on an assumption that their instruments are working perfectly, and they're basically just measuring their own faulty instruments.
right. So time dilation. So it's caused. So your brain right now, your consciousness, all the elementary particle in your brain are based on the speed of light. The mass that the electron in your brain, the mass.
Dude,
So
he's asking you.
Yeah.
Hang on, man. He's
Go ahead.
asking you
Mhm.
like how for the citations, basically the experiments that you've done or that anyone's done, for how you know that there's elementary particles in your brain, right? He's at that level with you, bro.
Oh. So ask me a question. What was the question again?
When did you find out about time dilation? What's real?
He wants to know what you've done or what you've seen someone do that demonstrates time dilation is a real thing that happens in reality.
Yeah, it's just interesting because he's mixing ether with like all this relativity stuff, like speed of light, time dilation, and it's like usually like those are like different paradigms. So it's I don't know, maybe you
Right.
don't
So
understand how they kind of like
But you
conflict with each
agree.
other and why they each were
Wait.
created.
Okay. But you agree. I mean, you would really do yourself a favor if you would just watch that episode on dialect with the clocks that are based on the on sound waves. If you would watch.
There's
Mhm.
no amount of time that I could spend like researching time and for it to make me believe that time existed.
The time existed? What? You said time existed? Are you there? Hello?
Yeah.
You heard
Well-
him correct.
Wait, you deny the existence of time?
Yes, that's what I said. There's no amount of time that I could spend thinking or researching about time for me to believe in time.
Okay.
It's ironic what you just said.
I know. I was
It's
trying to
kinda-
be funny.
yeah.
Oh, Left Lane doesn't get. I was joking. Nice.
Yeah, I got
didn't get it either.
So you
That's fine.
don't, I need to clarify, you don't believe in time?
Every time you say it, like I don't know.
Well, time is not like a physical thing. It's sort of like a medium that we move through, right? It's not an actual thing, right? Like a thought is not an actual thing, or I guess the mind, right? Or right, these things aren't actual physical things.
I mean, I would argue that there is no such thing as an actual thing or a real thing. Nothing
No,
ultimately.
there definitely is. Anything that has qualia is a real thing or an actual thing.
So I would argue that nothing is real. That at the end of the day, the universe is a psychological experience between my ears.
So you don't think that there's
So
objective
you're a
truth?
solid. You're a solid.
Wait, so how does
then,
time
you're saying.
exist in that paradigm then?
I mean, within the universe that exists.
This is solid, hardcore solipsism.
Yeah.
Basically.
Yeah.
I like scallops.
Yeah, I don't have a problem. Like, as far as I'm concerned,
Thanks, Left Lane.
there's no objective reality. All I have, as far as reality is concerned, all I have is, my personal experience. So that's all.
Yeah,
I
but
have.
that's a coping mechanism when it comes to any type of argumentation. Because anytime someone says something that questions your premise or your ideas, you can just say, "Well, we can't prove anything."
Wait,
I don't
wait,
say that.
Galaxy, is he what's that word? Fuck.
Jeremy, I can hear you.
Hold on, did you guys hear me? I said, oh, all right. I said, so this is solipsism. I think I cut out a little bit. This is
You said
solipsism, that's what
hardcore.
you're saying.
It is hardcore, yes.
Hardcore. Yeah, that's hardcore right there. Solid. Well, that's just basic. I guess there is no hardcore. I mean, that's just what it is.
It says pretty hardcore.
But that's just solipsism. This is your typical standard solipsism. I don't know. I don't think it's like a gradient.
Anyway,
Well, if somebody tells me that they don't believe in objective reality, it kind of makes, I don't know.
That's solid.
Well, it's a completely useless position to talk about science or anything.
Well,
yeah, it's useless for anything.
no, it's very useful, but I didn't use the argument that I'm not using it as an argument. I'm just saying when somebody starts saying time is real, time is not real, so then I pull out of my bag, well, nothing is real except for my experience of the universe. As soon as you question things that I don't have answers for, like the fact that I experience time, that's all I know. All I know is I experience time.
No, you experience life. You don't experience time, bro.
Then fine, that's just words. So now it's a
No,
semantic.
the words have meaning, bro. Time has meaning. Life has meaning.
What's your definition of time?
Time doesn't exist, dude.
What's your definition
The
of time?
definition itself is the what misled you to think it exists.
What's your definition of time?
It's just we use measuring apparatus to basically plan and to keep track of things, but there's no time. There's just
What are you measuring?
Hold on,
What
we're
are
not
you
measuring
measuring?
anything. It's like a calendar. My calendar has a bunch of numbers of the
You
month.
said it's a measuring.
What?
You said it's a measuring thing.
Yes, I
said
You said it's a measuring thing.
Yes, I agree.
Okay, maybe that's a bad word then.
I
You said
agree.
that, yeah.
I agree with your definition, and I agree with you.
I don't think I said did I say measure? I'm saying like it's like how we keep track of
Yes,
like
I
it's
agree.
like how we record things and plan ahead.
Of what?
I agree.
Yeah, the ahead part, when you say ahead, that's inferring that there's going to be like, a different time than now. Because you're not going to plan for now, you're planning for later.
That's just what we call it. We call it when the present moment, like after, like I have to use the word time, but after a certain amount of time, the present moment will be the time when we have planned ahead to do something, because we're not moving through time, but the present moment is continuously changing, and that change, the only way we can plan ahead for when the present moment is in the time for what change we're trying to plan for, is how we use time to basically coordinate like that. It's not like it's just continuous. It's always in a state of continuous change. Like there's always stuff happening.
That sounds like time to me.
Hold on, your name is
it sounds like time. It sounds like
whoever
time.
says time the most.
Wait, your name is Kiko.
I feel like
Pip?
using the word time.
Well, time. You are defining time as a verb there, aren't you? As an action rather than in its nounal sense.
Well, what it is time conceptually, but not time as some kind of entity.
Yeah, basically like the things are changing, and we're just like when my tree is gonna grow and like make apples, that's what I'm like planning for, right? So because it has to change into that, I basically made a method to figure out how long I have to wait in the present moment for that tree to be change into a certain thing. I don't have to wait. Like yes, I have to like in our words, like we do have to wait for time to pass, but that doesn't mean time is actually passing.
But you again, you're not defining time. You're defining scheduling within a temporal framework.
No, I agree, Kiko. Your name is Kiko Pip?
Yeah, that's cool. Kiko
Pip. I agree with you. So in general, whenever you try to define something, you very quickly realize that ultimately you cannot define anything. So even if you try to define a table or a chair, very quickly, if you really, really try to do it, you will see that it's impossible. And the same goes with time. So
yeah, I disagree with that.
Then please define chair. Please define
dictionaries.
Please.
I mean,
what do you think a dictionary looks like?
Hold on.
If you read a dictionary, what do you think? Like you're
right. So we can prove it from dictionary. So there's actually an episode in one of the YouTube channels about logic about that. So a dictionary is a self-referential system. So you can dispose of it right away. So again, you cannot, right? I call this the incompleteness theorem or my incompleteness theorem. So every system is
Bro,
incomplete.
the only reason we can even talk right now, the only reason we can even communicate right now is because you know the definitions of all the words I'm using. Didn't know the definitions, we wouldn't even be able to communicate.
Yeah, Jeremy, you're roboting.
Yeah, but I understood.
Your
I
point
understood.
backfired.
Yeah, Jeremy, I understood what you're saying, but look, we cannot communicate completely. I can never know exactly what you mean because I would.
Are we trying to talk about science or philosophy? Because you keep answering with philosophical like answers.
Well, you didn't let me finish.
You have to, bro. You have to discuss time. You have
No, you
to get into
don't.
the philosophy of it. Yes, you do.
Well, at least the philosophy of time, not solipsism.
Anyway, hold on 1 second. I was in the middle. Kiko Pip, with all due respect, I was speaking and you took away my mic. So let me finish.
Kiko Pip.
Wait.
All right. Well, let's wrap this up and then maybe we can.
Anyway,
hold on, Kiki. Let's wrap this up. Everyone give their final statements. I don't know. Are you guys into this? We're doing. You want
I'm gonna say something real quick when he's done.
Oh well, yeah. Just let him finish what he had to say, I guess.
Yeah. So it's impossible.
Finish out all our. Let's finish this. Let's round this off. If we can.
I mean, I'm fine. I mean, it's okay. I don't have to finish.
Well, I was just gonna inform.
Finish your thing. I didn't.
Okay.
Hold on. Let him finish his thing, and then Coach and then everyone give their thoughts.
Okay. So I can never know what you mean when you say 1 + 1 = 2. I don't know what you mean. What do you mean by 1? Like, in what language did you just say that? Oh, it's in English? Oh, I thought you were saying it in some other language in which 1 actually means 2 and 2 actually means 5. I don't know. So let's make sure. And forever I can ask and make sure. It's like the two generals problem. I can never completely know what you mean when you say something.
Can I ask you a question? Is there 2 genders?
Well, it's the same problems.
I want to kind of if we can
Yeah,
hold on,
it's
man.
completely
Hold
off
on.
topic.
A lot of people want to get in. Miss Love, hold on a second. What's your screen name?
Mr. Slave.
Love?
Mr. Slave.
Okay, Mister. Can we just hold on a second because a lot of people want to get in. Go ahead, Coach.
No, I was just gonna say very quickly to cue up into Mr. Slave that if you're conversing with somebody and you're responding to something that they said, so they say something and what you're saying is a consequence of what they're saying, then you're engaging in you're experiencing time and you're being very cognizant of it. And time isn't just the duration between events; it's also the ordering of events and the entire construct in which all that takes place. So just by being aware that there's an order of events, you're sort of confirming time.
That's not confirming it, dude. That's just how we write. That's how we keep track of it and write it down. It's not.
It's not just that. It's the very essence of its definition is based on premise that we are aware of events. We are aware there's a sequential nature to events.
Right.
We are aware of a successive mechanism that makes us in our conscious traverses those events. That's all that time is. It is the acknowledgement of that dimensionality.
So when the tree has to grow, right? It has to all the little cells, the plant cells have to build all these plant cell pieces. The wood has to they have to build the wood and all that.
So I agree. I have found myself enjoying interactions with Dan. Whatever's going on, we're getting along fine. However, first off, there's obviously the part where you touch the wrong button and you get completely nutso, Dan.
Yeah, I didn't think that
that could
Don't
happen.
you fucking call anyone a liar, not even me.
Right. It got to the point where like I also enjoyed Dan, but now at this point I can't even listen to his voice anymore because it's just so like we were on really, really good terms and I cannot.
All those flat earthers are just lazy.
Right. Yeah. I cannot even. Only when people are just dunking on him can I bear to listen to his voice because.
All right, I think we're done. I don't know what to do. This was, some of it was very interesting. Some of it was a complete waste of time. I don't know what to do. I need to go buy food and then eat, but I'm not really hungry and I still want to continue watching the video, this video. So we were just beginning to watch this. Let me see if I have any interesting notifications. Hold on, before that, let's watch this. Did Israel just eliminate Nasrallah? This is really important. Let's see what we know.
Did Israel just eliminate Nasrallah? Well, it sure looks like it, because I don't think anyone can survive if he was in that building. And I do tend to trust the Israeli intelligence because...
Wait, the Israeli intelligence said they killed him? The maggot? I don't believe it.
They practically stated that that was the target of their attack. Now, understand, Bibi approved that attack before he flew to the US. He just didn't tell anyone, and even America did not know about it. And then when he was in the US, he got called out of a conference call, out of a journalist conference by one of his advisors, and he ran straight to his cabin where he had the red tape, the red phone, and immediately started giving order. And Israel basically said that they launched the attack. They dropped about, I think, 3 rockets, bunker busters, I guess, and they completely annihilated, obliterated that area. In the center of Beirut, there was apparently a big wall of fire, and the whole city was shaken. So not only Israel is saying that if he was there, there's no way he survived, but also the American sources are saying the same. Now, here's what's happening right now. You understand, Hezbollah have received probably the biggest blow that it's been received since the beginning of that organization. His entire command chain have been assassinated. Since the pager war, where 4,000 pagers exploded in their faces, sorry, I'm in my basement here, giving you this live, basically. So since the pager war, immediately after, the entire elite command of Hezbollah got eliminated with number 2, and all these guys were planning on October 7 against Israel, and then they eliminated another leader, another leader, another leader. So just to get your head for an organization, what kind of a blow is that? You understand?
What kind of a basement is this? Where do you live? Jesus.
And this is a death blow. Because now you took out the communication system. They're afraid to communicate. And now it's taking all the leaders out. And all the other leaders are probably behind.
And there's nothing in this basement. Why don't you just fix your mic? I mean, you have the ultimate place. And only 8,000 subscribers. My God.
Like, Sinwar. So they're not effective in communicating. Now you took all the vision, maybe even Nasrallah. The average Hezbollah soldier at this moment right now is either confused, terrified, or confused and terrified. Maybe some radical fanatics are truly angry and want to go attack. But you see,
Yeah, I think the beeper attack was just in order to get Hassan Nasrallah.
it's the same thing like in sport. Everybody likes to cheer the winning team. Everybody likes to cheer to the Dallas Cowboys or to Beitar Yerushalayim or Manchester United when they're winning. But then when that team is doing really bad, that's when you find out the hardcore fans. All the rest just kind of fade away, disappear. Same thing with these terrorist organizations, especially in the Middle East. That's what people don't understand. I keep saying that I'm going to put my money where I talk. The answer for war in the Middle East is power and respect. I'm going to check my phone, see if it's recording.
No, that's not the answer. Jesus Christ, you're in the middle of a construction? You need to use this, otherwise this goes to the garbage. Anyway, the answer is the Middle East is poor. That's why there's always war. The Middle East needs to become wealthy.
Is power and respect. And right now, Israel is speaking power and respect. And that terrifies all of these dictators around Israel, all of these radical Muslim Arab leaders, just like when America took down Saddam Hussein. That show the strength, power, respect.
Yeah, that's not how it's done. No. The answer is just make the region wealthier and all these dictators will just disappear like the snow of last year.
When the American soldier was dragging him out of this cave that he was hiding in, put the flashlight in his mouth like he's looking at some kind of cattle or cow, that was such a humiliation to the Arab world that it literally scared the living out of all of these dictators. Bashar al-Assad, Gaddafi, all these guys were like, oh my God, that was Saddam Hussein who was like puffing his chest. I'm like Saddam Hussein. Look what happened to him. This can happen to me if I don't calm down. And it literally actually helped calm down the Middle East for a while. Now Nasrallah is some kind of a hero, a superhero in the eyes of the Shia. He's like the golden boy of Iran. He started probably.
What are you talking about? It helped calm down the Middle East? How do you see that? I don't see that.
believing that he's invincible, that nothing can happen to him, even if everybody's dying around him. Well, here's a reminder for any of these radical Muslim terrorist dictators around the Middle East. Israel can reach any one of you. The only reason that you are alive, why you're saying you want to kill Israel, is because Israel allowed it. And that's what Nasrallah forgot. Israel could have taken Nasrallah many times in the past. And the reason they didn't do that because they were thinking, if we take him down, maybe the one after is going to be more crazy. But Nasrallah kind of forgot that and forgot his place. And he started attacking Israel tomorrow, since October 7th. For the last 11 months, he's been waging full-out war with Israel. And Israel gave him a few warnings, but he's not backing off, and now he's down. So if any of these radical dictators around think that they can hide better than Nasrallah, well, they better wake up.
Wow, electromagnetism and Maxwell's equations, EMP part 4. Wow. Oh my God, that looks amazing. Wow.
In previous videos, we've introduced electric fields and magnetic fields. Now, we're going to see what happens when we combine them. So far, we've seen 4 equations that pretty much tell us everything about electric and magnetic fields. Gauss's law relates the charge inside a closed surface to the flux through it. Gauss's law.
Wow, I need to study this. This is so beautiful. Der Stern-Gerlach-Verschuss. Einfach und anschaulich erklärt. Wow. It's in German?
Sodass es gasförmig wird. Einige einzelne Silberatome verlassen den Ofen durch eine kleine Lochblende in Richtung eines inhomogenen Magnetfeldes. Hinter dem Magnetfeld befindet sich eine Fotoplatte, auf der die Silberatome auftreffen und ein...
Der Spin. Learning language by H.C. Verma, Quantum Mechanics. A logarithmic differential equation. Y double prime. Ugh, I wish it would stop playing when I hover over it. How can I make it not play? Don't play when I hover over you. Jesus. Step potential. Netanyahu versus the world. This, we are winning. This is good. Let's.
Prime Minister Benjamin Netanyahu has put us once again in a position that we don't like to be in, a position where we have to defend him because he spoke today at the UN General Assembly, as he does every year. He, of course, leaders are invited to speak there. He always takes the opportunity. He's a great speaker. He knows how to give a good speech. This was not his best, but it was, of course, probably one of the better ones you'll hear in the General Assembly, which was not much of a compliment. We're going to talk about that speech on the Daily Objective today. We are also keeping a close eye on what, of course, might be the bigger news of today, which is the attempt by Israel to...
I thought I have a message. On my iPhone, it says I have a message from someone. Let me see. Let me see. I have a notification because I didn't open it. I see. Anyway, I have YouTube notifications, but they don't show up on YouTube itself. Oh, there it is. Story of my life. You're right. I need better gear. Yeah, because I just told him, fix your mic. This is too important. And he says, story of my life. You're right. I need better gear. Yeah, definitely. Okay, what else we got? Friend request. Okay. What about this guy? How is veganism going to end the world? Oh, I see. Okay. You shouldn't listen to anything Vegan Gains says about veganism. Okay. Whatever. Okay. Not critical. Let me just charge. Oh, this is at 100%. And what we got here, 75%. Okay. What is this? Oh, that's his video? Oh, it's everything about it, all the reactions to his video. Okay. Okay, this we can close. 1 second. Okay, let's get back to this.
target Hassan Nasrallah, or you targeted, but whether or not he's dead, we don't know yet. If we hear such news during the episode, I think that'll change the topic midway. If we hear that news later today, we might have a special episode of the Daily Objective later today.
This is 5 hours ago. Let's find out. I need to find out. Okay, is Hassan Nasrallah dead? That is, I'm so curious. That little maggot. Based on recent news reports and updates, Hassan Nasrallah is alive. Really? No, I don't believe it. According to multiple sources, including Iranian and Lebanese news agencies, as well as eyewitness accounts, Nasrallah was not harmed in an Israeli airstrike on Hezbollah headquarters in Beirut. The strike was reportedly aimed at assassinating him, but he is said to be safe. I don't believe it. While the initial reports of the attack were unclear about Nasrallah's fate, subsequent updates and confirmations from reliable sources have established that he survived the strike. Really? I don't believe it. No way. Let's see. Central headquarters, Dahiyeh, Beirut, built under residential buildings. Israel attempts to assassinate. Massive Israeli attack. So we don't know. Oh, that's okay. Let's go to YouTube. Massive Israeli strike. Let's see Loner Box.
Fuck this Israeli-Palestinian war. We don't want to take part of it. It's not our. It's not a hill we want to die on. But now it's becoming more and more taboo. So Bashir Gemayel, when he was assassinated, he was sitting president. It was obvious that he became president because he kind of made a deal with Israel. So it wasn't that unthinkable of an idea for Christians just to say, we don't care about resistance, we don't care about the Palestinian causes, we just want to live in peace, even if that means making peace deals with Israel. But now it's becoming more taboo, first of all, because so Sunnis
Okay, they say here
liberal leader, like
they think so.
pro-Western leaders who are trying to make them more secular, like Hariri,
Yeah.
and they're only left with the religious groups, such as like groups close to Muslim Brotherhood, who are also close to Hamas, who are.
That's what everybody wants to know.
So that's why these are kind of getting more into the pro-Palestinian sentiment. The Christians also had a lot of like they became, like I think half of the Christians in Lebanon are pro-Hezbollah. At least the parliament says that.
Nasrallah isn't even the prime minister.
Pro-resistance. And there's also this general sentiment, like I know, like I have Lebanese friends who are...
Special relativity requires a preferred inertial reference frame. It does? No, it doesn't. Matter, basic, and nuclear radiation chemistry. Assassination attempt of Hezbollah chief. 2 hours, but they don't know.
Shalom, everybody. This is Yair Pinto coming to you live from Israel. And with me is Mati Shoshani. And we're about to unfold the massive explosions that rock Dahiyeh. This is a district in Lebanon, in the heart of Beirut tonight, as the IDF launched one of the most significant strikes on Hezbollah's central command. Mati, good to have you here tonight. And we are waiting for yours.
Finally, after a year of non-stop bombing, they finally got him. Jesus. I hope he's dead. That little maggot. What a little idiot. He could have had such a beautiful, such a perfect life. But no, he had to basically kill himself. He couldn't stay alive. It's like people, I don't understand people. I mean, you had everything. You could have had anything. No, he has to kill himself and live in a bunker for his entire life. What an idiot.
We are waiting for the rest of our viewers to join us for just a few seconds before we begin this live broadcast from Jerusalem.
Yeah, let's just say that this has been an exciting evening so far. If the rumors are true, this has been a unique event, even in Middle Eastern standards, even in the standards of everything that's been happening here in Israel, Lebanon in the past year. This is still a very significant, a very unique, a very outstanding moment in the history of this region. Again, if this really happened.
Yes, definitely. And we are still receiving additional reports.
Unfortunately, this is the best we can hope for, to kill an idiot instead of to build the world. Just terrible. We live in terrible times.
So we might give you updates as this broadcast is moving forward. But Mati, I think it's good for us to already start, and we'll keep updating our viewers as we go. Again, this is Yair Pinto, and I'm joined together with Mati Shoshani, coming to you live from Jerusalem as massive explosions rock the Dahia district of Beirut tonight, as the IDF launched one of the most significant strikes on Hezbollah's central command in recent history. The target, none other than Hassan Nasrallah himself. He's the leader of Hezbollah. Was this the decisive blow that we've all been waiting for, Mati? Let me summarize the events up until now. Okay, we are live from Jerusalem, and the IDF conducted a massive strike in the heart of Dahia in Beirut, targeting Hassan Nasrallah, the leader of Hezbollah. Okay, guys, I'm Yair Pinto, and this is your boots on the ground report, coming to you live about what is happening in Israel on the 357th day of the war against Hamas, Hezbollah, the Iranian head of the axis of evil, and all of its terror proxies in Yemen, Iraq, and Syria. Before we start, please take a moment to find the subscribe button and click on it so that you will never miss another update of Boots on the Ground. And the heart of Hezbollah's power, targeting their main headquarters located in the Dahia district of Beirut. This wasn't just any strike. It was designed to send a clear message to Hezbollah, to Iran, and the entire axis of terror and evil that Israel will not hesitate to take action. Details of the strike. The attack took place at 5:38, shortly after Prime Minister Benjamin Netanyahu's speech at the United Nations. Reports indicate that Israeli Air Force F-16I jets from the Bat Squadron unleashed a barrage of bunker buster bombs on the building, causing at least 10 massive explosions. 6 structures were completely leveled. I've seen the pictures from this attack, and it looks like an atomic bomb exploded. The target was the main target, Hassan Nasrallah, Secretary General of Hezbollah, who has been a thorn in Israel's side for decades. While it's still unclear if he was present in the building, the strike undeniably hit Hezbollah where it hurts the most. Lebanese sources report that at least 50 people were injured, and the fate of Nasrallah remains uncertain. Iranian officials stated that they are currently investigating Nasrallah's status. Meanwhile, Hezbollah has announced that they will issue an official response.
I mean, it's very exciting. This is absolutely exciting. I mean, the West should be much more forceful. The West is so weak. And this is causing the enemies of the West, the Putin and North Korea and the China, they're all acting up. The West needs to crush these enemies of civilization.
Soon. Before we continue, guys, please make sure that you subscribe to TBN Israel as we share the truth of what is happening. Conducted a massive strike, and the target was Hassan Nasrallah, the leader of Hezbollah, which was a series of pager explosions in southern Lebanon recently, hinted at a major intelligence breakthrough.
Let's see this.
Well, hello, ladies and gentlemen. Welcome to 2CTV with
No, this is 4 hours ago.
some breaking news coming from the Middle East, specifically Beirut in Lebanon, and of course the area surrounding Beirut, the capital. It seems like it is over, ladies and gentlemen. Hezbollah's main headquarters has been brought down. A number of senior IRGC leaders have been eliminated, and Hassan Nasrallah, the main leader of this organization, the Hezbollah, is been reported to either being killed or injured. Of course, if you're watching this live, we are going to be updating this information over the next few minutes and hours. If you're watching this tomorrow or next week or next month, you probably already know what exactly happened. And we're going to give you all the information because it's all kicking off at the same time. And the Americans are now claiming that they didn't know. First they said they were told last minute, then they say they don't know. It's all stupid right now coming from Washington, D.C. But these are the images we are getting from Lebanon as a massive round of strikes.
This is what you see from the ground up, but these are bunker busters. So I'm wondering if these are Israeli-made bunker busters or if they got them from the U.S.
Occurred over the last few hours, and now the last 2-3 days. Israel has been attacking Hezbollah bases non-stop. He obviously told the civilians in Lebanon to leave those areas, and they have left those areas. They evacuated this, and of course the Israelis wanted to.
Oh, I see. So the area was vacated, and then they could kill him because there's no civilians. Got it.
Finish this operation as soon as possible so that the Lebanese residents could return to their homes. Now, we are also getting information over the last few minutes. So before we get to Hassan Nasrallah himself, the leader, that Benjamin Netanyahu, Prime Minister of Israel, has decided to immediately leave New York City and return.
This is the new Israeli jet, governmental jet, State of Israel. Very interesting.
To Israel. Of course, this is important in terms of everything that's been going on. Netanyahu decided to go to New York to attend the United Nations. The plane is now getting ready to leave New York from the JFK airport. It should be departing over the next few minutes. And of course, over the next few hours, he will get back to Israel. We also have some videos that we can show you and some information about the retaliation, because the whole of Israel is now in a state of emergency because they are awaiting a response from the Iranian regime. Let's quickly go to the first video that we have for you guys and then give you guys all the information.
What do you mean Israel is in a state of emergency? Since when? What are you talking about? I didn't know anything about that.
عدوان الإسرائيلي غير مسبوق على الضاحية الجنوبية في بيروت. عشرات المباني دمرتها الغارات الإسرائيلية التي ضربت منطقة حارة حريق قبل قليل. نشهد حجم الدمار الكبير.
Holy shit! You want to tell me he survived that?
أعمال الإغاثة لا تزال مستمرة حتى هذه اللحظة. أكثر من 10 مباني دمرتها الصواريخ الإسرائيلية.
Holy Jesus!
أسرى هذا اليوم في الضاحية الجنوبية لبيروت.
Yes, that was the scenes from the Hezbollah's main headquarters that has now been brought down by the IDF. They are not messing about. And as we said, a number of senior IRGC members linked to, of course, the Iranian regime have also been taken out. And this is not good news for Ayatollah Khamenei in Tehran. He's been under a lot of pressure to do something, to retaliate somehow. Over the last few months, the Iranian regime have been humiliated left, right, and center. The last one was, of course, Ismail Haniyeh's assassination in Iran, in Tehran, which, again, the Iranian regime said they will be attacking Israel within the next 72 hours, 48 hours, and nothing has happened. We are all curious to see what is happening when it comes to happening now.
I can't wait for them to find his body. I mean, the Israelis should go in, get his body, steal his body, and what do you call it? Like humiliate it.
Because the early reports came, including the Israeli media, that he has been taken out. Then minutes later, the Iranian media decided to say, no, Hassan Nasrallah is safe. And now the Lebanese media are saying that he is seriously injured. Of course, he was most likely, highly likely, he was in the basement of the actual headquarters that has been brought down. Now, even if you're in the basement, if you're underneath in a tunnel, then the whole building comes on top of you.
It doesn't matter. I mean, that's not the point. The bomb itself, the shockwave, you're not going to survive these shockwaves. No way.
Then you will be affected.
You become soup. Internally, you become soup. Externally, you might look fine. Internally, you are soup. Your brain is soup. Everything is soup. You're gone.
Somehow, or at least you will be stuck in there without any food or drinks if all the doors and areas around you have been blocked. So even if he's stuck and injured, he will not be lasting too long. But of course, we will give you the reaction now. The Hezbollah, the remaining junior members of Hezbollah, have said that they will be releasing a statement. In reality, it's not really them doing it; it's the Iranian regime releasing a statement on behalf of Hezbollah. Over the next few hours, we will find out what they are saying. Whether they're going to be showing us Hassan Nasrallah's face, or is it going to be invisible? Is it going to be AI? Is it going to be saying, "Don't worry, guys, he's somewhere safe. He's just injured, but he's alive," without giving us any evidence?
If he were alive, they would already display him. He would have already spoken.
Of course, we'll get that reaction. The resistance security forces are now reporting that Iran, as we speak, are gearing up for a large-scale offensive against Israel. Now, again, we have heard this before. Having said that, it is highly likely that Iran might actually do this because they have no choice. This is the end of the Iranian regime's minions when it comes to Lebanon, and of course, Gaza has been completely taken out as well. It's just about Mr. Sinwar find out exactly what is going on. Let's double check to see what else we have. To the IRGC members, of course, a lot of them might have escaped before the attack occurred. Of course, they do. Again, we're unsure exactly how many have been injured or killed. We'll give you guys that information. And again, over the next few hours, as we speak, Israel is under in a state of emergency. All the borders are being protected, and the Iron Dome is ready to defend itself. Over the last few days, they have been very busy with these strikes coming from the north and, of course, Lebanon. Now, the US, this is where it gets really interesting because Tel Aviv said that they did notify Washington minutes before attacking the Hezbollah headquarters. But then over the last few minutes, Joe Biden's team have come out to say they were not actually notified. But then,
wait, so Elon Musk. Oh, this is interesting. Let's go to Elon to X. X.com. Hold on. Let me sign up. Just want to sign in. Let me clean. Let me clean up some stuff. Okay, that looks kind of clean. Anyway, So Elon says he says where is the question that he asked? Maybe. Oh my God, what's going on? Oh, this is good stuff. So he broke through. Eliminated? Is he? He's standing in their way on purpose. Whoa, what is that? Trump and Zelensky meet at Trump Tower. Wow, that's good. That's good news. Trump should support Zelensky. Okay, what I did want to check. Oh, what's going on? Potentially killed. Let's hear this.
I think the president said it the best. This is a war that should have never happened. It should have never happened, and it wouldn't have happened. It's a shame, but this is a war that should have never happened, and we'll get it solved. It's a complicated puzzle, very complicated puzzle, but we'll get it solved, and people get on with their lives. Too many people dead. Too many beautiful cities. I've seen those cities are so beautiful.
Yeah.
That, you know.
Yeah, but
I don't know how you can.
the question is Trump gonna give Putin what he wants? Okay, I just want to see. So Elon. So I saw a question. He's asking, would you join Xmail instead of Gmail? But I don't see it. On my phone, it pops up, but not here. Why can't I see it? Let me look if I got this right. Oh, it's not Elon Musk. Oh, fuck. Forget it. False alarm. Let me check the news. How can I find out the news? Let's go to Google. Google.com. I'm looking for Google.com on Brave and it's not finding it. Okay. Google.com. So what I want to find out is what's going on with Hassan Nasrallah. Yeah, okay. It's very likely that he is dead. So they're assuming he is dead. I mean, there are this is the estimation that he is dead. Oh, they tried to kill him in 1992? Whoever was there would have a hard time leaving alive. Okay. So let me figure this out. You know what we should look for? Live. Anyone? Okay, hurricane cover up. Israel bombs residential. Let's see. So they're complaining already. You can see by the title. Israel. Five minutes ago.
Hey everyone, Eric Stacklebeck here. Welcome to the Watchmen Newscast live stream. This may be one of the most significant days in the Middle East in years. And folks, considering the events of the past year alone, that's saying something. Israel today, breaking news here, destroyed. No other way to put it. If you see the crater in the ground, the massive crater, you'll see what I mean. Israel destroyed Hezbollah's headquarters in Beirut in a massive airstrike earlier today. Not only that, the main target of the strike was none other than one of the world's most notorious terrorists, one of Israel's greatest enemies, the leader of Hezbollah, Sheikh Hassan Nasrallah. He was reportedly inside this building. I should say beneath this building. This was an underground lair, an underground bunker that served as Hezbollah's main command and control center underneath a residential building in Dahia, a neighborhood in the southern suburbs of Beirut, which is a notorious Hezbollah stronghold. There is southern Lebanon along the Israel border, and then there is Beirut, Dahia in particular. That's where this command and control center was located. And the way it all went down, folks, we want to unpack this first of all. Second of all, what comes next? Third of all, just let me make clear to you right now. It is about 4:25 p.m. Friday afternoon, September 27th in Dallas, Texas, where I'm coming to you from, 5:25 on the East Coast of the United States. As of now, we don't yet know whether Sheikh Hassan Nasrallah is dead, wounded, alive. We cannot confirm that yet. Now, if you're watching this a few hours later, you're not live, say you click on it on our homepage at 10 o'clock tonight, it may be a different story. Although right now it's past midnight in Lebanon and Israel. Will we get confirmation soon? Will it wait till tomorrow? We don't know. But as of now, at least, we're not sure if Nasrallah is dead or alive. But reports I'm reading out of the region, they're trickling out fast and furious, are saying that Israel is increasingly confident that Nasrallah was eliminated today. On the flip side, Hezbollah says no way, he's alive, and the Iranian regime says they're looking into it. So we're getting some conflicting reports, but reports out of Israel from Israeli news networks and media sources are saying more and more, wow, it looks like Nasrallah is dead and gone. Again, we cannot confirm that. He may poke his head out of the rubble. We don't know. Can't confirm. But certainly Israel targeted him today. And again, when you see
If he was there, then very unlikely he is alive.
that massive crater, look, this Israeli strike reportedly leveled 6 buildings. That's how big it was.
6 buildings leveled. See, the thing that they did is, right, they don't want to kill him if it's going to kill many civilians. They don't want to do that. So, but they got the civilians to leave somehow. I don't know how. Now he has no human shield. So without a human shield, that's it. He's gone.
I mean, and those plumes of smoke will be seen for miles and miles.
I actually want to hear what the Young Turks have to say about this, because the title already says residential. Israel bombs a residential block. Yeah, but there's no residents. There's just Mr. Magid Hassan Nasrallah.
Miles, and it was a massive explosion that rocked the Lebanese capital earlier today. And
Yeah, it sounds like Israel did not take a chance that he's going to survive this. So it's an overkill, apparently.
the way it all went down, folks, is very noteworthy. Benjamin Netanyahu, the Israeli prime minister, spoke today. He entered the lion's den once again. He spoke at the UN General Assembly, as he does every September. He went back. I was unsure if he would go this year, considering Israel's in the midst of war right now on several fronts. But he went. He laid down the gauntlet for the world. His message essentially was,
it's part of the whole trick. So he went. So Hassan Nasrallah was thinking, there's no way he's going to kill me when he's speaking at the UN. But Hassan Nasrallah miscalculated.
Hey, we're going to keep fighting when it comes to Hezbollah because, folks, we've been telling you, the West in particular, led by the Biden administration, and France, Emmanuel Macron, is pressuring Israel relentlessly to come to some sort of ceasefire with Hezbollah in Lebanon. And there were reports. Bibi arrived in the United States yesterday. There were reports. Oh man, okay, Israel may just agree to the ceasefire. And wow, were those reports wrong? Because today Netanyahu not only laid down the gauntlet with speech, folks. If you can go back and watch the video, or at least read the full transcript of Bibi's speech today at the UN, it was a tour de force, as he always does at the UN, but with even greater significance this time around. He laid out the numbers of Hamas, how Hamas has been massively decimated in Gaza. That's another story. We're talking about the North and Hezbollah today, but it's all interconnected. These are all Iranian proxies. But the extent to which Hamas has been completely decimated was stunning. He laid that out, and the damage done to Hezbollah over the past week and a half alone, starting really on September 17th with the explosion of thousands of pagers simultaneously when they were on the persons of Hezbollah terrorists. That kicked off 10 days of hell for Hezbollah, culminating today with the possible death of its overall leader, Sheikh Hassan Nasrallah, after the death of dozens more Hezbollah leaders in the past 10 days alone. He was kind of the last man standing, and now he may not be standing either. But here's how it went down. There are photos that have been released by Israeli officials of Bibi in his hotel room in New York before speaking at the General Assembly on the phone, reportedly okaying this strike in Beirut against Nasrallah. Now, for Israel to carry out such a major and daring strike in Beirut, no less, against Hezbollah's headquarters, they had to know that Nasrallah was there. They had to have just pinpoint, rock-solid intelligence that Sheikh Hassan Nasrallah was in the building. That's number one. Bibi greenlit it. But here's the interesting, I think, folks.
I think this was real time. They might have tentatively planned for it, but in real time, you need to have confirmation that he is there and there's no civilians and it's ready to go. And then you have just a few minutes to decide, because it takes a few minutes to dispatch. I would say 15 minutes between the okay and until the bombs reach the ground. So
talked about how he laid down the gauntlet. It was a blistering speech today at the UN. He called out the hypocrisy of the nations of the world, and he made a very cogent point that we've been discussing a bunch here on the live stream over the past few weeks. What would your nation do? And look, we've got viewers here on the live stream from throughout the world. What would any nation do if it was in Israel's shoes with that situation in the north? At least 60,000, probably more like 80,000 residents of northern Israel evacuated from their homes for the better part of a year. Since October 8th, 2023, nearly 1 year ago, when Hezbollah, keep going here, unilaterally launched this war against Israel, began firing rockets, missiles, drones, and mortars at Israel, not the other way around. These are the bitter fruits of what Hezbollah has wrought. Now it's coming down upon their heads.
yeah, these people just decided to commit suicide.
Very biblical when you think about it, that kind of justice, especially when it comes to Israel's enemies. But for the better part of that year, northern Israel has quite literally been a ghost town. Netanyahu used that term today, ghost town, and he asked the world, especially the United States, what would you do? Hey, Israel's the size of the state of New Jersey. It cannot afford to have an entire region shut down. Economically, that's a disaster. It can't be sustained long term. America, what would you do? If El Paso, Texas, was shut down for months on end, thousands of people evacuated? We wouldn't stand for it. No nation would. And yet Israel is being asked not only stand for it, but to capitulate just when it has the advantage and is ready to strike death blows. It's being told, no, restrain yourself, ceasefire, and kick the can down the road and leave Hezbollah alive to fight another day. And Bibi said today, no, I'm not going to do that. I'm going to put the interest, as he should, of the citizens of Israel front and center. As should the leader of the United States, Great Britain, any nation in the world should put the interest of their citizens first and the security of their citizens first. Bibi, if there was any doubt whether he was going to do that, well, he laid down the ultimate mic drop today. He finishes his blistering speech at the UN, calling out the hypocrites and the moral rot in that institution. The anti-Semites, hey, to give you an idea, the UN, folks, has passed more resolutions against Israel than any other nation since the UN's inception in the mid-1940s. That means more resolutions against tiny Israel than against China, Cuba, the former Soviet Union, Iran, Syria, North Korea. The list goes on. That says all there is to say. Bibi gives his speech, and a few minutes later, literally a few minutes after he ends his speech, he wraps it up at the UN. Literally a few minutes after that, maybe 5 minutes later, news breaks of this massive airstrike in Beirut targeting Hezbollah's headquarters. Again, that's sort of like the ultimate mic drop, where Bibi says to the world at the UN General Assembly, the assembled nations, hey, we're not going to stop fighting. We're going to continue this, and basically we're going to win this fight against Hezbollah. Ends the speech, and it's almost like he was saying, and just to show you I mean business, here you go. Nasrallah, eliminated, potentially. That does not strike me as an Israel that wants to back off now and play the world's game and the world's appeasement game. Deterrence hasn't worked for Israel with Hezbollah or Hamas. That was blown out of the water quite literally on October 7th when Hamas attacked Israel, and October 8th when Hezbollah attacked Israel. In both cases, unilaterally, they weren't provoked. They both launched war on two separate fronts. Now, we want to dig into this more. Folks, it's going to be, hey, a long weekend, perhaps a long week and beyond in the world's most chaotic and volatile region. Two things to remember here. Number one, we've got you covered. We'll be coming to you with breaking news, updates.
Let's see live. Anything else live? Wait, what was that? Hezbollah wiped out?
Hello, everyone. I'm the Enforcer, and welcome to the breaking news. Please make sure to like, comment, and subscribe, and support us on Patreon. Link in the description below. We have breaking news today, as Israeli Air Forces have conducted a decapitation strike against Hezbollah command inside of Beirut, Lebanon. And according to preliminary information, a large amount of commanders have been killed, but Nasrallah may still be at large, as we have not been able to confirm the death of Nasrallah at this point. We'll be going on into the city of Beirut, where we were able.
So they don't know. Let's see this.
That was both tongue-in-cheek and serious.
down the path towards something that is more duty grade. It's going to be dust proof. It's going to be waterproof. It's going to have a different material that the housing is made out of. Sightmark is actually now run by new management than it was previously. So, Iowa, Scotland, Jacksonville, what's going on in Florida? Well, I know what's going on in Florida. Set aside for us to cover tonight. At least the MSpec line specifically is what I'm speaking to. Let's talk about what we're going to cover tonight, though. First off, I appreciate everybody for being here and for dealing with what's going to end up being a little bit of a jumpy around you. That's a very technical term. Now, we will have an Around the World segment. I think we're going to see Myanmar. 6 buildings weren't level. 2 were, though. But why? Let's take a look at these 2 buildings. Some stuff popped off. Here is where we're going to be starting this evening. That's Ukraine specifically, but we're going to move to this location here. These 2 buildings were absolutely leveled today. Now, there's running conversation and discussion that it's something like 6 apartment buildings, but the footage doesn't do that justice. As it stands, and as far as my opinion, as far as I'm concerned, 6 buildings weren't leveled. 2 were, though. But why? Let's take a look at the strikes and some of the footage that I was able to find for this. Now, we compiled this, at least at the time, into all the footage that we were able to find, essentially a supercut. Here are Israeli strikes on that location in Beirut. Full screen. What's making that red dust? Displacement of dirt. We'll kind of talk about that here in a second as well. That was both tongue-in-cheek and serious. So what was there, what was once, is no more, but why? Let's take you back to the very beginning of this, because I think a point needs to be stressed here. Whatever was there that Israel was striking at, they did not want to be there. Listen to the sound. Those are multiple munitions, likely including smaller 500-pounders and bunker busters. Here's what Israel was striking there. That is the Hezbollah command post. It has been under surveillance now from Israel for quite some time. It's believed that Hassan Nasrallah was there. If you're wondering who Hassan Nasrallah is, that is the Secretary General of Hezbollah. It's de facto leader. That is the head of Hezbollah. Were Israel to have killed Hassan Nasrallah, and there are also rumors that potentially his daughter was killed there as well, that would warrant possible direct retaliation, from Iran. Now, that's an opinion. I'm giving you that opinion based on a litany of other factors. Those other factors include things like Iran rolling with its own personnel being hit in other strikes and not striking back. They already took an L, and they rolled with that punch. I don't know if they're going to roll with something like this. Iran has funded and has such a vested interest in Hezbollah's operations and funding that it's really difficult to articulate without spending a career monitoring the IRGC's efforts in Lebanon.
This would be very good. If Iran now reacted, this would leave no chance for Israel. Israel would have to wipe out Iran, and that would be a good day. That needs to be done, and Putin is next because he's behind everything.
These strikes have probably some of the most gravity of any of the strikes that we've covered.
In North Korea, I mean, the world has no choice but to rid itself of these maggots.
Here on the show so far, especially given the different players that are involved behind the scenes supporting Hezbollah. Let's watch this stuff again. And there are a ton of other photos that have been released so far, and I want to kind of talk about some of those because there are a lot of people that so far it's not been confirmed, at least 100%, that Hassan Nasrallah has been killed. Though some of the statements that are being made are increasing the likelihood of that as a possibility. So Netanyahu himself was in a press briefing in New York, supposedly when this strike package was prepared to be delivered. He immediately rushed out of that. There are photos now of him at a phone in a hotel, presumably giving the green light for these. Some of the other things are the statements from Iran. Some of these statements from Iran include things, at least reportedly, right? That's another part of this that's always going to be important to understand. With live, especially on an unscripted show like this, there could be information that I have in hand right now that, is technically going to be outdated by either even the start of the stream or the end of it. So this is all information that I have with an information cutoff of maybe 1630 Eastern, and not even at best that, because by that time I was trying to close out the Ukraine portion of the show. But some of the statements from Iran had to do with things like if you cut off the head of the snake, another head is going to grow back in its place. Here's the problem with that with respect to Hezbollah, though. Iran had essentially postured Hezbollah to be more of a state actor than it was, your typical insurgent terrorist.
Okay. What do we got? Let's see if there's anything new here.
Saturday and Sunday, scores of other targets were also hit, some close to the Syrian border. At the same time, the Air Force dispersed leaflets calling on the inhabitants of South Lebanon to leave their homes. Hundreds of thousands fled. Still, dozens of civilians were killed in the airstrikes.
Wait, what?
Leaflets calling on the inhabitants of South Lebanon to leave their homes. Hundreds of thousands fled. Still, dozens of civilians were killed in the airstrikes.
Well, you were told to leave, so what do you want?
It's quite interesting listening to reading this history.
Why does it not go back to live? Okay, Israel, the Young Turks.
Here's 26 billion. America's shut.
No theories.
Watch list on YouTube and. Power panel. But look at that, J.R. Jackson out of nowhere. Here comes J.R. Host of the Watch List, legendary DYT host here, and John. So, all right, guys. Obviously, Young Turks live from the Polymarket Studio in LA in two different ways, Los Angeles and Louisiana. So, Jake Huger, John Idarola, host of the Damage Report, J.R. Jackson, host of Watch List. So, good to have you back, brother.
What's going on, you guys? It's good. I was listening to the intro music. I was listening to the power panel graphics. It's like, man, I haven't heard those in a while. I mean, it's not like I haven't been watching. I just haven't been listening to the intros and stuff. That's actually what I'm actually trying to say.
All right. Of course, JR shows on Watch List on YouTube and everywhere else we're on. Make sure you're checking that out along with Damage Report. But good to have you back on the main show. It's been a little bit. It's been a minute, as the kids say.
It's been a minute, I must say.
Yeah. It's crazy just to see us three together. And also, I know you're remote, JR. You got a new setup. I know you're worried about like some tech thing with like the sharpness of your camera. It's like weirdly sharp and focusing.
Yeah. No, I was gonna say I have a theory.
Good side. I'm intro like this.
Yeah. Anyway. So we're gonna get angry in a minute. So that's just the reality of life. So let's do it.
Downside first story is about war. Upside second story is about war.
Yeah.
Another one. But anyway, they're related. Okay. Well, why don't we get into it and see what happens starting with this?
I have a message for the tyrants of Tehran. If you strike us, we will strike you. There is no place.
Oh, they're not there. They ignore him. They don't show up to his speech. Losers.
There is no place in Iran that the long arm of Israel cannot reach. And that's true of the entire Middle East.
That's good. These are good words.
The Prime Minister Benjamin Netanyahu, obviously in the video, was speaking to the General Assembly of the UN earlier today. He was addressing in that video, obviously Iran, whose diplomats were not there. Of course, while he's addressing Iran, they were launching attacks in Lebanon, which we will be, of course, discussing in great detail later on in this episode of the show. We want to give you a little bit more of his remarks where that topic actually did come up.
As long as Hezbollah chooses the path of war, Israel has no choice, and Israel has every right to remove this threat and return our citizens to their home safely. And that's exactly what we're doing. And we'll continue degrading Hezbollah until all our objectives are met.
So there he's saying that so long as Hezbollah keeps choosing the path of war, then they have no choice, which is generally what people say after they make choices that are not necessarily popular. Of course, this comes just a day after he rejected a ceasefire agreement with that organization that the U.S. helped to broker and Israel also apparently was a part of. Now, White House spokesman John Kirby was asked earlier yesterday why it is that they rejected this proposal that they themselves helped to set up. And John Kirby said this: "What prompted the Prime Minister's comments, only he can say. We wouldn't have issued the statement we did if it wasn't supportive of conversations we had with top Israeli officials yesterday."
So he played them the way they played him so many times. So finally he's waking up and he's doing what they do. So he probably pretended to have good faith conversations just to lull them into lack of care, and then he attacked.
Today. So John Kirby, professional both spokesman, also diplomat, has no idea why he's doing or saying what he's doing. No theories. He's got nothing. Netanyahu apparently is a total black box. Can't read his motives. Now, there are theories I think that we can speculate about. Here is one. The far-right National Security Minister, Ben Gvir, said Thursday he had informed Netanyahu that if a temporary ceasefire with Hezbollah is agreed to, his party would not vote with the coalition, and if the ceasefire became permanent, then his party would withdraw from the government, threatening Netanyahu's hold on power. So if you take that serious, if you believe that that's a credible threat, then you could have the ceasefire that you claim that you want. But if you get that ceasefire, you yourself might lose your power. So I guess the war has to continue. Isn't it amazing? So many conflicts seem to rest almost entirely on the continuation of political positions for just a handful of people who get to choose who lives and who dies for their own personal benefit.
Yeah. So a couple things here. Number one, if you heard a little bit of applause there, that's more propaganda from.
It sounds like it's part of the ploy. So Netanyahu told Ben Gvir, I'm not attacking, in order to get Ben Gvir, or I'm going to have a ceasefire, in order to get Ben Gvir to say this again, to lull the Hezbollah. Oh, they're not going to do anything. Oh, they're going to make peace again. Because Netanyahu has done this so many times that he could have attacked and he didn't attack. So they said, oh, he's going back to being the old Netanyahu, the weak democratic Netanyahu.
The Israeli government, they brought in a whole bunch of people into the gallery to cheer for Netanyahu because they knew that everybody else that were diplomats at the UN would hate his speech because it was a warmongering speech. As you saw there, he said the long arm of Israel can reach anywhere in the Middle East, meaning none of you are safe. We've already bombed the capital of Iran, the capital of Lebanon. We've already destroyed Gaza, bombed the capital of Syria. We can bomb and kill any of you. It was one of the most evil speeches I've seen, and it made me think. Remember, guys, now it's easy to look back at Mussolini, Stalin, etc., and go, well, of course, they were comically evil, horrible, black and white issue, and everybody at the time must have also known, oh, that's the deeply evil Stalin, the deeply evil Mussolini. No, at the time, there was a discussion and a debate as to whether Mussolini was doing the right thing or the wrong thing. In fact, there were people in America that defended the fascists and said, no, Mussolini is doing the right thing. In fact, we should be more like Mussolini. And so this is one of the most inarguably evil leaders of our lifetimes. Here, coming to the UN, threatening it, more quotes in a minute about how he called it a dark chamber. I mean, he would know a thing or two about dark chambers, and insulted it in every way imaginable, and claimed that Israel has been sanctioned more than any other country, not because it has committed more war crimes than almost any other country, but because those things, even though they're facts, you should ignore, and facts don't matter. The only thing that matters is he claims the entire UN and the entire world is anti-Semitic. It's not that they're starting all the wars and they're creating all the problems, his right-wing government in Israel. It's that, well, if you guys realize we're the best of the best, and you should all listen to us, and you know that we could kill you at any time, and that's all right in our prerogative, and then you accepted that, well, then we wouldn't have any problems at all. You see how the problem is yours and not ours? It's absurd. And
we have that video if you'd like.
Yeah, I would. Yes, let's go to it.
The singling out of the one and only Jewish state continues to be a moral stain on the United Nations. It has made this once respected institution contemptible in the eyes of decent people everywhere. But for the Palestinians, this UN House of Darkness is home court. They know that in this swamp of anti-Semitic bile, there's an automatic majority willing to demonize the Jewish state on anything. In this anti-Israel flat earth society, any false charge, any outlandish allegation can muster a majority.
Yeah, okay, guys. So first of all, you should kick him out immediately. They should not him. Israel should be kicked out of the United Nations immediately. I mean, if somebody came to my house and said, "This is a house of darkness," and you are,
I wish Israel would leave the UN. The UN, it has dictators. It has North Korea and Iran and literally evil countries are in the UN. Of course, Israel shouldn't be a part of it.
Or filled with hate, like, get the hell out of my house. You grab him by the scruff of his neck, throw his ass out. You say, I dare you to set one foot in here and see what happens with a long goddamn arm. What are we sitting here taking insults from this maniac for? The United Nations sits here, okay, sorry, a whole bunch of diplomats walked out, of course. Okay, and second of all, much more importantly, make Palestine, declare Palestine a state right now. That's how Israel came to be from the United Nations. And so if the United Nations was good enough to declare Israel obviously against the Palestinians. Say, the only people on earth who cannot govern themselves, is that the maniacally racist thing that America and the United Nations and Israel agreed to? And in fact, is yes, Israel and America are that deeply racist against Palestinians, Muslims, etc. You can't govern yourself. You're savages. That is the most obviously racist thing I have ever seen. And
Israel is a democracy. The Palestinians can just live in peace in a democracy. Why do you need a separate country? That doesn't make any sense.
Has audacity to talk
The
about
only reason he wants a separate Palestinian country, state, is to have just another terrorist base, just like Lebanon is a terrorist base and Gaza has become a terrorist base. Every Arab country in the region is basically a terrorist base. That's all he wants because he hates Jews.
how the world is anti-Semitic because he's trying to start the biggest war in the Middle East that we've seen in our lifetimes. And of course, what's he going to do? He's going to come back and go, no, I demand that America pay for it and America fight it. I order you to do it.
That America pays for it. Oh my God. So that's the only issue. Why you even bring that up? Right? Your issue is not who pays for it. I mean, I'd love for America to not be involved. Unfortunately, America is mostly hindering Israel's independence.
And, oh, and by the way, you're in a house of darkness. And of course, he attacked progressives and said that we're in league with Iran. You don't come to America and tell us that our citizens are terrorists and you're the good guy.
What do you mean? But you are. What, you don't admit it? What are you ashamed of it?
Starting a giant war that we have to pay for. This is, look, I'm done with Netanyahu.
That you have to pay for? How exactly are you paying for anything? What are you talking about?
Any decent human being would be done with Netanyahu. And the fact that our government, both Republicans and Democrats, fawn over him and serve him slavishly. It's disgusting and it's humiliating to America and to all of its citizens. So, no, I do not agree to any lie from the American media or from the American government about how this is the moral army that has murdered tens of thousands of women and children in Gaza, that just murdered 600 people.
What are you talking about? Who did they murder? Not even a single person. Every casualty of war is a casualty of war, a war that was started by the Arabs.
In the middle of Beirut, and then he's going to pretend, oh, we didn't start the war. What do you mean?
I don't care. I just wanted to know if Hassan Nasrallah is dead or alive. I honestly don't care for this guy's opinions. Reported dead. Let's see.
So we got some trolls already in the live chat. Right. Number one. What about the IRGC members? Of course, as you can see, I'm out and about. I cannot fully confirm whether we came out tonight to celebrate the massive success that the IDF have had with the counter-terrorism operation in Lebanon, specifically in Beirut. Ladies and gentlemen, the IDF are now reporting that Hassan Nasrallah is dead. We are going to
Wow.
his statements and his body. But the interesting thing about
Oh my God.
the action is everybody obviously immediately respond. There we go. So we got some trolls already. Number one, the headquarters of Hezbollah in Beirut destroyed. Number two, they had a big meeting. This operation was organized since last Monday. They knew exactly when Hezbollah leadership are going to be meeting. They also used Netanyahu's trip to New York as a distraction tactic. And of course, also, just for the record, I got that in the background in case something comes up and something happens to me. You can see as witness. Give me a heads up if something comes up. So they knew this was going to happen. They knew about the meeting. All the senior members of Hezbollah have been there. They've all been taken out. The Iranian regime have already prepared a retaliation. The Israelis have said that they are also preparing for a ground invasion, official full invasion of Lebanon. Of course, as I predicted, it was not going to happen officially tonight. But they have already started more airstrikes.
Okay. Is Hezbollah leader dead? Mm. This is an hour ago. This is just they're not reporting, they're just showing footage.
More. Hold on, we'll see. They fired some rockets like an hour or two ago, and it wasn't that many rockets. It was like 65 in an hour.
جليا يحيى الآن، ولذلك التخوف لدى الإدارة الأمريكية ليس فقط على أمن إسرائيل ولكن على أمن مصالحها في الشرق الأوسط وقواعدها منتشرة
It's too noisy.
Properly articulate to make you mad, you'll get madder.
Juenu, if the slaughter ever ends, do you think Israel will eventually, with the help of its lackeys in Western politics and media, be able to
آمده است. پاسخ می تواند این باشد که 3 میلیارد سال پیش جو مریخ توسط خاک این سیاره سرخ جذب شده و حیات احتمالی در مریخ از بین رفته باشد.
Do if they had a destruction on their border.
The only channel with bad audio, what is this Times Now World? But where's the original? This audio is terrible.
Necessary action to protect our people so that Israeli families can leave their homes safely and securely. Moments ago, the Israel Defense Forces carried out a precise strike on the central headquarters of the Hezbollah terror organization that served as the epicenter of Hezbollah's terror. Hezbollah's central headquarters was intentionally built under residential buildings in the heart of the Dahia in Beirut, as part of Hezbollah's strategy of using Lebanese people as human shields. On October 8th, Hezbollah started attacking Israel. After almost a year of Hezbollah firing rockets.
Why did Israel wait a year to stop this nonsense?
And suicide drones at Israeli civilians. After almost a year of Israel warning the world and telling them that Hezbollah must be stopped. Israel is doing what every sovereign state in the world would do if they had a terror organization that seeks their destruction on their border. Taking the necessary action to protect our people so that Israeli families can leave their homes safely and securely. Moments ago, the Israel Defense Forces carried out a precise strike on the central headquarters of the Hezbollah terror organization, built under residential buildings in the heart of the that Hezbollah must be stopped. Israel would do if they had a terror organization that
it plays in a loop. So where's the original? Moments ago. Okay, but where's the original? Let's see this. This is an hour ago. Directly on CNN's webpage.
Let's go right to Barak Ravid. He is a CNN political and foreign policy analyst and Axios politics and foreign policy reporter. Barak, What do we know about Nasrallah's fate?
Well, what I hear from Israeli officials is that Israeli intelligence had, I think, very strong indications that Nasrallah was in the compound that was attacked. And Israeli officials say that they think that whoever was in the compound when it was attacked has a very, very, very small chance of surviving. So I think although the Israeli intelligence doesn't know for sure that Nasrallah was killed or what his fate is, I think the Israelis have let's say, a very strong assessment that he was hit in this strike and likely have been killed.
It's a lot of big buildings that he took down, and obviously it seems as though there are probably a lot of civilian casualties as well. What do you know
No, there's no civilians. Everybody left.
about why Israel decided to strike at this moment?
So the decision was made on Wednesday, the decision in principle, when before Netanyahu traveled to New York, he had a security meeting, and the decision there was to take out Nasrallah, but they needed an operational opportunity, and this operational opportunity only arrived today. But the rationale, from what Israeli officials tell me, was that the Israelis tried for a long time to force Nasrallah to decouple himself from Hamas leader Yahya Sinwar and Hamas in Gaza and agree to some sort of a separate settlement that will end the fighting in the north and will allow tens of thousands of Israelis to go back to their home. Nasrallah refused to do that. He doubled down again and again and again. So an Israeli official told me, we just decided that maybe it's time to take him out of the decision-making process, and then maybe, by that, we'll push Hezbollah to decouple from Hamas.
I think we are in a full-fledged war. There is no doubt about that.
Mm-hmm. Mm-hmm. Mm-hmm.
All right, I'm joined here by Moeen Robini, a Mideast analyst, to talk about Israel's devastating strike on the Israeli suburbs, which they are claiming, or we'll talk about this in a moment, to have taken out Hezbollah Secretary General Hassan Nasrallah. We'll also talk about the threat that the IDF has been making to the Dahiyya suburbs, ordering a massive evacuation of civilians, presaging what could be a Gaza-like assault on southern Lebanon. So, Moeen, first of all, thank you for joining me today.
Good to be with you.
So the way that this works on YouTube and wherever else people are watching this is that many of you, by the time you're watching this, may know a little bit more about the precise outcome of this.
Israel had targeted a Hezbollah chief Hassan Nasrallah in a massive blast in the capital of Lebanon, in Beirut. I want to go to my colleague, Jumana Karachi, who has been following this story for us. Jumana, it was your initial reporting and your headlines internally here at CNN that caught our attention over an hour ago now when you were reporting massive blasts. Tell us now what we know. 6 buildings leveled. The casualty numbers are just coming in. What are you seeing and hearing?
Well, as you mentioned, Bianna, we've just heard from the Ministry of Health that at least 2 people were killed, 76 were injured in those massive blasts that targeted Beirut's southern suburbs. As we understand, of course, from the Israeli military, the target of those strikes was the leader. They say it was a command center, but what we understand from my colleague Jeremy Diamond, according to a security official, a senior Israeli official, that the target was the leader of Hezbollah, Hassan Nasrallah. And that is the big question right now. What if Nasrallah was there, if Nasrallah survived? We understand from the senior Israeli official that the Israeli military is working to verify that.
What's up, guys? We're back with something crazy here. I always thought about putting wings on a Cybertruck. Ever since I saw it, I was like, oh, F-117 stealth fighter, geometric, angular. And my my father actually has a Cybertruck. He got the Foundation series, and I just like I make things fly, and I'm like, you know what? Let's make a Cybertruck fly. I try it as hard as possible to not have a vertical stabilizer, but you need to have one. That's about as small as I think I can go. I can make it out of acrylic, so you won't see it, or you'll see it less. The power to weight is not great. It's a 50 millimeter.
I don't think there's a problem as far as stealth is concerned to have a vertical stabilizer. It's no different than the side being straight. I don't see the difference.
Fan in there. It's about.
You could argue that the waves could bounce here, but as long as all your angles are the same, there should be no issue.
1,200 grams, so it has enough air to maintain flow. 100 force live. There is 50. Kind of like, see if I can't get enough, and I should be able to get enough. Can you actually first baseball field, some wheel covers, has a stop and too much versions. Oh, sir, I am gonna there's no wind, so I just couldn't get enough weight. I had to add literally, and this thing is pretty bomb-proof.
Oh my
It's
God!
fun seeing the thing fly. I mean, that's amazing. Now the EDF is basically exposed. I'm gonna trim it down a little bit so that it flies a little more level.
It's hopeless.
It's kind
Yeah,
of
the
fun.
wings are too small. The engine, it's not fast enough, so there's no lift, and there's no angle. The wings are not angled, so there's no self-stability.
Flying. It's fun seeing the thing fly.
Israel had targeted a Hezbollah chief Hassan Nasrallah in a massive blast in the capital of.
All right, I'm joined here by Moeen Robini, a Mideast analyst, to talk about Israel's devastating.
Hey everyone, as you all know, I enjoy debunking charlatans more than just about anything else, and today we have a 2-for-1. We will be looking at Brett and Eric Weinstein, the self-appointed leaders of the intellectual dark web. I've never debunked brothers before, so let's have some fun with it. Again, in case you've never heard the term before, these guys are prominent members of the so-called intellectual dark web.
Yeah, I don't like. I mean, they're both nice and everything, but yeah, they're both a problem in terms of being charlatans. I wouldn't say charlatans. I think they believe their own nonsense.
The term actually having been coined by Eric himself.
The group of people I'm increasingly hanging out with is the intellectual dark web, which is emerging.
The dark web, of course, being the place where people hire hitmen and watch kiddie porn, so it's not really the most sparkling.
Stop it.
All right, I'm joined here by Moeen Robini, a Mideast analyst, to talk.
Wow, this looks interesting.
Never, ever, ever be in the barrier, right? No matter when you measure it, it's never going to be there because.
That's interesting. Everyone is asking, no one is answering. Is he dead?
Hello and welcome to P Guru's channel. I'm your host Sri Iyer. This is a special broadcast. It's about 2:45 p.m. local time. That is specific.
It doesn't matter. Israel, if CNN says that Israel says that he's dead, then that's it. He's dead. Where is this? Is this like London? Anyway, he's probably dead, most likely. It's a good day. As he spoke, Netanyahu speaks at the UN just as Hezbollah leader was eliminated in airstrike.
Today, Prime Minister Netanyahu gave another very powerful speech in the House of Lies itself in the United Nations, the largest organization which is the greatest support of terror around the world. And ironically, while he was speaking, Israel bombed deep in Beirut, and we are still waiting for the
good stuff.
Kill someone that's my brother, then it's gonna happen.
Through Saturday and Sunday, scores of other targets were also hit, some close to the Syrian border. At the same time,
Those last couple were enormous.
في ذات الوقت يتحدث عن
Who has touchdown?
And let's switch back to that liftoff view here as we are about to end. Hello and welcome to another Saturn Aerospace stream. Today we have a very important launch, Telesto IFT-3. I'm Aviation, lead interplanetary here at Saturn Aerospace, so stay tuned for this monumental launch. Telesto is our biggest crewed vehicle. Its primary use is crew. It will eventually
nominal power consumption rates prior to switching to internal power.
It will eventually deliver crew to Rhea, which will be in orbit for crew on the pad, light up. Wings attached to them so they can glide.
Propellant. Propulsion.
Propulsion stuff.
This is LD. We are go to continue count.
Interesting how they set this up. This looks so real. Everything about it is so real.
All right, T-minus 10 seconds here.
There's no countdown.
T-minus 10, 9, 5, 4, 3, 2, 1. Lift off.
And there we go. Telesto is ascending into the skies. Laggy as usual.
Okay.
Those are precious, valuable lives. The minute you find out about any of them, I would hope to God that you feel empathy towards them, and you go, "That's a real person. They were at a concert. They were on
Saturday." And Ad Manta. And
Yeah, whenever Israel or the U.S. kills a bad guy, an enemy, so the Young Turks are talking about the innocent, the children. But whenever somebody from the American side, from Western civilization dies, like there's no talk, nothing. They're quiet. Okay, I think it's a good day. Anyway, I'm gonna go take a break and I'll be back. All right. That's it.